This one? Well, that answers the question of whether the mic is on. It's on. I would like the accessory to connect. No. So I want to not use screen mirroring. There we go. Almost. Cursor. Where's the cursor? Well, I might just go with it. Okay, we're going to live with the surrounding Chrome of Chrome, actually. Okay, so good morning, everybody. Welcome to Flutter and Friends. Now, Lukas kind of spoiled my first sentence. I was going to say, some of you may know me, but he assured you all that you all know me, so hopefully no one's feeling bad if they don't. But yeah, my name is Labenz, and I have the great pleasure of working at Google on the Flutter Developer Relations team, which amongst other things brings me all over the world to conferences like this. And I've given a fair amount of technical talks in my day. So despite having stood on stages like this and having talked to folks like you, when Lukas asked me if I'd stand on this stage and give this talk, I was actually pretty hesitant. I wasn't sure if I'd have anything worthy of a keynote stage to say. So let me make this a little bigger actually real quick. Oh, it just literally nothing's happened with that? All right, let me try again. Are you sure it's not in slide mode? I think it is. Yeah, I put it on slide mode. Yeah, see there, slide number 2. I will try again. You, do the thing. And then you, come here. Okay. I don't know why it's not going full screen. Maybe this little button right there. Oh, we're so close. Nope, function F didn't do it. Enter full screen?
I guess we'll see the slides like
yeah. It refuses to cooperate. As my dad says, technology, it'll never catch on. All right, now we need the cursor back here. Oh, lordy. No, wrong way. What is the monitor arrangement? I don't know. No way that I move the cursor will it escape this space and go back. No, is it up? Lordy, it's none of them. System settings, we're gonna go old school here. Look at the monitor arrangement. No, I can't get to the monitor arrangement window. Oh my gosh. Now maybe I can escape confinement? No.
You have to exit full screen.
Oh, I'm in full screen mode. See, this is the worst Mac OS feature in the world. It is terrible. No, I still can't get out. Oh, here, okay, I've got it. Okay, so it's this, no. Well, this didn't happen in any of my rehearsals. Let me tell you. Displays. Wow, this is great. Maybe I'll do a Mac OS update while we're at it. Arrange, oh, this is the arrangement? That's crazy. No wonder. Go. I have a theory that if I do this and go back here, and that's pseudo full screen, partial screen, some might say. Okay, where the heck was I? What was the last thing I said? Yeah, I wasn't sure if I'd have anything worthy of a keynote stage to say. So my first talk idea was going to be something like the future of widgets, which I was pretty excited about. But my whole team swatted down that idea and encouraged me to think bigger. Now, obviously, I did eventually confirm with Lukas that I would come here and give this talk, because here I am. And that was only after I accepted the fact that anything I talked about would obviously have already been covered by someone else in a way better way in some other keynote, but at least I would talk about it in my own words, and that would be somewhat original. So I set out on my grand adventure to find the one topic to rule them all, and in the darkness bind them. And I was researching and brainstorming with teammates and watching other keynotes and whatnot. I knew the right topic was out there, I just had to find it. And you've already seen this slide. So as I was researching, I was watching the 2019 PyCon US keynote to see if I would get any inspiration from it. And lo and behold, I did. The speaker was a man named Russell Keith McGee. He's an old teammate of mine when I was at Zapier. He's a Django core contributor. And interestingly enough, he's actually the primary maintainer of a library called Beware, which you can basically think of as Python's version of Flutter, even though Beware is actually way older than Flutter. Anyway, Russell's talk was great, and he made this one comment while he was setting up the age of Python. And he said this 5 years ago, so you can increment the numbers in your head, as they say, never do math on stage. And he said, Python is 28 years old, but it took 10 years to gain any decent recognition in our industry, and then another 10 years before we had all of this, which he said with this grand gesture out toward the 1,000+ person audience in front of him. And I thought, oh my gosh, Dart itself is only 11 or 12 years old, and Flutter's 1.0 release wasn't even 6 years ago yet. So it feels like we've been doing this for a long time, and we wish our community was even bigger than it is, but measured against the arc of successful technologies, we're actually all still early adopters. And if we are all still early adopters, then everything is still in front of us. Now, just because stuff is in front of us does not mean it will actually come to pass. When Python was only 10 years old, its next 20 years of success was not at all guaranteed. Python had to do a lot of things right to become the ubiquitous language that we know it as today. And I think a lot of what Python had to do, or Python, as Australians say, which I'm a little jealous of, it's a very cool pronunciation, I think a lot of what they had to do correctly revolved around their culture. So that means for us, the culture and the shape of what it means to participate in Flutter is in our hands. We control what that means, and I do mean our hands, the people in this room, the people in the rooms with you at future Flutter events that you may attend. And so then I realized that I had my topic. I knew what I wanted to talk about, how kindness and empathy within the Flutter community will shape our future success or a lack thereof. Now, the reason that I was watching Russell Keith McGee's talk, 2019 PyCon US, like maybe it seems a little bit random, is because before Flutter, Python was my community. And if you don't know much about Python's community, that's fine. No community is perfect, but Python's really bends over backwards to make sure that everybody feels a sense of belonging, whether it's technically while they're at home coding or socially on the road at events. And so while I was falling in love with Flutter in the winter of 2018, and I was starting to say these really dramatic sentences like, I think I want my next day job to be about Flutter, I also knew that I didn't really want to leave the Python community, or at least I didn't want to leave those attributes of kindness and empathy. But obviously, something made me take the plunge, because here I am. And I still remember the day and the moment that I emotionally committed myself to Flutter. Fast forward, it was now the summer of 2019, and I was working on my side project basically every day. And I had Andrew Brogdon's I/O talk on adaptive navigation up on my side monitor. And it was about handling different navigational patterns between iOS and Android within one app. And as a longtime fruit company device user, the thought of Google acknowledging iPhones and iOS and those users and their experiences and the value of Google engineers accommodating those experiences absolutely blew my mind. And a few weeks later, I applied to Google to work on Flutter. Now, had my first formative experience with the Flutter community instead been some kind of snarky post or someone dunking on someone else, I might not have ever gone as deep into Flutter as I did. I might not have ever applied to Google. I might not have ever moved to California. I might not have met anyone in this room. Like, my whole life could be different. And as any GDE that I've interviewed will tell you, I end every conversation with a reminder that all of your online interactions could be someone's first encounter with the Flutter community. And this doesn't mean that we can't have disagreements and report frustration and whatnot, like please do report things that frustrate you. As a Flutter team, we know that we need to fix those things. But there's always more and less constructive ways to have any of those conversations. And so as I look at our still youthful community, my charge to all of us is to continue to build the most kind and empathetic corner anywhere in technology. But I mean this in more ways than you might think. So the first way, I think, starts from the Flutter team itself, where we've got to set the tone, and we try our best, imperfectly, I'm sure, to always lead with developer empathy. And really, the Flutter project itself is entirely rooted in empathy. Like if you think about the fact that it's just free and open, that means any developer, anywhere in the world, with nearly any laptop that turns on, can start building their dream project and get it in the hands of users on nearly any device. And Flutter has long known that we could never just kind of go hide away in a cave and come back down from the mountain with a perfectly designed UI toolkit engraved in stone tablets. Like, no, we need to hear reports from you all from the field of what it's like to learn Flutter, what it's like to build apps with Flutter, and what it's like to compete for contracts with Flutter. And so that's why we're doing our best to always listen to what you all have to say, and then we adjust what we're doing, our roadmap, in response. Now, to say nothing of all the excellent documentation that the actual engineers building Flutter write alongside their code, Google also pours a lot of resources into explaining Flutter, both written and video. So to help folks learn Flutter, Google employs some of the best marketers, some of the best technical writers, some of the best developer advocates, and also one of the world's biggest clowns. Now, those things are all fine, but this next one is actually really important to me. And it's best summed up by this old phrase that representation matters. Now, this is one of the greatest American athletes of all time. Obviously, her name is Serena Williams. And she is the winningest player at both the Australian and US Open. Her 367 singles matches victories is most all time. And her 10 majors victories, just counting after the age of 30, which is like when all of my joints stopped working, is most all time. And also, you all know that if you pair her with her sister Venus, the two are one of the most dominant doubles teams of all time. But to me, one of the coolest things that Serena Williams ever did in her career was to inspire an entire generation of black girls to play tennis. And my wife was one such girl. And to this day, tennis is her favorite sport and probably her favorite hobby. And she will be the first to tell you that if she had not grown up watching Serena Williams, she might never have realized that tennis could be for her. And representation matters just as much in tech, a space unevenly distributed across race and gender. And as any advocates for underrepresented groups will tell you, members in those groups are all too often offered mentorship, but not sponsorship. And that's because it's so much easier to just give someone some passing advice than it is to have skin in the game for their success. So on the Flutter team, we try hard to invite community leaders to help us present episodes of our flagship YouTube series. That's because we not only want to sponsor those individuals, but we also want the rest of the world to be able to look at Flutter and see themselves. So this is just a sampling of some of the ways that the Flutter team tries to kind of start the conversation with empathy, imperfectly as we do it, I'm sure. But those efforts would be a candle in the wind without buy-in from the broader community of you all. So I propose that as individuals, for all of us, there's two main ways that we can continue to uphold kindness and empathy as first principles for Flutter. And the first is from developer to developer. So to start, if you are already advanced in your career, great, pay it forward. A great example of this is, of course, Hump Day Q&A, who I'm sure all of us know, the weekly live stream from Simon Lightfoot, Scott Stoll, Randall Monroe, Danielle Cox, John Weesey. And every time I've done this, I say those names in a different order. But that is just a great weekly effort from all of them, an incredible investment of their time. There's also a lot of community-run Discords and Slacks that you can join, and you can even answer questions in those. And if you do answer a question, make sure that the person who asked it really feels just how happy we are to have them. Developer-to-developer empathy also matters in how we file issues, not just on the main Flutter repository, but on all the repositories behind our favorite packages. And again, this is not to say that we can't have opinions and disagreements and even API designs that we dislike, but I would call on all of us to maintain some humility in our own ideas and remember that in any given conversation, it actually could be us that is wrong. Now, at the risk of getting a little philosophical, the great astrophysicist and philosopher David Deutsch, who's my personal intellectual hero, said the following: "Mistakes are the normal condition of humans. All we can do is try to find them. Maybe not destroying the means of correcting errors is the heart of morality, because if there is no way of correcting errors, then sooner or later, one of those will get us." Now, he's talking about how to design societies and the survival of the human race and big fancy stuff like that. But I think the same principles apply to us. I agree that error correction is the most important subsystem in any knowledge-generating system, because it is inevitable that some of the knowledge we generate will be wrong. And the only way we can sort out which of the knowledge we generated was wrong is if we remain open to the idea that any given piece of it could be wrong. And in the tech industry, I think we risk more than just personal stasis if we are locked in our own errors. I think we risk tribalism. And thinking about that reminded me of another quote, this time from someone that you've probably heard of before. So Yoda from Star Wars said, "Fear is the path to the dark side. Fear leads to anger, anger leads to hate, and hate leads to suffering." Now that may seem like it has absolutely nothing to do with what I'm talking about, but I think that us developers have our own form of this sequence too. The only difference is ours does not start with fear. I think ours is basically the opposite. It starts with hubris, or not entertaining the possibility that it could be us that is wrong. So for us, I think it goes, hubris is the path to the dark side. Hubris leads to arrogance, arrogance leads to toxicity, and toxicity leads to defensiveness. And defensiveness and tribalism, that's our dark side. That's when we as individuals start to tie our identities to our teams. And this is why I think there's so many holy wars in tech. Software engineers tend to be fairly smart people, but sometimes I think we get a little too excited about ourselves and we forget that each and every one of our opinions, no matter how dearly we hold it, could actually be wrong. And then in our arrogance, we dunk on each other online, which builds resentment between individuals and communities and entrenches everyone's opinion about everything. And this is a well-known phenomenon in psychology. It's called belief perseverance, or the backfire effect. And it's when someone's belief and confidence in their own ideas actually increases even after encountering clear and compelling evidence to the contrary. And what's super interesting about this is between strong arguments, medium arguments, and weak arguments, strong arguments tend to perform poorly because they trigger this backfire effect. Weak arguments perform poorly because, well, they're weak arguments, so they can't convince anyone of anything. And it's those medium strength arguments that actually enjoy the most success convincing people of new ideas. And so this is why I think the antidote to all of this is humility in our own ideas. Because try to imagine like firing off your saltiest take online while also holding on to the idea that it could actually be you that is wrong. I don't think any of us could actually do that. Now, thankfully, this is not a plea into a storm of despair. I think the Flutter community is already exemplary on these fronts. But this is just the kind of developer-to-developer empathy that I want to uphold as Flutter's ideal. Now, the final aspect of empathy that I want to talk about is from all of us developers to our users. Flutter's singular founding principle and kind of core value proposition is around reaching users where they are on whatever devices they use. But what if we change that to something like reaching users however they exist in the world? So obviously here I'm talking about accessibility, but accessibility itself is not actually everything. There's another concept in product design called inclusive design, which is a superset of mere accessibility. And if inclusive design is a new term for you, that's fine. Interactivedesign.org defines it like so. Inclusive design is an approach to create accessible products and experiences that are usable and understandable by as many people as possible. It goes beyond accessibility to consider users' diverse needs, backgrounds, and experiences. So I think if we don't consider inclusive design principles in our products, then we risk unknowingly being a developer who says, I use Flutter to reach as many people as possible all over the world, but is unaware of the invisible and silent ending to that sentence, which says, as long as they're perfectly able-bodied and look exactly like my engineering team. Like, yikes. So a common counterpoint of accessibility and inclusive first engineering is that for any resource-strapped startup, just getting an MVP out the door as fast as possible is all that matters. But, and it's true that we don't want to let perfection be the enemy of the good. But I want to convince all of us that effort spent in this direction doesn't just help a subset of users, it helps all users. So the really fun thing about inclusive design is that following its principles is the act of identifying friction that you may think only a subset of your users are experiencing, but in removing that experience or that friction just for them, you tend to broadly improve your product and end up removing friction for everyone. And some refer to this phenomena as like universal design, which is that act of thinking you're helping just a subset of users and like, whoa, accidentally helped everyone. Other people think universal design is kind of its own principle or its own framework and approach for product design. Like, I'm not a scholar on all this stuff. I probably don't have the terms totally correct. But for the rest of this talk, I'm just going to refer to all of this as inclusive design, which is the conscious effort to include all of your users. So, and I do want to return to this idea of not letting perfect be the enemy of the good, as the English idiom goes. Perfect inclusive engineering is probably not possible, and chasing it can prevent you from ever releasing your app. But there are some easy kind of ideas that I think all developers should keep in mind for the entire lifecycle of their project, from idea inception to development, testing, and releasing. So we're going to take a look at 8 different principles of inclusive design, including real-world examples, and some of them really ended up kind of escaping their original scope and helping everyone. And then we'll also look at how we can apply each of these to our apps. So the first principle of inclusive design is called equitable use, which is defined as providing the same means of use for all users, which encourages inclusion and lessens stigma. And a great example of this in real life are these little ramps and sidewalks called curb cuts. And they were originally only designed for folks with wheelchairs in mind. But guess who else uses them? Everyone. Parents pushing strollers, travelers dragging luggage, cyclists hauling their bikes. And what's beautiful about this design is that it allows everyone to engage with the sidewalk in the same way by seamlessly crossing the boundary, instead of segmenting how folks in wheelchairs are supposed to interact with the sidewalk. So how do we ensure equitable use in our apps? Well, the first thing, super obvious, localization. Few things are more powerful than letting your users interact with your software in their native language. Adjustable font sizes, also very important. They allow anyone with degraded vision to just still read everything clearly. And in Flutter, to make use of the operating system's default, all we have to do is not override the text scaler on the media query. But you probably have to actually change the font size in your phone and then run your app again to make sure your UI doesn't totally fall apart. The second principle of inclusive design is flexibility in use, which is defined as accommodating all by offering choices for users. And to me, a quintessential example of user choice is audiobooks. If you can't read a book, then you can listen to it if you'd like. And this was originally only designed for visually impaired folks. But again, guess who ends up using audiobooks? Everybody who's busy, either driving to work or folding laundry or washing the dishes, and also wanting to read a book. And the key takeaway here and the insight is that whether because your vision degrades or just because you're busy, all of us will have visited upon us at some time in our lives the experience of wanting to read a book but not being able to point our eyes at it. So removing friction for those people ends up removing friction for everybody. Another great example of this is closed captions. This is basically the exact opposite of audiobooks. If you can't hear a video, then you can read it. And to say nothing of, some people leave these on all the time because you can't hear any dialogue in TV and movies these days. Beyond that, anyone who's just listening to a video in a loud public space, or maybe listening to a video quietly in bed next to their sleeping partner. And just think, without closed captions, we wouldn't know how Spock was sobbing here. Like, is he sobbing existentially? Is he sobbing like ironically? Think of the confusion. So how do we do this in our apps? Well, pretty obvious, but just light mode, dark mode. Some people prefer one, some people prefer the other. Flutter offers light themes and dark themes. We just have to define them. Another great choice for user flexibility is to integrate with voice command systems like Google Assistant. This can allow a distracted or occupied user to still complete an action in your app. And you might not even make them open your app in the first place. They might be able to complete an action while just kind of walking by a smart home device on their way to the kitchen. I also think a low-key, pretty sneaky avenue for user choice is keyboard shortcuts. And to explain this, I always think about my own kind of mobile form factor bias and remember that some users, especially maybe older users, may prefer larger versions of the UI or even like printed versions of the UI. Well, I'm not saying we have to make printable versions of our apps. But 10 years ago, I was DMing a game of Dungeons and Dragons for my family, and I made this primitive digital character tracker. And I showed my cousins and uncles who were in the game this thing, and I was really surprised to hear one of my uncles ask why he couldn't print off his character sheet. And the simple answer was because I didn't want to look up the browser APIs, and so I didn't code it into the system. But the better answer was that because to me, the whole point of this little character tracker was to not have a character sheet. But for him, even though the screen maybe looked shiny and was ostensibly cool, it was less accessible and less tangible to him. He wanted to be able to take notes on the piece of paper. And so if you imagine, I often imagine users only engaging with an app that I'm building on their phone. But that doesn't mean someone's not going to download it on their tablet and want to attach a Bluetooth keyboard and mouse. And for that, of course, keyboard shortcuts really completes the experience. So the third principle of inclusive design is called simple and intuitive use, which avoids complexity while ensuring all users can understand how to use or operate. Now this one seems pretty obvious, like, no duh, have a simple app. Great, Craig. But arguably here, the stakes may be highest of all. Now for those of you who don't know, this is a picture of the control room in 3 Mile Island, a nuclear power plant in the United States that suffered a near catastrophic accident in 1979. Thankfully, the overall engineering quality of this plant prevented it from totally melting down and exploding like the Chernobyl plant did 7 years later in 1986. But root cause analysis of the 3 Mile Island incident still revealed tremendous problems. Now, the investigation was led by a man named Don Norman, and he's the person who coined the term user experience. And he wrote in his report, thanks to the catastrophically bad control room design, and you just love the shade here, like the shade is so thick you could freeze to death in it, the operators were unable to understand what was going wrong. They continued making bad choices as the plant and the men who operated it were not in sync. The plant was not designed for bad decisions that men can take, and men couldn't understand what the plant was doing in a crisis. Obviously, this paragraph was written before the really revolutionary idea of women having careers had arrived. But look at these panels. Don Norman found that there were, and I quote, 0 organizing principles for how controls were designed or grouped. In one specific panel, he found 14 different meanings for the color red and 9 different meanings for the color green. So obviously the staff at this plant had no chance. Now ultimately, it did not melt down and destroy the entire state of Pennsylvania, which contains it. So you might think this is like a no blood, no foul situation. But to this day, America is still afraid of nuclear power. Think about how far ahead the whole world could be on climate change if that panel had just made sense. It's crazy to think about. So now that I've made keep your app simple seem like a matter of life and death, what do we do? Well, first, include user experience experts in your process as soon as you can. Obviously, all projects have a limited budget and can't do everything, but in my experience, time spent with UX experts up front easily pays for itself by avoiding wasted and duplicated work. But for some more concrete, quick wins, a great practice for clear and intuitive UIs is to just have a clear and consistent information hierarchy. Anytime you establish an expectation somewhere in your app, treat that as sacred everywhere in your app. Similarly, consistent icons and controls allow a person to very quickly and easily parse what's going on the screen, greatly reducing friction of using your app. Now, the fourth principle is called perceptible information, which allows all users to access information regardless of ability, experience, or literacy, which maybe on the surface feels like kind of a tall order, but in the real world, I think pictograms are a great example of this. Don't speak English? That's fine. This sign still perfectly communicates its message. Now, humorously enough, not all signs are created equally. This sign, which comes from OSHA, the United States governmental body for worker safety, means like beware of the fish. Maybe don't drink the water, like did that kill the fish? The tree has no leaves, is that involved? You know, presumably there's some kind of ecological disaster here, right? But I don't know whether it's already happened or I'm about to cause it. So anytime you lean on pictures or iconography to convey information, just make sure that it actually does convey information. And as for this sign, I never did figure it out. It's probably explained in an OSHA manual somewhere, but it does not convey information to me. In our apps, perceptible information, first and foremost, has to be legible to human eyeballs. So that means, first, sufficient contrast. And you know this when you see it. I haven't decided yet if that pun was intended or not, but interestingly, orange on orange can have great contrast if one is light and one is dark. Meanwhile, orange and green, two very different colors, can have terrible contrast if they're both dark. Human eyes are funny things. Another huge one here is just legible fonts. Can you read what this says? Like maybe if your English is really, really good, but handwriting fonts can present a significant challenge to anyone using your app in not their native language. And this is especially true because even though we celebrate localization, we're obviously not going to be able to localize our app to every language in the world. And for me, as someone who's newly learning Korean and is still completely terrible at it, I'm horrified at the thought of encountering some cutesy, very demure handwriting font in Korean that makes all the Hangul look different, and like now I have even less of an idea what's going on. So the fifth concept, or the fifth principle of inclusive design, is tolerance for error, which minimizes hazards and the consequences of mistakes. So for a real-world example here, I think of just any slow-moving automation that gives users a time to react, or self-correcting systems like safety shutoffs. And in apps, my mind always just goes to reversible decisions. So any kind of recently deleted section, also persisting form progress in local storage. This can prevent an accidental backwards navigation from jettisoning everything that someone has typed into all the different form inputs from memory. We all know that losing work is literally the worst thing that can ever happen to you. Relatedly, not all actions can actually be reversed. If you have a hard delete in your database, then you cannot easily restore that record. So if someone is about to take a destructive and irreversible action, just a confirmation dialog so they know exactly what they're getting into. The sixth principle of inclusive design is low physical effort, which is pretty self-explanatory. I would also give this one high marks for not requiring a lot of physical effort to understand, very internally consistent. And in the real world, I love this example, electric toothbrushes. These were only designed for folks with limited dexterity in mind. But it turns out no amount of human dexterity can compete with an electric toothbrush, so everyone uses these, including myself, because I definitely want whiter teeth. Within apps, I think a great example is animating state changes. This reduces the amount of focus and attention that users have to pay every single 16 milliseconds to see what actually changed. Another great example is easy password reset flows, social login, potentially email auth links, or even just pass keys to help users never have to think about a password in the first place. Now, the next principle is around the size and physical space that's taken up by a product. And this is defined as providing easily navigable space that users can reach and manipulate. Classic example, I think, in the real world, sit-to-stand desks. How tall are you? Great, this desk accommodates that height. Would you like to stand part of the day? Great, this desk accommodates whatever you just said. So obviously, these are great. A nice digital example of this is iOS's trick of double tapping on part of the screen and having the whole UI shift down so it's now all accessible to your thumb. And this really helps anyone using your phone or using their phone with just one hand. And again, you already know how the pattern goes. This could be because they always only have one hand available, or their second hand might just be busy holding their child or a bag of groceries. So at one point or another, all of us will only have one hand available. Now the last principle, this one is my own. The previous 7 I found on a list somewhere, but then I tacked this one on. And I call this one global thinking, and my very profound definition for it is avoiding assumptions and biases with an eye toward product decisions that may alienate users. And for decades, one of summertime's most common activities, putting on sunblock, worked better for people with lighter colored skin. And this isn't because sunblock didn't physically work and block UV radiation on dark skin, it just left a chalky residue while it did so. And across the beauty industry, from sunscreen to clothes and makeup, just awareness of the genetic diversity of customers ends up elevating the experience for everyone. Now, within our apps, I think allowing folks to express themselves more directly and authentically is a great step here. And it allows everyone to feel like an app really wanted them specifically. So this is called the Fitzpatrick scale, and it replaced the old emoji set of just those yellow tone emojis that I always imagined were inspired by the American cartoon The Simpsons, but I don't actually know. But everyone knew that that yellow skin actually meant white people. So now everyone can feel like they are expressing themselves in apps. So these are the 8 pillars of universal design: equitable use, flexible use, simple and intuitive UIs, perceptible information, tolerance for errors, low physical effort requirements, flexible use of physical space, and global thinking. And I think that keeping these in mind from the beginning can help us design products that truly delight all of our users. Now, of course, there's great guidance on this online. You're not alone to figure it out yourself. This is some of Google's accessible design documentation, and obviously Apple has a lot in its own human interface guidelines as well. And you don't have to write down these links. These are some of the most easily discovered pages on the internet. Now, all of these tips are good and fun, but how is a team supposed to identify where these sneaky sources of friction are coming from? We've talked about a lot of different vectors in which people can be outside the kind of heat map of your engineering team. But just to focus on assistive technologies for a second, in my experience, the best way to do this is you've got to test your apps with people who use assistive technologies. So if you don't depend on a screen reader yourself in real life, for example, as I don't, then it's just very hard to imagine where friction is going to come from for somebody. You can't close your eyes and think really hard and just divine where it'll be. And then you might think, well, I'll turn on the screen reader and close my eyes and try to drive my app that way. But if you've never used a screen reader before, then that task is just going to feel impossible. And like the problem is intractable and nothing that you do will actually help anything. But the human brain is amazing and can get good at anything. And people are really good at driving their phones through alternate inputs. So you've got to watch someone skilled with a screen reader use your app. And then if you observe friction, don't just make it a P4. Take it seriously. If it's just a matter of the screen reader not reaching a certain part of your UI, then that's probably pretty straightforward. But we've seen here that other problems are open-ended, and creative thinking and solutions in those spaces can help everyone. Flutter is so special. For me, it's really been a story of come for the hot reload, stay for the community. But we're still undeniably young. By Russell Keith McGee's count, we still have 14 more years until all of this. Now, I think we're going to get to 1,000-person audiences long before that, because the development community is just cooking a lot hotter than it was 20 years ago. But along the way, all of us contain in our hands the power to define what it means to be a Flutter developer and what it means to use a Flutter app. Thanks so much, everyone.
All right, thanks a lot, Craig. And we have a few minutes now before we will have, I think, the coolest job title you can possibly have. Slava is called the Dart Uber TL. He's the Uber team lead of Dart. And there is a lot of breakfast left. And that will be thrown away if you don't eat it. And we don't want to waste food, right? So eat as much breakfast as you can. And
yeah, so please, you can take 5 minutes and go grab breakfast and then come back. We won't start the presentation before that.
Well, you don't start, I start.
Yeah, the MacBook Air is a cup.
Yeah, I mean, I like my Pro, but it's just like so big and so big. Yeah.
It is, I know. It is. Try to squeeze in so that you don't sit in the edges so that we can fill up the rows.
Yeah, I know.
And this is M3, like this is faster than my M1 Pro. Still some people coming in. Grab a seat quickly because soon we're going to start. All right, what a morning, right? Whoa, not what you plan, but what can you do? So, one very important thing, don't smoke in the toilets. Somebody smoked in the toilet, put their little cigarette butt in the bin and was all on fire, so. I don't know who you are, but I will find you. And if you have ordered Majid's book, you can get that over at the swag table, and you can get a lot of other things there too, like there are some Supabase shirts, some Flutter shirts, some Flutter bags, yeah, lots of different things to choose from. Yeah, we will have a little bit of a shorter lunch since we have lost a lot of time now, but I think we'll manage. And now over to Slava. Give it up for Slava.
Okay, it works. Okay. Good morning, everyone. I see people are still coming back from the fire. I'm not going to wait. I'm going to start. Okay. Hello, everyone, and welcome to my talk. I must admit, all this evacuation caused a lot of stress to me, and stress is not good for your memory, especially short-term ones. So I completely forgot what is in most of the slides. I'm going to use that as an excuse. Also, I have a very severe case of slide edidis, which means I'm constantly adding slides even 5 minutes before the talk, and there is never time to finish all of them. So it's not going to happen today. It never happened before. That I cannot blame on fire. Okay. My name is Slava. I work on the Dart team. I am overall technical lead for the Dart team these days. So if you have any questions about Dart, future, or have suggestions about the evolution of Dart and so on and so forth, come catch me. I will try to run away. If you manage to catch me, you get your chance to ask a question. I will answer it truthfully. Okay, so without further ado, no, actually, like, you know, when you do talks, you always need to start by telling some story from 20 years ago or so. 20 years ago, I was already pretty aware of the fact that I would be a programmer, and I could program some C, and I wanted to level up my game. So what do you do 20 years ago when you want to level up your game? Well, you go to the bookstore and you buy a book. So I went to a bookstore and bought this book with 400 pages, and I never got past the first 50 or so. Did not stop me from becoming a better programmer, though. But on this first 50 pages that I managed to get through, there was one thing that really caught my attention and stayed with me through all these years. It's this quote in the foreword to the first edition of that book. It's a quote from Benjamin Worf, who was a linguist. And he said, "Language shapes the way we think and determines what we can think about." And somehow it really stayed with me. And I constantly return to this phrase. I think that's what maybe got me into the programming language development to begin with. I'm not sure, but now if I look back, maybe that's the thing. This is something known as the Sapir-Whorf hypothesis, so linguistic relativity. It postulates that the language that we can speak, it impacts the way we perceive reality. So if you speak Swedish, your perception of reality is different from people who speak, I don't know, some other language like C++. Anyway, so I think there is actually truth to it, because the way programmers approach things is very based on the fact which programming languages they know and have experience with. So there is something true to it. The whole thing is quite disputed, and it's called hypothesis, not a fact, but still, I thought it's an interesting thing. People, though, realized it way before Worf. Worf lived like in 20th century, but 500 years before, there was a guy called Charles V, the Holy Roman Emperor, who said this, that he speaks Spanish to God, Italian to women, French to men, and German to his horse. I guess, yeah. If you translate this to the modern language, then if I go now into the, like, between the rows and start asking you, I probably discovered that you speak Dart to your mobile apps or your mobile phones to create an apps, and your backends are written in some other programming language. It's just a modern version of this thing, and I think it's wrong. And when you go to some social media platforms and read the threads about Dart, you discover a lot of people who say, well, I have discovered Dart through Flutter, and I really love it, and I have created many apps with Flutter, but my backend is still trusted Node.js version 0.6 because it's just the best thing since sliced bread. And it also parses JSON 1,000 times faster, according to this post I found on LinkedIn. Usually I get upset about things when I see this. Mostly I get upset about the jsonDecode being so slow, not about the fact that people use very strange arguments to choose what to develop their backends with. But anyway, let's take it as a face value and try to figure out, is this nasty jsonDecode actually slow, and what can be done about it? So first we need to figure out what we are comparing, right? The guy on Reddit, that was actually a fake post, which I created using the Chrome DevTools. Don't try to find it. But anyway, so that hypothetical guy, which is kind of an average of all Dart developers on Reddit who don't like developing server-side Dart, he compares JavaScript, like Node.js versus Dart. So what do we have in JavaScript? Well, in JavaScript, we have this JSON.parse thing, which you give it a string and you get back a JavaScript object or array or primitive. In JavaScript engine like V8, it's usually written in C++. You can go read an implementation if you know C++. That's where that book from the beginning comes quite helpful, if you can get through it. In Dart, the story is a bit different. You have this JSONDecode method. You give it a string. You get a map, a list, or primitive back. It's implemented in Dart, so you only need to know Dart to read it. So you go to that source file that I put on the slides and read it, and then you start searching a little bit around, and then you discovered, well, wait, there is one more file like this, and there is one more file like that, and there is one more file like that, and there is one more file of that. There are 5 different implementations of the same JSON decoding thing. Well, that's where the Dart's multi-platform nature comes really and complicates things, because Dart can run on many platforms. And it does not target just native execution, right? You can run it on JavaScript or on WASM, for example. And web is complicated. It has this JSON.parse thing, which is the fastest thing you can get on the web, but it does not give you back things that you want from it, it gives you just JavaScript objects because that's what it's made for. And if you are trying to run Dart on the web, you want to get back something different, so you need to spend time converting what JSON parse gives you, or you need to create your own JSON parse, which would be slower, and so on and so forth. So it's complicated. Life is complicated in general. So I'm not going to talk about web, because if I talk about the web, I need maybe 2 slots or 3 slots. I will focus on native for the purpose of this talk. So I'm going to talk about jsonDecode on native, which is also known as Dart VM or Dart native runtime, whatever you call it. It's the thing that runs Dart on the mobile phones when you use Flutter, on desktop when you use Flutter, or if you use Dart from command line. That's the thing I'm talking about. Okay. And I'm going to put everything up front. I'm not going to hide anything because also I might run out of time. So the most important thing goes here in the beginning, not at the end. I am going to share with you my biggest secret, how I can optimize everything using 3 easy steps. So the first step, I measure things. And if it's okay already, I just go home and drink wine to celebrate. It's easy, right? If it's not, okay, I identify some unnecessary work and remove it. And then I repeat this process. Sometimes I have a break for the dinner and sleep and so on, but eventually I have not yet met a problem that I could not have optimized using these 3 steps. So this is the only thing you need to carry with you home today from this talk, and you will be okay. Okay, let's apply this to the problem of JSON decoding. So you start by making a measurement, right? So you write a small benchmark. This is Dart code. Everybody can read Dart, right? Who cannot read Dart? Success. So you have some input. You run jsonDecode in a loop n times, and then you compute how many nanoseconds you spend per decoding 1 byte of input. Of course, you need to select n large enough so that actually the measurement becomes stable and so forth. I'm not putting this auxiliary logic on the slide. This is JavaScript. That does the same thing, measures how many nanoseconds per byte you spend decoding the same input. And I found a large enough file, 64 kilobytes of GitHub events, whatever the thing is, and I put it into this benchmark, and oh, it's actually, the people on Reddit are almost correct. I mean, it's not 1000x, but there is a factor of 3-4 difference in this performance here. So it's bad. And if your server really spends most of the time decoding JSON, then maybe you're doing something wrong. But in that case, it would actually come to matter, right? So if you spend 10% of your time decoding JSON, then a factor of 4 difference means that you actually could save at least 8% if you sped it up, right? Napkin math is very good. Of course, if it spends 1% decoding JSON, then you all can optimize it by 100 times, and you're going to save much, right? Anyway, so does it mean we should rewrite the JSON decoder that we have in Dart into C++? Maybe. Maybe not yet, right? I want to live in a world where I can speak Dart to my horse, and the horse runs as fast as it can and decodes the JSON. So that's just the best world to live in. So I'm going to try to look at how we can get Dart performance on this JSON decoding as close as we can to the numbers we see on JavaScript, which uses just C++ to decode JSON. But before that, remember that recipe that I talked about. You need to figure out the unnecessary work that you are doing. So there is actually unnecessary work we are doing here that is kind of invisible. So what does JSON decoding do? You take a string, you make a map out of it. But if we stop here already and ask ourselves, where does this string come from? Is it granted to us from some revelation? No, it is granted to us in the network of some, in the stream of some bytes, so it comes from the disk or network, right? So first you get some bytes, then you decode them into a string, then you decode string into a map. That's already a bit on the nose, right? It seems like there is one step that's a bit redundant. So what if we removed this string decoding from the equation and we tried to go from bytes to map directly? In JavaScript, there is no equivalent of it. The API is just in terms of strings. But in Dart, There is also no equivalent in the API. But there is a hidden thing inside the library. It's not visible to anybody. Nobody knows about it, not documented anywhere, maybe. But already 10 years ago or so, people thought about this redundancy. And they said, well, if you make a normal JSON decoder, well, most likely you want to decode strings. Okay, that's fine. You get a normal JSON decoder. But if you make a UTF decoder, and you make a JSON decoder, and then you fuse them together, there is a method fuse on these decoders, which kind of glues two things together. Then, surprise, what comes out is not just the thing that pipes from one decoder into another. It's actually a short circuit decoder that can decode JSON directly from UTF. And they did it, but they did not document it anywhere. So when I tell this exists, people are surprised. Okay, so let's focus on optimizing these things first. So we rewrite benchmark a bit. So we create this fuse decoder. We take now bytes as input. And we measure how long it takes to convert it. We also update the JavaScript benchmark the same way, because in V8, or in JavaScript, you would also have to decode bytes first, and then you have to give it to the parse method. So I added a function to the V8 which exposes this functionality. In the normal JavaScript API, there is no such thing. So you could use some node, like whatever, two-string UTF-8 things. God knows what methods are there, but I did something to measure. So. And what we see here is that the performance on the V8, which now captures the true amount of work you have to do, it increased a little bit, like you spend more time per byte because you now need to do also UTF-8 decoding. The performance on Dart did not improve much, so it's disappointing, right? When I first did it, I was like, this really smells bad. Something is rotten. So I started looking closer. What does looking closer mean in this context? Well, it means profiling. And if you develop Flutter, then you usually profile with DevTools. I work like on my trusted Linux desktop, so I profile with perf, which is a tool that comes with Linux that can be used to profile things. It integrates with kernel. Kernel exposes underlying like hardware counters, probes, God knows what, and you can record the traces and look at them. It's very useful for low-level profiling. So I profile it, and then I just look at where the time is spent. And okay, there is some parsing. It's all some English words that we can understand, and digits, and the sign of a %. So it all makes kind of sense. But there is one thing that is very strange here. There is the access to the uint 8 list, which is a list of bytes that we have given to the decoder. It's an indexing operator that returns a single byte from it. So I would not expect that to be in the profile, because if you have to call that thing for each single byte that you're trying to read, it's not going to be fast, definitely. So the mental model which is very important to have when you try to optimize code, you need to look at the code and kind of try to reason. What operations do you expect to be fast and what do you expect to be slow? So in this mental model, I don't expect bytes access to be slow, right? Because otherwise something is fundamentally rotten in this world. So it should be some sort of instruction sequence which it does not involve calls. It should be just some bounds checks, because Dart requires you to throw an exception when you read out of bounds, and a load, not a call. But something went wrong here. So if you want to verify that this indeed the case, that actually byte accesses don't involve calls, you can try to make a small example like this in Dart, which just creates an array of bytes and then tries to read a thing from it. And then you do some incantations. You don't have to write them down in your notebooks. You can just go to slides later and check. And you look at the disassembly that you get back. And this is from the Mac. So this is ARM64 disassembly. It actually down there, right before ret, like return, there is a LDRB, which is load byte. So that is great. It actually loads the byte directly. Before that, there is a huge amount of instructions that is associated with the bounds checking. But this is what we expect. There are no calls involved here. So something must have went wrong in our benchmark. So we invoke our trusted Dart compile with more magical flags. And what that gives you is when you profile and you look at the disassembly, you can now see some comments around, so it makes it easier to read what the thing is doing. And then when you see what it is doing, you find the hottest spot, which I highlighted for you here with 25%. 25 is higher than 0.16 or 4.16, right? And right next to it, there is this call instruction. So compiler somehow failed to have access to the list of bytes, be this direct access that I showed on the previous slide. Instead, decided to go with just this generic call, get me an element from any arbitrary list in the world. And that, of course, is not going to be fast. So at this point, we look at the code. And it's a Dart code, as I said, so it makes it easy for us to read. And we discover that there is this chunk JSON parser in the SDK, which is abstracting away over the underlying representation of data. There is like generic implementation of parsing, but it is not written in terms of getting a byte from a byte array or getting a character from a string. It is written in terms of calling a method of an abstract class called getChar with no implementation, which gives you a character. And then there is the whole this implementation in base class. And then there are two subclasses, which one provides the implementation which reads from a string, and then one that reads from a byte array. And when I saw that code, I was like, not good, not good. So this code illustrates two performance anti-patterns in Dart, which if you want to write performant code, you should avoid. I'm not saying that you should avoid it everywhere. Somewhere it makes sense for maintainability and stuff like that. But if you are in the mode where you want to squeeze a nanosecond here, nanosecond there, this is the pattern you should avoid. You should not create base class which provides completely generalized generic implementation which uses a bunch of small methods which subclasses implement, because when you do the compilation and you end up in a situation when this base class has multiple subclasses which are instantiated in the program potentially, you end up with the base implementation which is still very generic, and it will just do calls for all the small operations that you hoped to get specialization of. And the second performance anti-pattern is that if we look back on that code, we see that it's written in terms of list of int. It uses a little bit of uint list there, but the type annotations on the code, they're just list of int. And that is also very bad. If you work with bytes, you better annotate your static types in a way that helps compiler and put like uint 8 list or uint 32 list precise type data types in the places where you work with raw data. So I made a patch in March, and that thing removed these two performance pitfalls from this parsing. What I did is I made a mixin instead of a base class, because mixin methods are copied when you apply the mixin, and I also changed the types in a way that say, well, I expect actually to be called with the uint8 list, then I use this directly, because APIs are all written in terms of list of int. This is kind of remnants from God-forgotten days of Dart 1. And if I got something that is not uint8 list, then I copy, because the underlying implementation expects this uint8 list, and it will work faster if it works with uint list. And almost nobody passes real list of int. I mean, it would be very wrong to have a list of int to represent a list of bytes, because you waste a lot of storage. Like it's 4 or 8 times larger than uint list, right? Anyway, so when I did it, it improved it by 30%, right? So that already shortens the gap between Dart and JavaScript, and it was just a pure Dart change. I did not need to change compiler or anything. Okay, there is another performance anti-pattern here which is kind of hidden, and in general you should prefer to parse bytes, not strings. So it's a bit strange that we even provide that JSON parser from string as a convenience. The reason is because in Dart there are two implementations of string to save memory again. There is like all the strings that are Latin 1 characters only, they are represented as a 1-byte arrays essentially, and all the strings that require full 2-byte representation, they represent as 2 bytes. if you write the code in terms of like just parsing some arbitrary string, compiler cannot figure out which type of string you pass. It can be 1 byte or it can be 2 byte string, and it, as a result, cannot really produce a good code. And just, you can do the same trick. You can learn how things look in the compiled code by writing small snippets of Dart code and looking at what assembly it produces. Like for example here, I wrote a code that just calls a method with a constant string, and then it asks for the first character of that string. Well, compiler was smart enough to just load a constant as a result. There is no string, there is no indexing, there is nothing, because it was just a constant string. It was smart enough. So I added a little bit of fork to hide the fact that I'm loading from a constant index. And that created more code. But the string itself, it still figured out it's always the same string, and it always just loads a byte because that string is a 1 byte string. So you need to put even more fork in there, like say you don't know where string comes from at all. And then it produced so much code that it doesn't even fit on the slide. Like it tries to figure out what type of a string it gets, and then it loads either 1 byte or it loads 2 bytes. Okay, anyway. Let's go. So that is the moral of this, even if you did not pay attention to every single assembly instruction on the previous slide, is that you better not parse strings. You better parse bytes if you get bytes. Okay. Okay, now get back to the JSON decoding. So I was reading more assembly instructions and whatnot, because that's what I like to do. I figure out that AUT compiler has some issues with ordering the machine code that it generates. And it puts the code which is not part of the loop, or like the code that should only be executed once during the loop, like for example this return or throw statements, it puts it into the loop, which is actually bad for the CPUs. So I thought, haha, if I fix that problem and I take that return block and I make it move to the end, that would improve the performance greatly. So I laboriously spent, I don't know how much time making changes in the compiler and improving this block order. The resulting code got nicer, but the improvement was hidden in the noise, maybe 5% on a good weather when there is no wind. So I went back and started reading the code, and I found the code like this. It has some switch, different characters, so it tries to parse this JSON and tries to figure out, is it white space or not? Or code like this, which it goes through the string and it tries to figure out, is it a character that continues a string or it's a character that stops a string? This code has a lot of comparisons and a lot of decisions happening to it. So maybe there is a better way to write it. So what it's trying to do, read the character and categorize it. Is it a white space? Is it something else? So the solution for this problem is to use a lookup table. You can make a table for each possible character. There are 256 different bytes, right? You can encode this information to that lookup table. Is it a white space? Is it not a white space? So on and so forth. And then you can use a single thing to write that whole loop. So you basically go through the whole string and then check, is it the end of string? And this covers many different characters in one go. And there is some magical string. That's how it looks like to categorize these characters. Does not matter. There's an explanation I will skip. Anyway, so it helped a bit, but I discovered that the compiler still struggles with that code. So for example, this if condition, it was producing bad code. It should be just one instruction on the Intel CPUs on ARM64, but it was not. And then bounce checks, which I showed before, they are actually causing issues already at this point because the loop was getting so tight. And there was some other overheads in the loops that were also causing issues. So I landed more changes, and that improved by another 30 to 40%. So I removed some bounce checks. Okay, I'm cheating here, but it's inside the SDK, so you don't know about it. I improved the compiler, and finally landed change that used this character attributes map. So, and then I looked at the profile again, and things started getting very flat. So now the overhead is spread across the whole parsing implementation. And, but there is a lot of stuff that deals with hash maps because you produce hash maps. And I looked at that and I realized that the hash map is being built one key at a time. So you rehash the map periodically if it reaches the capacity. That takes time. So and then did another change which also gave some improvements that basically as you go through the map, you count the keys but don't hash it immediately. And then you go in one go and you produce the map of the known capacity. And that got us to 3.5 nanoseconds per byte. So we're still 30% slower, but it is a huge improvement from where we were before. And if we look at a bigger corpus of benchmarks with JSON parsing, we see that somewhere we're even faster than V8, like 84% of the V8 performance. Somewhere we're pretty close. Somewhere we're still slower. So I was looking more on this, and there are different possibilities to optimize it. You're getting into really obscure things, and complexity starts skyrocketing. So I thought, maybe I need to rethink this. And yesterday, 3 in the morning, I was rethinking this. And I applied this. So the fastest piece of code is the one which does not need to run, right? That is the thing. So there is this C++ library called CMD.json. It's written in C++. And now so I exhausted the Dart things. Now I'm going back to the C++ things. It is a very cool library. It uses SIMD, which is the single instruction multiple data CPU stuff, to blaze through the JSON. You give it many characters at a time. Because in Dart, I'm forced to do one character at a time, categorize, move to the next character. With SIMD, you can do many, many characters at a time. So, and it also has this capability of doing lazy parsing. So if you don't ask it to give you a specific key from the map, it just skips that key completely, just finds where the, for example, closing brace is, and off it goes. So it goes very fast. What if you use it in Dart? And we are coming here to the conclusion. I don't know how much I overrun, but anyway, I want to finish. Once in a lifetime, I'm not going to stop. You can take this from my cold hands. Anyway, so yeah. I created a simple Dart package, and I will actually publish it on GitHub at some point, maybe tomorrow. The famous last words, so in a year you will ask me why it's still not published. And then in that package I put the SIMD.json library. It's just a header file and a C++ file. They're just 2 files. I put it in the source. And then I made this hook/build.dart file. Who knows about that file? Well, you are too advanced. Almost nobody knows. Yeah, and you're like, what the hell is that file? Never heard about this hook here. What is that secret technology? It's something called native assets. If you have not heard about that and you have to deal with native code, I suggest you hear about it now. It's a thing that we try to revolutionize. No, we try to streamline the way you add native code to Dart packages. So you don't need to deal with strange Flutter plugin templates and Gradle and CMake and God knows what on Apple stuff, Cocoa Pods, deprecated Swift, whatever, does not matter. So all of that goes away. Instead, there is this Dart file there. And before we get to that Dart file, so you make some simple C code, for example, like this, which uses SIMD.json API. Okay, you put it in the C++ file. You make a simple Dart code which says, well, I have that function somewhere. It's external. It has this Dart signature and it has this native signature. Please hook it up together. And then you make this hook build.dart file which says, I have this library which has this C++ code inside and it has this compile flags and it's written in C++. And that's it. Then you run Dart enable experiment native assets. You run that Dart code. That would build C++ code magically transparently underneath. And it would just run. If you run Dart enable experiment native assets build, it would produce an AUT compiled code, which also has next to it all the compiled native code from the C++ libraries you included. And it's made extensible, so it can be Rust, it can be Go, it can be whatever. You can provide different extensions to that build system. Anyway, so I used it. Then I made some things. Does not matter. You can go to the thing, read it later. So what I did is that I looked again at this thing. We removed string and we go from bytes to map directly. What if we think about the next step? What happens to the map? Well, map you usually pass to X from JSON and you make real objects from it. So maps are also, just like string before, they are intermediary objects to create real objects from them. So what if we remove that step? So what if we just take a list of bytes and make normal objects from them? And I wrote some code, and I wrote some more code, and it does not matter. But I've skipped this. There is a bunch of low-level stuff. I don't want to go into detail. You don't have capacity to understand it right now anyway. You're like thinking, coffee. So it would be nice if it was all just hidden, if I could write macro. I was sitting there at 3 in the morning and trying to write a macro, discovered there are bugs that prevent me. There is, we don't support augmenting fields, for example. So I could not write it as a macro. So I just made my own DSL in the night. And from this JSON description of my tweet feed layout, I generated a bunch of Dart code. And magic! It now can parse this. It's a different JSON file, but before it was also quite slow on the same JSON file. It's actually the one that is slowest to parse with Dart now. And now it's only 1.6 nanoseconds per byte. And it parses everything still. But here's the thing. So that benchmark just parses everything, creates Dart objects from the things, but it doesn't actually access any of the data. So as a compiler engineer, I always think, well, it would be actually good to screw this program up and not parse any data. And TreeShaker actually knows that you're not calling any getters on these methods, on these objects that you create. So you're not accessing any data. But it does not give this information to SIMD JSON, which is responsible for parsing the JSON. So it dutifully parses everything that I asked it to parse. So, but it turns out, hidden in the Dart SDK sources in the MD file, there is a magical pragma, which we created specifically for this reason, because we were thinking about, for example, protobuf deserialization, how to tree-shake parts of the protobuf deserialization code, which is responsible for parsing protobufs that are never accessed. So we created this VicTROFs, and it does not matter how it works, but it works. So I changed my generated code to check if a user is actually, if the user code is actually accessing the specific fields. And if it is not accessing it, then I tell SIMD.json not to parse it. I just skip that thing. And it sped it up even more, because now it does not actually parse anything, because it just churns through this JSON and then says, whoo, and it just counts how many, for example, tweets are there. So it loads that information up, but all the contents are absent. But then if you, for example, start accessing created at date, then only that field will be parsed in this setup. Yeah, okay. So now closing remarks from this. What do you need to learn from this talk? You better have a mental model if you're trying to optimize things. If you don't understand what you are trying to optimize, you cannot really make any improvements, right? Okay, that is a truism. That is too banal. You need to look for things to stop doing. Like everything that I have done was about removing things that are unnecessary. And when people, for example, come to me and ask, well, my code is running slow. Well, you're doing list.expand.map.reduce.toList. And this could be actually written in 3-line simple for loop. And then you write it like that and it's 100 times faster. Well, maybe you could hope that compiler can do it for you and for you file issue about it. But you can also spend just 3 minutes rewriting that super high-level code to a slightly less high-level code, and it would run much faster. Maybe jsonDecode is now in the current SDK, after all these fixes, is actually doing all right. Like 3 nanoseconds per byte is 300 megabytes per second. Maybe your server does not need to parse so much JSON. I don't know, is it like TikTok, I code it in the base 64, and that base 64 is put in the JSON and streamed to your server? I don't know. So maybe you should give Dart on server a try if the jsonDecode was the only thing that was stopping you from it. And also, I know I would like everybody to write as much Dart as possible, but with features that are coming now down the pipe, like native assets, you can do pragmatic amalgamation where you amalgamate Dart with your other favorite language. I would prefer that Dart still is your #1 favorite language, but if your #2 favorite language is C++ or Rust or Zig or Pascal or whatever Asian, anyway, so yeah, so. But don't reinvent the wheel. Reach out for the native assets and embed them into your package. And that's the last slide. I will stop talking now.
Wow. Thank you so much, Slava. Like, he gives insights that you cannot possibly get anywhere else.
You can get them from me on Twitter.
Yeah, exactly. Follow him on Twitter. Scan his NFC badge, and you'll get directly there, because we have already coded it onto yours. Right. So we've just realized that we have forgot to properly tell you where the second stage is. So there's almost nobody there. In the exhibition area over there, there is a big spiral staircase going downwards. So you just go all the way down there. It's like 3 floors down, and you will get to that stage, because there are lots of great talks there too. And unfortunately, we don't have time for questions with Slava now, because somebody smoked in the toilet. But you can just go and ask him out there. He's super friendly. So now we have just about 2 minutes until the next talk starts, and here we will have Renan's talk, and downstairs we will have... Did anyone check the schedule? Majid's talk is downstairs. Thank you. Oh, but it will be fun. Yeah, that's a classic too. Who wants one? Who wants one?
Just give to the people in front. They never get.
Yeah, for sure. Yeah, a big one or a small one? All right, let's get started. And if you don't know Renan, he's one of my best friends, but that is not why I put him on stage. It's also because he's a code magician. He can do really cool stuff with shaders, and he's also in a team building a cool game engine called Flame. I don't know if anyone heard of that. But today, he's here to talk about WASM, which will revolutionize Flutter web.
Yeah.
Over to you, Renan.
Okay, thanks a lot. Hello, everybody. If you don't know me, that's me. That's my face on the screen. I'm originally from Brazil, but I live in Portugal. I'm a GDE for Flutter and Dart, but most importantly, I work on some open source stuff with a collective that we call Bluefire that includes that mad guy there that is the main maintain of Flame, and Flame is one of the packages that we maintain at this little collective thing. We also have Luan here that's going to talk about 3D games later today with Flame. I also work at Superlist for app, but as lots of Flutter developers, I started with a different context before adopting Flutter. In this case, was front-end web. So I started back then in 2013 as a web developer, and that's why this subject interests me a lot. Did anyone here, I think Flutter is old enough for people to have started their careers in Flutter. Do we have anyone here that started their careers in Flutter? Oh, yeah, no one. So I can assume that everybody here came from a different language, different framework, even sometimes from the back end. So that's pretty interesting. And I hope there are some more people like me that came from the web because, well, instead of going directly to the point, why not just to rant a little bit about something? So as someone that was used to the web and now working with mobile apps, there's some things that have been pushing my buttons lately. And I had this amazing idea of a quick mobile app that I could just publish on, solve my problem and publish on the store pretty quickly, and I'll have something useful. But, well, first we start with, well, development. So the things that we study for, the things that we go to mostly to conference for. So this is where we go and learn about solving logical problems, architecture, state management, all the libraries and everything. It's the fun part, is where we solve the problem. And it was pretty fun until I got to this point where I had to publish my app. And yeah, so it was a long time since I didn't start from scratch and publish a new app, particularly in this case, to the Play Store. But I mean, I figured, the biggest problem, the biggest difficulty for us is on developing, right? It's actually solving the problem. Deploying will not be a problem, right? Hell no. So the problems started. So things like Apple Play Store now is asking for 20 testers for if you're not a company to get verified, and you have way more things. And about a year ago, I published a game for a smartwatch, and to publish a game for a smartwatch using Wear OS, believe it or not, you need to have a tablet screenshot. So it doesn't work at all. But all of this just made me thinking, why you have to comply about this, you know? And then, well, after all of these difficulties, all of these weird things that we have to go through to get our app in stores, I manage it. It's on the Play Store. It's published. People are downloading it. It's super fun. But then I went to brag to my family meeting. Like to brag, I have something in the Play Store. You should go ahead and play, and even plays on smartphones too. And my aunt said, "Okay, let me find that out." And she pulled this bad boy here, and I was like, let's go to the App Store, and then go do all of that over and over again. And this reminds me of something that I read that really resonates with me when I was reading some kind of the mission statement of Shorebird or something like that. And in the very beginning, they say, well, mobile app development is broken. And if you don't know Shorebird, they really help you on code push. So it's publishing updates faster. But we still, anyhow, have to grow through the gates that we have these gatekeepers. And yeah, Flutter helps us a lot on the development part because at least that we don't need to solve problems twice when we talk about mobile, but when it comes down to deploy, there's no help. We are still have to comply with those rules. But services like Shortbud and CodeMagic really help on the distribution of the app, but the problem is still there. So, you know, why we go through this? Why it's almost 20 years into the smartphone age, and we still didn't figure out how to, ship mobile apps. And only if there was something that could allows us to just skip those gatekeeping things. And I started remembering about my past as a web developer and why didn't the web, why didn't PWAs take off that much? Why do we still have to download mobile apps for gym or for parking lots or things like that? Well, when I hear about, especially on Flutter, when it comes down to Flutter Web, people are restrained a lot from Flutter Web because, well, the performance is visibly different from native. And sometimes, if you really want to ship something with a great performance, today it's easier just to go native rather than overly optimize your web app, because shipping web app with a native-like experience is extremely hard and sometimes impossible. But yes, here we go. But remembering those times of developing for the web, it's nice to understand how everything started to when it comes down also to smartphones, smartphone apps. So I don't know, was a surprise for lots of people. I don't know if it's for you, but when the first version of iPhone was introduced, there was no app store. And the way that was promoted, the very release of the iPhone was through web apps. So web apps was a free way of shipping apps for the iPhone without SDKs, without restrictions, without approvals. This was the initial view of iPhone. So it was interesting how the thing have turned. And the web is still not the main way that companies have in mind when to ship apps. And sometimes they don't even need a store placement. They could go a web app. But yeah, performance is still kind of a constraint there. So yeah, as a web dev, this was the things I started. I kind of showing my age a little bit with MooTools and jQuery. And in this past years, the web have been evolving a lot. In the past 10 years, development of web it's completely different from what it was back in 14, 13, 15. Did anyone ship a web app before 2015? Before React? Yeah, things are way different now, right? It's a whole different platform. It's crazy. And I like, and there are some secret sauces that were like the personality of these changes. Okay, so historically speaking, the web was basically divided in these three languages that we call markation languages like HTML and CSS, and JavaScript was the way to have a runtime dynamic web app, and it still is. But one thing that caught my mind is that, well, folks on the JavaScript world that are shipping web apps, they love JavaScript, but very few of them really write JavaScript, For example, React, you have these weird XML things in the middle of the syntax. This is not part of the JavaScript syntax. So the other folks have looks a little bit more like a normal thing, but if you paste this on an HTML file and open a browser without any transformation, it won't run because it's not the proper grammar for either HTML or JavaScript. And without mentioning the fact that lots of people put types on their JavaScript and call that TypeScript. But of course, that's not going to run on the browser. So the secret sauce of the reality of JavaScript and web development today is transpilation. So this means that the JavaScript in the browser is essentially a runtime language. For all means that very minified code that's popped out of Webpack or Flutter Build Web, it's something that is not meant for humans to read, but only machines. So it's essentially a compiled code. Could be a binary, essentially. Okay, but with that in mind, we go back to Flutter. And well, this is pretty much what happens, what's generated from your Flutter web app when you build Flutter build. So everything that's Dart basically goes to this huge JS file that looks like really not meant to be written by humans, totally minified, and we have something else back there, which is the Skia, which is the graphical engine. It's built to a different file that's not JavaScript, it's WASM. Well, let's talk about WASM now. Good. The theme of this talk, finally. Well, remember when I said about these three guys? Well, we have a younger brother. It's WASM. WASM, our WebAssembly, is a standard by W3C. That's meant to be a runtime language on the browser, an alternative to JavaScript. If you're using JavaScript not for scripting or as basically a runtime, you can maybe consider a WebAssembly. And the standard includes two types of files. There's a text description of things, but it's also compiled to a binary that's very much more compact that can be run by browsers in runtime, just like JavaScript, with the difference that is way more lower level. So the level of abstraction between the language and machine instructions, in theory, is way smaller than JavaScript, so it should be way faster. But, well, if WASM has this intention to have been built to substitute JavaScript, why we're still having this huge JavaScript file there? Well, it's because on the first version of WASM, it didn't include any specification for garbage collection. And languages like Dart really rely on garbage collection for this. Okay, so languages like C++, Rust, AssemblyScript were made for with manual memory management in hands, so they can take that advantage of that performance edge that we have over JavaScript. But garbage collection languages, well, they could have an option, which is to ship a garbage collection with the application, but that could increase the size of the whole bundle in the end. So we lose a little bit of the advantage that we have in the load time over JavaScript, and also it would be wasteful, because if there is one thing that's fast these days, are the runtimes, the VMs on browsers, especially on the garbage collection side of things. So it would be wasteful. We could just have two garbage collections running, one that you had to ship with your language, and one with the VM that's sitting there, is not being used. For example, V8, which runs JavaScript too, includes a great garbage collection logic there, but has no way to free memory that was allocated for WebAssembly, because there's no way to track what references are being used or not. So there enters an extension, which was a series of proposals on the WebAssembly specification that managed to include a way to VMs to see what's going on the memory that's managed by WebAssembly modules and free unused references. So in other ways, it would be WebAssembly. It would include garbage collection, in fact, in WebAssembly. Okay, but the circuit for that is how WebAssembly manages memory. So there is this concept in the first version of WebAssembly that's called linear memory. That, for simplicity's sake, is just one contiguous block of memory that could be reserved by the WebAssembly modular as we go. So, for example, if you allocate some memory for some numbers during your calculation, it would be added to this linear memory, and when the modular is not running anymore, the whole block goes away. So the one secret about this type of memory is that it just grows and doesn't shrink while the module is running. So this was a problem because in languages, such dynamic languages, we would have to be really smart on what new memory we allocate, and it would not be okay. So on these new specifications, we include a new type of memory that's called the heap memory. So now we have a heap specification for WebAssembly that includes essentially the specification types that then would be understood by the runtime. So for example, on WebAssembly, linear memory, we only have integers and floats, basically numbers, but with this new specification, we include references, type references. We can have function reference, so basically you can pass functions as parameters, for example. And then we also have nice types like structs, vectors, arrays, structs that can imitate data structures of other languages, depends on how you compile. For example, Dart, you can translate an object to a structure in WebAssembly. And this is a game changer because languages like these now could be compiled to WebAssembly if GC is enabled on the clients. And it's great because these are very popular languages for UI. And UI is a big thing on the web. And people end up using JavaScript because they don't have garbage collection. And why? It's sometimes not very ergonomic to split your compilation to either WASM or either JavaScript because you need specifications, different specifications for performance here and there. So WASM to this day was just a very specific thing. When you see a bottleneck of performance on JavaScript, then people would usually consider WASM then. Or if you already had a modular in either C++ or Rust, it would be really easy to compile, but not entire application, and especially not UIs. At least not normal people wouldn't do UI in WASM for now. But with these languages, especially Dart with Flutter, we have almost for free, with some kind of changes, a whole application with a very nice UI running with the promised native performance on the web. So this is really great because, well, native performance and a free and kind of open source platform that could reach virtually any device in the world is the holy grail. And Flutter, especially Flutter Web, comes from being this little ugly duckling that's of the Flutter family to be probably the most awesome way of shipping Flutter apps. But how this works here? So remember this is what happens now. Everything you write in Dart is compiled to a garbage collected version of WASM, one big modular. Includes the framework, parts of the web engine, and obviously the code you write. And then the smart people at Google created a bridge, a C++ bridge, to talk directly with Skia, and the C++ bridge is compiled together with Skia to one new web renderer, which is SKWASM. It's WASM, right? I don't know. That's how they speak, and I really like that pronunciation. And they didn't go with Canvas Kit because Canvas Kit is something from the Skia engine that includes bindings for the whole of the Skia API via JavaScript. And here we don't need any layer of JavaScript because you have a WASM to WASM calling. And it was really, really interesting to see this happening. And we are going to talk a little bit more about SQUASM later. Yeah, but now, when you build with Flutter Web, you have these outputs. We still have the old JavaScript build because, unfortunately, WASM is still something that is not on all browsers. In fact, only on Chromium browsers you have WASM GC available, and Flutter does a little testing in runtime to see if garbage collect WASM is available, and if it's not, it falls back to the JavaScript build. This happens on Safari, so every iOS device will not run WASM, unfortunately, for now, but they are working on it. Firefox theoretically has support for WASM GC, but there's a bug in the off-screen canvas that breaks Flutter specifically. So Flutter WASM still doesn't happen there, but let's hope for them to fix that little bug soon. And then we can have WASM on Firefox. I personally use Firefox over Chrome, and I really wish we could have all of this performance there. Okay, but for us, Flutter developers, what we should care about, okay? Besides all the outputs, the new outputs that we have, there are some things that we have to be mindful. First one, WASM support is still experimental, so especially SQUASM, which is a whole new graphical engine, you could see some bugs in the visual resulting of a build with WASM. If you do, file a bug, please. The folks at Google are working a lot on it. I had to file some. I have to file some after some testings I did, but you can see that it's still early stage thing, but you already can see the performance there. Okay, so what changes for us? On the code base, changes on the code base, and this is what got me a lot. Like without warning. My fault because I didn't read the documentation first, but people shipping web apps with Flutter relies a lot on this kind of technique, which is conditional imports and exports. And if you're using the HTML identifier, yeah, you should be really careful with that because that's false for JavaScript, for WASM builds. So I/O keeps the same. If you're using HTML, it will go for web, but not WASM builds. And JS interop will go for both. So if you are interested in supporting both WASM and HTML, use JS interop instead of HTML as identifier. Okay. Oh, all right. So I saw that now I was looking to the next slide and not on the current slides. I'm really sorry for that. Okay, let's go. We had also some changes here on the HTML front. So if you want to access DOM APIs, for example, you're not going to use the Darja HTML package library anymore. You're going to use rather a package. This is interesting because the web is evolving a lot always. So new specifications comes, renames happen, deprecations. And we don't want to release a new Dart SDK version every time that happens. So we have a package web that's separated from the SDK that can be versioned faster. It can be iterated faster as the web evolves. So it's pretty cool that they had that. And they also probably going to follow some of the actual names of the APIs and not something that looks cool on Dart. There's also some other libraries that were not supposed to be used anymore, so you should use package web instead. And JS interop. So if you need interoperability with JavaScript, if you want to instantiate JavaScript objects and everything, you don't use those packages in the bottom anymore. You use JS interop. And oh yeah, this was an interesting case. I was updating a package for WASM, and accidentally I installed the JS interop package. Don't do that, because first, that package won't do anything. It's just a bogus release, but it's a GPL licensed one. So if you accidentally publish that somewhere, you could get in problems. I don't know how, but just be careful. And yes, of course, these changes has to happen not only in your code, but the codes of every package plugin that you have installed. So yeah, just have that in mind. If you have a package or a plugin in the pub, please migrate that as soon as possible. And if you have a good utility for when searching for plugins for WASM, you have this little filter is WASM ready, and it will filter out non-WASM ready packages. Okay, so for builds, this is the easiest part. You just put the WASM flag either on run with the new Flutter release, 3.25, and on 3.2.2, they started with also on the builds web WASM. And there's also these two options to ship source maps or not to strip the static symbols. This helps on debugging. So probably if you see a bug on the SKWASM, and you want to report to the Flutter team, use this little flag here, no strip WASM, that will give more information for the Flutter team to debug on. And on the server, okay, on the server, you have to add, you have to create the cross-origin isolation, which is a security kind of pack of good practices that are implemented in the web specification. That some of the web APIs are restricted to sites that doesn't allow cross-origin embeds, for example. So you cannot have like a YouTube embed on your website. In this case, you're always isolated to your domain, to your specific space of domain. So we have to add those to the server and serve the static files with these for WASM to work. Why? You know, so why does this happen? It's so annoying, because in some vendors you cannot even set headers. It's like a deal breaker for the GitHub pages, for example. So let's understand why this happens. The answer, of course, is on SKWASM. It's on the little modular that we ship with Skia. And why specifically this one has this? Well, it's, as I said, it's a new kind of a custom canvas kit modular. But this one, they're doing something different, and I found that very sneaky of Kevin of announcing this everywhere, because I think this is as important as WebAssembly for Flutter, that we are starting to have multi-threaded handling in Flutter Web with this thing here. So basically, SKWASM splits some expensive tasks to a web worker, and in the web worker, they use an off-screen canvas. That's why it wasn't run on Firefox, because of off-screen canvas. They use an off-screen canvas to pre-render or post-render things, and in this way, it improves a lot the timing and reduces junk in the web. So that's the secret sauce of the new performance on the web. But Skia really relies on shared memory, and when you have multiple threads like that, it's good to have. It's actually necessary to for all of these threads to access the same space of memory. And there's shared array buffer, which is one of these APIs that are very protected by this set of securities on the web that always only runs with cross-origin isolation, which is really annoying, but it's understandable because this is very powerful, and we don't want to cross scripting on this. I have access to this kind of thing. So yeah, because we have multi-threads, we need to serve with those two headers. But there are plans. I saw some issues from the Flutter team on planning to fall back to a single-threaded version of SKWASM in the future, if those security things are not available or if we opt out of it. But I think it's going to take some time because we're going to need some changes on Skia too for that to work. Yeah, so to activate these headers, some vendors allow, some vendors don't allow. GitHub pages and GitLab pages, they have a tracking issue for that, but they didn't have an update in a long time, especially the GitHub one. I hope that GitLab is gonna add that soon to enable shared array buffers. If you like doing Flutter games, maybe on itch.io you have an option on configurations. All of these is clickable, and I'm gonna release the slides in the end, so you can click. I'm gonna release on my Twitter, so you can check those links out with the guides on how to add those things. And I had a great experience with Cloudflare pages. I really recommend that. Super easy to set up, and you can have WASM on it. Okay, and was using Cloudflare pages that I added some of the examples, two of the examples I'm gonna show here. The first example of all of this performance gain, it's obviously a Wonderose that's was built. This example was built to showcase the beauty of Flutter apps, how they can be well animated, and well, we can access that via this URL, and it's really, really good to see both on desktop and mobile. Performance is amazing with all of the animations. And there's this thing too, because if you know me on Twitter, you know that I'm obsessed with mesh gradients. You could see on my slides mesh gradients everywhere. And I created an editor for mesh gradients using Flutter, and I decided why not to ship with WASM. And you can see if you run on Chrome, obviously, on this playground. I think I have it running here. Shouldn't be a problem to add. Oops, I'm gonna show in the end. And there's also this example that's a theory. That's this one I really, really want to show. Let's go for the editor. Good. So yeah, this is my little thingy. It's running on Chrome, so performance should be awesome with WASM. I can drag around. So this is like the widget I'm using here is interactive viewer, and actually this widget with the mesh gradient, it's really big. It's like a 4,000 by 4,000 widget with a mesh gradient. It scales down. So, and the mesh gradient is a bunch of complex graphical operations. So we are really putting SKWASM here to test. I could find a ceiling where it starts to fading, where the heap is overflowed a little bit with tessellation, but it's really hard to get there. And obviously, I'm not going to tell how to get there because you're probably going to need a very big mesh gradient here. And the performance is amazing. You can zoom in, oops, zoom in, and zoom out. And yeah, performance is just native. If you're running on full screen, you don't see the browser, you probably would, the user could be gaslighted to think this is native. It's crazy. But there's one that I really want to show that is something that I showed with Craig on Observable Flutter last year. Is a demo for another talk of mine that was about shaders and game development and Flame. And well, this is crazy. This is way, in terms of graphical performance, is way more, requires a lot more of the canvas APIs than the previous one, than the mesh gradient, because it's like six fragment shaders running on a game loop, so we are always cranking, always repainting. The Flutter rebuild system is always running, so it's not the most performance of things, but of course it's a game, so people expect their battery to go down when playing games, so it's fine. And this is on Firefox, and well, you can see that performance is not terrible. I think that's pretty much what I'm seeing here and seeing on my screen. It's running, you can see junk. It's not 60 frames per second by any means, not even 30. But it's there on Firefox without WASM. And I have some bugs on my code, especially on collision detection. If you skip a frame, weird things can happen because my game loop's terrible. Luan is way better in writing game loop codes than me. But you could see that this bug happens. Sometimes the ball just goes inside of the water forever. Oops, I'm just exposing my history there. See, the ball goes inside of the water because it doesn't detect collision detection on a frame, and sometimes just go inside of the water, it doesn't go back ever again. But yeah, there is that. And when I tried this with WASM, oh crazy! It's just native, you know. And I was just stunned about this. You can try. It's on turi-wasm-renan.gg. Let me put the URI. So if you have an Android device there and you can run mobilely on a Chromium-based browser. I tried on Brave and also runs well on Brave. I was not expecting that, but yes, it was really, really interesting to see. Yes, I guess that's pretty much it. I have some useful links here that I used to learn about some of the things I said, and also some interesting issues to monitor for the future of this thing. And well, that's it. Thanks a lot.
Thank you, Renan. That was amazing. And if you have any questions for him, just find him out there in the exhibition area, because now it is lunchtime. And you can grab one of the bowls and you can be anywhere out in the exhibition area, or you can come back in here because at past it will be a speaker or a PowerPoint karaoke in here, handled by Mangirdas. And you can also sit outside of the exhibition area. There are some like couches and stuff in there too, like where you came up, where we had the check-in this morning. Yeah, exactly. So who's doing that? Mangirdas is holding it. Yeah, good. Yeah, that would be. Yeah, take him in on there. That would be fun.
All right. It's working. Hello, everyone. I think we'll be slowly gathering into this room with your lunch or after it. Can we share the screen that it's there, not to be on there? Ooh. So, shameless promo. It should have been a PowerPoint karaoke. But the thing is that I created a Flutter package to create presentations. So that's a Flutter karaoke now. And I own the stage. But that's all the promo. Just check out this package if you're planning to talk about Flutter and you want to show a fancy demo inside your slides. You can do that because that's a Flutter app after all. And today we have 4 interesting topics about Flutter. And the idea of slide karaoke, for those who don't know, is to get on stage without knowing what you are going to talk about. You'll see a prepared slide deck for you. And it will be 10 slides. And for each speaker, there will be 5 minutes of doing this presentation. And hopefully, my hope is that for this speaker will feel terrible, lost, but at the same time very excited, and it should be a lot of fun. So, what? The question was whether that will be recorded. I hope not. So that's the goal. And we actually have some volunteers. I see one already standing over there. So Sally, want to start? Because as a first speaker, you can choose one of the 4 topics and that are prepared for you. So which one that is? Yeah, leave Flutter is dead for Craig. No, I'm joking. You can choose. You can choose whatever. Flutter is dead. Okay. And let's go. Flutter is dead by the delulu developer. Enjoy. You have 5 minutes.
All right. Is it like 4 slides, right?
It's 10 slides.
10 slides. Oh, okay. Yeah. You know, like, this is the sentence that everyone wants to see, right? Yeah, everyone wants to see that Flutter is dead. And the reason goes in multiple reasons. First, Twitter people says Flutter should be dead as soon as possible because there are better alternatives out there, like Xamarin or PhoneGap, and people are happy to use it. And as you know, everyone has a way of eating food, you know, and everyone has a way of doing a different kind of application. And if you don't know what you're going to be doing, you will end up looking like, okay, I just don't even know how to use utensils. I just don't know how to use the forks and so on. So that is why when you think that Flutter is dead, then you might end up looking like this. So yeah, like as yeah, like one night I had a nightmare, you know, like I had a nightmare that Flutter was dead, and the Edward from Twilight, I forgot his name, the new Batman, he was thinking that he was getting chased by the Kacho, so, and at the end they were both trying to catch me to tell me that Flutter is dead. And luckily, the dog was here to save me with all of these ideas that saying that, hey, Flutter is not dead, you will survive. And if you want to build apps for web, Android, Windows, and iOS, you will do it. And it will make you as happy as having happy kittens around. And it will make you an amazing developer as well. So let's talk about, is Flutter actually dead? And slowly wrap things up. We know that Flutter is not dead. And we also know that whatever we do, we cannot prove that it will be dying. It will show the opposite, almost 100%, then we don't have any evidence to show that it is dead. So, but if you want to see Flutter working, you should use more Gemini with it, apparently. And as you use more Flutter, I guess you turn into Flutterman and show that it is alive. So, long story short, we will sing this song to say that Flutter is not dead, but actually it is going to be alive. First I was afraid. No, that's not that. So okay. So here's what we are going to do. We will sing it together, and we will sing the famous part. Staying alive, staying alive. Staying alive, staying alive. Now we will do it as Flutter alive, okay? Flutter alive, Flutter alive. Flutter alive, Flutter alive. Yeah. So, thank you very much for listening to this amazing conversation. I hope that you learned Flutter is not dead. Thank you.
Yeah, thank you. Thank you for opening this. Flutter's alive, indeed. Cool. So as you may notice, it doesn't make sense. The presentation is completely random. And other 3 topics should be similar. So who's the next getting on stage? I see a lot of hands. Yeah, sure, come. Introduce yourself.
Hi, I'm Qais, and I would go with this. Yeah, state management.
State management, let's go. So this is next slide, previous slide.
Yeah.
Yep.
So, state management by GetX Guru. You know every guru is fake, so GetX is fake. Yeah. Oh my God. Yeah. Picking a state management is just like GTX. When you go to steal a car, you pick the first one and you see the other one more fancy, so you jump to the next one. And you carry a gun sometimes to kill the person who is in the first car, just for fun. That's exactly what happened when your state is out of sync, when your widget is out of sync on your state, because you just forget to make listener on one of your widgets that should be stateful. Yeah, so you get the same screen saying 2 different things, and yeah. I know. This is so hard. Okay. States like pickles, so they cook for 40 days until they are ready, and when they are ready, they may, yeah, taste good or shit. So when we pick a state management, we basically pick a risk, and it's just, hey, we picked this approach on front of others. It gives this benefits and this pros, this cons, and we usually like regret this decision after a while. Then we love our decision because we hit the cons, and we hit the cons, we regret them. We hit the pros, we love them, and we are in this vicious cycles of loving our first state management decision or hating on it forever. It's a cycle, never-ending one. Okay, so I jumped with energy when I came to this pitch, and everyone maybe had attention on me, but I sucked half the way through. And now I'm just making jokes on myself. I trapped myself when I jumped here. That slide would have been better if it was 2 slides. Yeah, so that's where we jump in to pick the next package, the next state management solution. And when we just regret the last decision, I don't know. That's a proven fact that simple solution could solve complicated problem if you use them correctly. Thank you. Sorry for taking your time.
Thank you. Oh, this one, yeah. Yeah, it is not easy even talking about state management, right? Cool. 2 more serious presentations. I know I promised a place for Craig, so yeah, you should come there. And you have 2 presentations to choose from, which are Flutter and Friends or is Dash Swedish? Flutter and Friends? Yeah, it makes sense. Let's go. That's actually not a regex, that's just different variations of Lukas that you could find on this venue.
How dare you have a name that is not a complete grammar of a regex? It's an irregular expression, actually. So, as you know, all regular people, as they want to express themselves, walk across the street in the costume that sets their soul on fire. And these 4 lovely ladies, we can only presume they're lovely. The costume is very, it's a great disguise. I think they really set the stage for all of us. They remind each of us that kind of childlike whimsy that we had when we were young to truly express ourselves in an irregular way, just like the name at the top of this slide deck. Now, if you've ever eaten at McDonald's, you know that they can take a potato and turn it into French fries in like hours, out of the ground into your mouth in just minutes. And that's because of a very standardized process of chopping up and frying potatoes. And honestly, computer scientists took inspiration from McDonald's French fry process when the original regular expression grammar was conceived of. So just incredible. Oh wait, I'm supposed to be talking about Flutter and Friends. I've just totally gotten hooked on the regular expression thing. Anyway, potatoes are mostly from Idaho. Did you know they only came to Europe and arrived at Flutter and Friends hundreds of years later because potatoes can be chopped up into little pieces, and then you bury a piece of potato in the ground, and it will grow into more potatoes, which is a really unholy thing, but it did get potatoes to Europe. I actually may have that backwards, I don't know. Okay, so psst, kids, want to buy some widgets? Yeah, Mengerdas actually last night was on the street trying to turn tricks by selling widgets to kids, and this was to raise money for our lunches today. So allegedly, he says, but we've got photographic evidence here. But you were also expressing yourself in a very authentic and irregular way in this costume. So you do have plausible deniability here. But that is a part of the funding process for Flutter and Friends. Now, this is actually a picture from karaoke night last night. And you're going to hear later today, some folks have lost their voice, and this is how that happened. So Flutter and Friends, you know, if you hear any cracking voices, you know, you just want to cut people some slack because they were singing last night at karaoke way too late, way too loud, a lot of like fist pumping, and you know, Flutter and Friends is going to suffer today for it, but it's the friends we made along the way, right? Charles C. Darwin? I don't remember what his middle name is. One of the founding members of the board of Flutter and Friends. And when he went on his voyage to the Galapagos Island, he didn't just notice that the finches were similar. He also noticed that the platforms where you could render UIs were similar. And he thought to himself, gosh, there's just got to be a better way than to start over from scratch. DNA didn't start over from scratch when it made 2 different finches. They all came from the same tree. They all had a common ancestor. And he thought, I'm just sure that there could be a rendering pipeline behind all of this. And that, of course, ultimately helped form Flutter and Friends, where we now gather. So this was one of his early schematics for how evolution may have produced different finches. And he was misspelling finch there, so that's a little embarrassing. He wrote duck. But the same spirit of this went into the early Flutter kind of prototypes and architecture, and now here we are. So Swedish people have they have a first name and they have a last name. Some people call that a surname and a given name, but at Flutter and Friends, we just use the American terms of first name and last name. And what you'll find at your local Flutter and Friends badge is that you do in fact have your first name and last name printed on here, unless you failed to tell the organizers that, and then you may have had to write it yourself. I saw one person who had handwritten her name on her badge, and I personally don't blame that on her. I blame that on Flutter and Friends. So here, there's just a lot of joy in the world, and I, for one, at Flutter and Friends today, am experiencing a tremendous amount of joy. And this is a photo of 2 deer and 2 cats, definitely not made by AI. This is an actual photograph of them celebrating how just excited they were to get to Stockholm, to turn up at whatever this venue's name is, and enjoy some great talks about widgets and rendering pipelines and WASM and whatever the heck else we're going to hear about. And I think that's a very infectious energy, and I've got it right now. All right, that was 10. Great, thank you.
Thank you. Yep. Man, that was a weird. That was awkward. Was that more awkward than the slides? I don't know. Is Dash Swedish the last topic? Joseph? Yep. Let's go. So yeah, the last topic by Volvo IKEA Baba. Next slide, previous slide. Yeah, good luck.
Hey everyone, I'm Volvo IKEA Baba. IKEA Baba? Yeah. So is Dash Swedish? That's what we probably all ask ourselves, like the first time we saw Dash. This is, actually Dash as a kid. That's like, no, actually in the womb, just before it came out. Does Dash have a gender? I don't even, a she, okay, she. Maybe I'm not the best person to talk about Dash if I don't even know the gender, but I still do it. That's actually me. I still don't have a Dash, so that's an accurate picture of myself, looking like that. Yeah. What is happening? This is this is Dash Dash's mom in disguise telling people that Dash is from Sweden. I still don't get this. It's like I think someone needs to explain it to me later. Well, I guess a lot of you played Ocarina of Time or any other Zelda game. This is one of the bloopers from the Ocarina of Time, actually. If you watch the end credits long enough, that was there. Has nothing to do with Dash, but it's still a fun fact. What probably no one knows is that Dash actually speaks Latin, and that's her favorite poem. Yeah. Yeah. They're really good slides. Like it's just. So. Yeah, nothing more to say to this slide, I guess. It's just like. So great that we talk about IKEA now, because Dash almost has the IKEA colors, which is another sign of her being Swedish. And she's actually vegan, but she really loves the vegan meatballs from IKEA. That's what she told me backstage. yeah, it is also like Dash is really into folk music, and that's actually some like American, they call it country, but the country music originates in Sweden. So probably not everyone knows that. Here here we see Dash in disguise, like with a fake beard in front of what's the Ericsson statue, right? Yeah, it's like she's kind of a bit shy in public, so that's why she often wears a fake beard. Yeah, thank you.
Oh, that was a secret topic where we get a prize. Sorry for other speakers. Thank you for being here, actually. It was fun. So I think we'll leave 7 more minutes for the next speaker who's coming on stage for a more serious talk this time. Yeah, enjoy the conference, everyone. Thank you.
Give it up for Mangiras! But before you go away from here, raise your hands if you have a Dash. Okay, Enzo, come. Oh, wait, actually, you're taking photographs. Come here, Craig, and come here. And we have, yeah.
Oh, we're going to shoot some stuff?
And you take this one. And you take the center here. And now let's try not to kill anyone.
I've always wanted to partake in this.
Okay, are you ready?
Ready?
Who are you aiming at?
I don't know.
Okay, okay.
Okay, watch your head. Okay, I think it's not.
Yeah, you got to get it in there better.
It will work.
Okay. Ready? 1, 2, 3. Okay.
Wait. Let's see. I managed to do this before, so you should be able to do it.
Yeah.
Okay.
I think I'm good.
I think you have to have it a little bit like that, maybe.
All right.
Okay.
Like this?
Okay, try.
Okay, this is good.
Okay.
You can leave. 1, 2, 3.
Not all. I want to. Oh, is this thing on? No. That's good. Display. I don't want mirroring. Don't want to mirror. I want to extend. Where was it? I always forget it. Is it already extending? Okay. Yeah. Okay. No, it's not. Wait. Extend. I want this to be there, and this to be there. These are two different screens. So if I put, it's mirroring. No, this. I want my. I want this to be mirrored here. Can I put it here somehow? It was there. Let me see. I'm doing it. Look, please stay here until I'm done. It works because in the Chrome bar, in the settings, you have to check the move bar. Yes. Oh fuck. Oh, I'm sorry. No, I'm not done. I'm not done yet. No, not yet. No, not yet. Not yet. Not yet. Not yet. Not yet. Not yet. I'll tell you. Close your eyes, please. Never mind.
All right, we have quite a crowd here. And next up is Darja. And if you have ever spoken to Darja, the first few things you'll get to know about her is nothing about Flutter. First will be cats, then dogs, then Harry Potter. But now you will get a little bit of this mixed in with Flutter, I think. Give it up for Darja.
So, hello, my dear students, and welcome to the class of Software Witchcraft and Wizardry. My name is Darja Orlova, and today I will be your professor of defense against the dark bugs. Besides occasionally teaching magic at conferences, I'm also building apps. And currently, I'm focused on building my own apps in a company called BB Apps, where we create apps that care for you and the planet. And I hope that those apps will help people be more mindful about their lifestyle and help them achieve their goals. So feel free to chat with me about what I'm building during the conference. I'm always open to do that. And you can check out what I've already built at bbapps.dev. But before going solo, I was building apps for clients. Many different apps in many different domains. And eventually I became a mobile tech lead and my tasks became more abstract. One of the scope of the tasks was systemizing our approaches to building apps, code style, architecture practices, delivery practices, and of course automating them. And in this regard, static code analysis tools really helped me, and that is why this is the topic of today. In Harry Potter and the Half-Blood Prince, students throughout their potions class were brewing a potion called Felix Felicis, also known as liquid luck. A sip of this potion would make you successful at anything that you attempted. So, inspired by that, I thought that Felix Felicis is a great analogy to what we will be brewing today, which is a robust and automated static analysis system, which can also sometimes feel like magic outside of Hogwarts. And just to keep it a bit more fun, get your questions ready. I hope we will have some time for them. And the best one, in my opinion, will win a portion of liquid luck. Of course, to explore coding practices, we need a sample project. And I have built a very simple app where you can read all about various magic beasts. And as Lukas has already mentioned, if you have ever been to my talk or just spoken to me, you know that I have this thing with cats. And there is no way that a cat would not make an appearance in my talk. So the star of today is not an ordinary cat, but a magical beast called Shadow Felice. And the goal of this demo is to refactor our initial app step by step, but only by following what static code analysis tools tell us to do. And we will see how even on such a small example, these tools can be powerful. Now let's see some code. From the first glance, we can see that Beast Page View is a stateful widget, which doesn't actually have a state. And our main page has a page view with children, and some formatting is off, and the Beast views are hard-coded. And now let's zoom in into a particular view, which will be our Shadow Felice code. And again, if we have some experience, we can see that there are missing trailing commas. There's the generic media query is used when it could be a specialized one. No const constructors. And there is no state in the stateful widget, so it might as well be a stateless widget. And if you haven't noticed, this is actually a different view. We have switched a class, but it is completely duplicated except for the title and the actual image. So it would be useful if we could detect duplicate widgets and maybe refactor them. And while catching all of this with our own eyes is a very useful skill, it is generally less reliable and very dependent on the experience, mood, deadlines. So it would be great if all of those things could be found automatically. And automatically will be via CI. And I will use GitHub Actions. You can use in your code, in your project, whatever you want. And we will build the workflow step by step. So first, we create a YAML file in our GitHub Workflows path and call it pull request. What we want to do is for every time a pull request is open, run a CI check that blocks merging in case it doesn't pass. We will call it audit and also run it on every push to the branch with the pull request. And we need to describe some admin steps. Check out the repository, set up Flutter, and print Flutter version. And before preparing for this talk, I've never actually used GitHub Actions, only other CI providers, so it turned out to be super easy and straightforward, and if it's your first time too, then that's good news. Now that we've understood the automated part, let's understand the robust part. And we will start with simple yet important things. Properly formatted code is the foundation of a clean and maintainable code base, and I don't think anyone can argue with that. But we are human muggles, some of us. We can forget, it happens. So to make sure it never happens, we can add an automated check. The CLI command Dart format set exit if changed checks if your code needs formatting, and if there are any formatting changes, it will return an error code which will fail the CI. For example, in GitHub, it looks like this. We have open a pull request, and once we did that, we can see the audit action check started. And in case something went wrong, you will see the failing check, meaning you need to address the issues before merging. We can then open the details of our action and see that check code format step has failed, which means we have formatting issues in our code. And code formatting is great and useful, but it's just the first step. Now let's put in the next ingredient, the actual lint rules. In order to do that, we need to create an analysisoptions.yaml file at the root of our package alongside the pubspec YAML. You can have nested analysis options YAML files, and then the analyzer will prefer the nested ones, so keep that in mind. And you can do that in case you need to override some behavior in your sub-packages. Starting from Flutter version 2.3, all new projects come with Flutter lints library enabled by default. This library is updated roughly once per year and contains a list of curated lints, such as core and recommended lints from Dart, and also some specific Flutter ones. And in order to enable Flutter lints, we need to include them in our analysisoptions.yaml file. And doing this will enable the lints in our project, and Dart Analyzer will start using them. For example, by just enabling the standard set of lints, we can already see in our IDE of choice, in my example, that's Android Studio, that we have 70 issues. Most of these issues are related to the fact that we're not using const constructors. And then in our IDE, we see the highlighted code, and if we put our cursor on the correct line, we will see the description of the lint. And being able to see all of these issues from the IDE is very useful during development, but we also need an option to run those checks in the terminal, which we can do with the CLI command flutter analyze. And if we can do it via command line, we can use it on CI. So our next step in the audit workflow is to add the flutter analyze command, which we can then see in the report. The step failed because it returned more than 0 warnings. When it comes to fixing those issues, we have 2 options. We can fix them manually by hand, or we can use the automated command Dart fix. And if we use Dart fix apply, it will fix those issues that have auto fixes enabled for them. It's very useful and time-saving command, so if you haven't been using it before, you should know. And we can apply it in our Magic Beast app, and we'll see how many and which issues have been fixed. Here's the report. But as I previously said, not all of the lints have autofixes because there's not a definite autofix for every lint. Some of them are opinionated. So most of the time we will be fixing issues both automatically and manually. And finally, when we fix all of the issues, our GitHub action check will pass and will allow us to merge. Now, take a look at the code again. We can see that const constructor is being used correctly, but formatting is still quite off because we're missing trailing commas, so maybe there's more that we can do with the lints. The thing is, Flutter lints library contains only 100 lints, but there are actually more than 200 lints available in Dart, and I'm not sure if the number on the screen is relevant anymore, because latest Dart version, I think, also introduced some more new lints, and more new lints come out with new language versions. And this is because Flutter lint is meant to be more or less universal for all Flutter projects, but specific teams have specific requirements and can be much more stricter than that. One way to enable extra lints would be to manually select the ones that make sense to you and configure them one by one. But I think this way it's very easy to miss some of them, especially as new ones come out. And another way is to use already created lists by other companies, such as Very Good Analysis by Very Good Ventures. But some time ago, I learned about a different approach, the opposite one. You actually enable all lints by default at once,
and then explicitly disable those that don't make sense or are conflicting, such as prefer single quote versus double quote. I like this more explicit approach because this way you're not missing out on any lint and have to understand why are you disabling one lint or another, preferably with documentation when doing so. And also it's much easier to update the lints from the official website every time there is a new version published. So in order to follow this approach, we need to create another file at the root level and call it alllints.yaml and copy paste all of the lints from the official Dart docs website. This is how it looks like. We have all lints alongside analysis options, and in the file itself, we just specify literally all of the rules. Next step is to actually include this file inside of our analysis options, the same way we previously did with Flutter lints. And instantly, we see that we have much more hints and warnings now. But the problem with the warnings is that we have conflicting rules enabled, such as the already mentioned prefer single quotes or double quotes. So our next step is to configure the conflicting lints, and we specify them under the linter tag in our analysis options.yaml file, explicitly enabling and disabling them with the Boolean flag. We also need to ignore these warnings so that they don't flood the analyzer because we have explicitly configured them. Finally, we can see that now we have 163 hints more, and this time they do contain a missing comma warning. We can also see the issues highlighted in our code. As usual, we can't on this screenshot, I think. Oh, we can, it's very at the bottom, sorry. But yeah, they are highlighted here. And once we fix those issues, our code becomes much more readable now, looks more like decent Flutter code, but still not perfect. We are still using the inefficient media query as well as still have duplicated widgets. So our next ingredient into the perfect status analysis system is a tool called DCM. And before we move on, I just want to mention that I'm not sponsored. I'm just sharing my actual experience that I liked by using this tool when I worked in a team. And DCM, which you may have known under the name Dart Code Metrics, is a static code analysis tool that offers more than 300 unique rules on top of the standard Dart ones, as well as many other useful features, which we will see now. One thing to keep in mind that DCM is a paid tool that offers various licenses, including a free open source license, which you can obtain by applying on the website. In order to enable DCM in our project, we need to configure it under the Dart Code Metrics entry in our analysis options.yaml file. And a good starting point is to enable the recommended preset. And one thing that excites me about enabling just that preset is that all of the lints that you see on the screen are lints that show potential errors in code. So by fixing just those issues, your code base will already be much more reliable. Now, this slide is not me trying to start a holy war on the best state management solution in Flutter, because obviously Flame is. And so these are some of the packages that DCM offers lints for, because it's not opinionated on which state management solution you're using for, as long as you're doing it correctly. And yes, including those that shall not be named, because you never know which code base you can inherit from a previous client, previous code owner. And it makes sense that the standard Dart lint set will never contain rules for third-party packages, so it's very helpful to have them in DCM. And yeah, as I said, the goal of the tool is to help you write cleaner and safer code, no matter your life choices. Now, after we have configured DCM in analysis options, we can see the warnings in a separate tab in our IDE of choice. And this is because DCM is a separate analysis process. It is not part of Dart Analyzer. It is not a Dart Analyzer plugin. So it runs completely in parallel. For example, now we can see that our widgets that don't have state can be converted into stateless widgets, and that we can use a more efficient version of media query. And obviously, many more issues. Another issue that has surfaced is that the first class name does not match the file name. In our main.dart file, besides having the main function, we also have our Magic Beast app class, which ideally should be in its own file. So By following the hints from DCM, we can refactor and extract the Magic Beasts app into a separate file and make our code base cleaner and more maintainable. And of course, we can perform the same check in CLI by calling the command DCM analyze and providing the path. And if we call it in CLI, we should also add it as a step to our audit workflow on GitHub. We have also added the if not cancel check, which will make sure that these steps run even if previous ones, such as code formatting or Flutter analyze, will fail. And in similar way, we can see the report in the audit flow details. The step has failed because we have issues. Who doesn't? And some of the lints in DCM have batch fixes enabled for them. So alongside manual fixes, we can also auto-fix them with the DCM fix command in the CLI. But obviously not all rules, not all lints have them, same as with Dart fix. And now I want to show you an example of manually configured DCM lints. And besides just turning them on and off, we can configure to make them even more customized to our own style guides. So as you can see, we can do a lot. And here's a couple of configurable lints that I particularly like. Panned imports, making sure that we can't import UI libraries where they're not supposed to be, such as in data and domain layers. Another banning example, but in this case we have specific classes that we prefer using for consistency, such as using a time provider instead of explicitly initializing a date with datetime.now. We can control our class code layout by specifying the order of the members as well as specific widgets methods. And this configuration helps to structure code so that you always find what you expect, where you expect. And there are many more rules which you can explore in the documentation. And moreover, new rules come out every month. And DCM is more than just a linter. We all use packages in our code, but sometimes there can be a situation that we stopped using the code from one package, but forgot to remove a dependency. Thankfully, we can make sure this doesn't happen with another DCM command, the DCM check dependencies, which, as the name says, checks dependencies and reports those that are unused. And we can add it to our workflow. And in the case we have left behind any unused dependencies, our check will fail until we remove the dependencies that we no longer need, such as Flutter tests, because who needs that? In general, part of the software evolution is code that eventually becomes unused, such as a method called unused method, or even a whole file, such as unused widgets, which is not used anywhere. For both of these issues, DCM also offers a solution, and it checks for unused files and checks for unused code. So we add two more helpful steps to our audit workflow, which will make sure that our code base never has stale code. And it will fail in case we have unused files or unused code. Unused code is one problem, but another problem is duplicate code, especially when we're talking about multiple duplications of big chunks of code. But we will see a simple example, just that we can follow along. Here we have two classes, a Luminara view and a Qualis view. Both of them have the same print methods with the same argument, but different method names. So the signature is the same. And if we run another DCM command called DCM check code duplication, and obviously do it via CI too, we will get a report where we will see the code duplications and candidates for refactoring. Even if the method names are different, it checks the signature, not the name. And DCM has several more features, but for today I want to show you one final one. And I believe this one definitely invokes some dark magic. We've been talking a lot about static code analysis in Flutter, and one thing we all know about Flutter is that in Flutter, everything is a widget. So wouldn't it make sense to have widget analysis? For that, we have DCM analyze widget command, and with the flag show similarity and type of reporter, which we can be in console, but we will take a look at the HTML one. And once we run this command, we will get a full report on our widget system. So we can see different different widgets, the beast views that we have. And this column particularly interests me the most. As you can see, for each of our beasts, and we have 5 of them, the similar widget column says there are 4 similar entities. So let's take a look inside to see more details. The first thing is that we have a quality score, which is based on various code metrics, such as number of params, max nesting level, source lines of code, and so on. These metrics are all configurable, if you want to get nerdy enough, but we won't have time to do that today. We can also see what widgets are used and how many times. And we can see the analysis of similarity of the widget tree, which in our case is 100% among the beast widgets. And what is compared is the widget tree and the parameters of the widgets that are used. And this provides us with a great insight into our widget system. And I think this is a solid argument for refactoring. So based on that feedback, instead of having 5 separate widgets, 1 for each beast, which doesn't really scale as we have more beasts, we can now refactor to use a configurable and reusable widget called BeastView that accepts parameters. And we got rid of 4 classes and made a good architectural decision thanks to a static code analysis report. And on top of the widget report, we can also see the resolved widget tree statically for all of the widgets in your code base, which can be useful in many cases, especially when working with design systems, because you can visually track relationships among widgets and what is used and where, even conditioned ones. But what if we have an issue and the rule to highlight this issue does not exist? For example, this line of code, Firebase analytics.log event, share a beast event triggered by user in-app. Do we have Firebase users here? Put your hand up. Okay, amazing. So basically this will never be logged to Firebase analytics because it should be highlighted like that. Event names can be only up to 40 characters long, and this is longer, and Firebase just drops them. So we don't always calculate those characters, right? So it would be useful if this could be highlighted in code as soon as we write it. And we could potentially see it in our IDE and do something with it. It would be also useful if you could maybe trim it automatically with a Dart fix, or with maybe not Dart fix, but we will see soon with what. And we have such an option. It's called Dart Analyzer plugins if we want to add custom lints, custom behavior. But enabling analyzer plugins is still experimental. There is still work going on. As you can see in the documentation, it says experimental. And there are some limitations. First of all, you can only enable 1 plugin per analysisoptions.yaml. And obviously, enabling an analyzer plugin increases how much memory the analyzer uses, which can be crucial for bigger projects and smaller computers. And don't use analyzer plugins if your situation meets either of the following conditions. You use a development machine with less than 16 gigabytes of memory, or you use a monorepo with more than 10 pubspec YAML and analysisoptions.yaml files. And we have another solution called custom lint, because what is custom lint? It is a package. It's a Dart package. Sorry, I don't press correct buttons. So basically, it's an analyzer plugin which wraps around the Dart analyzer plugin architecture and gives us a more usable API and also tools such as debugging the lints, testing the lints, and so on, and makes it much easier to write custom lints than actually writing your own Dart analyzer plugin. And in order to use a custom lint package, to write a custom lint, we have 2 steps. First of all, we need to define a package that uses custom lint. And then we need to use that package in our project. So let's start with step 1. And we will create a magic BeastLint Dart repository. And we need to add some dependencies, the analyzer plugin, and custom lint builder. Then the first thing that we need to do is we need to extend a plugin base. And from there, we return a list of lint rules. And this is where we will specify all of the custom lint rules that we will write ourselves. For example, we want to write a lint rule that will highlight that Firebase event name is more than 40 characters. And we do that by defining first a class that extends the lint rule. Then we specify an instance of lint code where we need to specify the name of the lint, the problem message that will be shown in the ID or in the CLI, and error severity, such as warning, error, or hint. Bigger code. Then we need to override a method called run. And in this method, we get a list of useful tools that we can use to navigate our code. And from my experience, writing custom lints is a completely different thing than writing Flutter code, because you have to understand the language and difference between things like function and method, which I found out while writing custom lints the hard way. I mean, I knew that, but as a human speaking, it's not much of a difference. And when I talk to developers, developers understand, but yeah, analyzer doesn't. So you have to be very explicit. And we can also specify optional fixes in the overridden getFixes method. So here's an example of how a potential lint rule might look like. I hope nobody, especially Slava, can see this code because it's probably really bad. I'm not teaching how to actually write good lint rules, just how to do that. And the rest is on you. So what we need to do is we need to add register a callback on the context. For example, we want this lint rule to check every method invocation. And I have highlights. So this is what we did. And then we want to run this check only on the method names log event and where the argument list is not empty. And we read from the argument list the first parameter, which will be our event name, and we check for the length. If it's 42 characters, which includes 40 characters and the quote, then we want to report an error for this line of code. And we do that by using the reporter instance passed to us in the run method and specify the actual location and the length of the code that needs to be highlighted. And by doing that, if we run this, I will show you how to run it soon. If we run this in VS Code for now, we will see the reports. Unfortunately, last time I checked for Android Studio, there was some bugs, so I could not see the reports in the IDE itself, only in CLI, so it's something to keep in mind, but also I think it will hopefully be fixed. So yeah, this is VS Code. And in the code itself, we also see it highlighted. And as I mentioned earlier, it would be cool if we could just automatically fix it and not manually. So what we can do is we can supply a fix, and we do that by extending a class called dartFix. We will call it trim_param_name_fix. Also override a run method, which has even more parameters. Again, we do the same thing. We register for the method invocation, the fix. This line checks if the line actually contains the error that we are trying to fix. And if not, it just goes over. And in order to supply a fix, we need to create an instance of change builder where we specify the name and the priority. And priority also, I think, works only in VS Code for now, but it's not that important, not that prioritized. And yeah, so basically we get the event name, and what we do is we just, for now it's a very simple fix, probably the marketing team will not be happy with this, but we just remove the exceeding characters and log the first 40 symbols, whatever they may say. And we need to specify them in the getFixes override that I mentioned earlier, what we do. And then in our code, we can see that when we put the cursor on this hint, there is a quick fix called trim the event name to 40 characters. So how to actually see this in the IDE is we need to use that package in the project. So we go to our pop spec and we add the path or dependency depending on which library you're using. For me, it's local. And in the analysis options, you need to also specify the plugins used, and we can only use one, and we're using custom lint. And then we run flutter pub run custom lint, add it to CI. And in CI, we can see that there is a report. It has failed because Firebase Analytics max event name length is 40 characters. Yeah, that's a spoiler. Or not. OK, never mind. So basically, when I was giving this presentation the first time, I made an example with the Firebase event name rule as a custom lint rule because it was not available even in DCM. But one month later, it is available now in DCM, so you don't have to struggle like I did. And it also includes checks for other Firebase things like alphanumeric characters and so on. So it can be very useful. One thing that I wanted to mention about custom lint and analyzer plugins is that if you use custom lint from different, like you can use different libraries that extend custom lint in your project, and they're still part of one analyzer plugin of the custom lint one. So this makes it much more useful than writing like from scratch your own plugin, because that way you will not be able to use anyone else's lints. But with custom lint, everyone else who writes custom lint and publishes them, you can also use them. And you can also use it in parallel with DCM because DCM is not an analyzer plugin, it's its own process. Obviously, there is more, and we don't have that much time. So there's more things you can do just in the analysis options. You can also do more things with DCM, many more features, which you can check out. There's a lot of custom lints published in the pub.dev. You can also find useful plugins for your IDEs, which cover some of the things that, for example, DCM does or other tools, but they work in IDE, not in CI. But you can also find some useful GitHub actions. For example, they can review your pull request and also comment on the exact lines, and also some of them can fix them automatically for you, the ones that have fixes. Or use JavaScript copy-paste detector tool for finding duplicate and similar code. It also supports Dart. So to wrap this up, what we have done is we have created a GitHub action that runs on every pull request and every push to that branch, which includes code formatting, lint rules, Dart code metrics, and custom lints. And this is how the final report can look like. All of the steps passed except the check dependencies, because we still depend on Flutter tests. And one last thing that I wanted to mention related to Analyzer is with the latest Dart version, the publication, there's a couple of things coming soon. First of it is the new formatting for Flutter repositories. It's still work in progress, but you can try it out by enabling a flag. And in this issue, you will find instructions how to do that. And you can also give feedback to the Dart team, how it works for you, what could be better, what is good, and so on, so that we can have properly formatted Flutter code from the beginning without the lint rules. And another feature is workspaces, which is also work in progress. I think if Slava is here, you can catch him, try and catch him, as he said, and ask questions about that. But this is a feature that will help use less memory for Dart Analyzer by making less analyzer context, hence using less memory and being more faster. And if you want to learn more potions and magic spells, which I mean Flutter design patterns and best practices, I have published a book which we have written together with Ezra and Jaime, and it's available for pre-order. And yes. Hopefully it will teach you to write better code without even using static analysis in the first place. And yes, thank you. I would be very grateful for your feedback about my talk, which you can find. It will take 10 seconds. You will find it by following this QR code. And yes, you can follow my developer journey on my Substack. I don't spam, I promise. I wish I would. I don't have time to do that. But yeah, I post occasionally. And Twitter and GitHub. And now it's time for your questions. As a reminder, you can win this if you want to be lucky. Thank you. Are we going? Okay, so can you handle it? Yes, I think with...
So first we'll repeat the question so that the stream can hear it. So the question was how computationally price it is, how long it will take to run all the checks and whether you can, all the DCM checks and whether you can run them locally too, right?
So I'll start with the second part of the question. You can definitely run those things locally. These are just CLI comments. You can have a script in your repository, which you can just run manually, or you can configure pre-commit hooks, which will also run them locally, and you can do that. About pricing, I'm not sure. As I said, I've used GitHub Actions as an experiment in this project. Previously, like in my professional work, I've used Bitrise and CodeMagic. So yeah, I guess it depends on the machine that you're using. I think you can select that, and also on the size of your code base, but mostly on the machines. So because some machines can run it faster, but it will be pricier. So I think you should read their docs for that.
So the question is, what's your favorite lint rule?
Well, there are many, but I think I have OCD, so required trail comma, because it makes my code look better. Yes.
I think we have one over there. Wait, what was the second last word? Oh, all right. Okay, how do you keep all these things as positive things within your team, is the question.
Well, with this GitHub action, you can't merge the code to the main branch unless the checks pass. So you force them to follow those practices. They physically can't merge it. So you can configure that in GitHub. I think in probably GitLab and Bitbucket too, I would assume.
Any more questions? It's kind of hard to see you.
Yeah,
with spotlights right in your head. Yeah, there's one up there with the glowing badge. That's a good idea. What's your question? So the question is, you created your own custom analysis rules, and if you also run static analysis on that.
You mean Inception?
Like Chinese whispers.
on the rules themselves? Well, technically, I guess you can, but with the custom lint package, you can write tests for them, and also like there's the debugging thing with the logs. So every time, for example, you write the custom lint, all of the data is available in the logs, so you can debug them that way. But yeah, I guess.
Okay, let's go with Freya now. So the question is, if, like when you have a legacy project that has lots of problems in it, you might not be able to refactor all of them at once. So he wants to have some kind of check where it just makes sure that it's not worse than it was before.
Well, with Dartlint, I'm not sure, but with DCM, there is a feature called baseline, which if you introduce DCM into an already existing project, it you have this baseline, and you only get lint rules for the new code that you add. So this way, you can still keep the CI in check and also step-by-step refactor the legacy code base.
All right, last question. Right, so the question is, if you as a package developer can embed rules into your package kind of and then provide them to your customers so that you have some special ones in there.
Yeah, you can do that with custom lint. I think that's how Riverpod works and all of the other libraries, because custom lint is also maintained by Remy, the author of Riverpod. So yeah, I think it's done that way.
Yeah, I think so too. All right, that was the last question.
Okay.
Who had the best question?
That's hard, but okay. This time I'll take quantity over quality. So that's you.
And as Darja said, she's not sponsored by DCM, but we are. So we have these little cards where you get DCM for free. So you can either come and get them from me here after the talk, or you can get them in the swag booth over there. And I can really recommend it too. We're using it in the Flame team, and it helps out a lot. And the guy who's writing it is, if you come up with some lint that you think is missing, he's usually very quick at implementing it too. Super nice.
True, I can second that. There's many rules that I suggest, and I'm like, oh yeah, day after tomorrow, it's done.
Yeah. Yeah, so give it up for Darja again. Thank you.
Thank you.
And if there is somebody who hasn't picked up their Majid book yet, just go to the swag booth and show your ticket that you have bought your Majid book, and you will get it there. And now we have just a few minutes break until we will have Luan on stage here with making a 3D game with Flutter and Flame. And then downstairs we have Flutter and Friends by Alexander. Take a bunch and hand them out. I'm not sure. They have different ones. I think it's the one that is here on the QR code is just free forever, I think. Yeah. I think there is a QR code.
Oh, okay.
There is different sides.
So you are from the Flame team, right?
Yes.
We used your technology to win the Google.
Oh, nice.
Yeah, hackathon.
Oh, did you win the one with the car?
Yeah,
No.
Gemini. The Google
Global Gamer
Oh,
Challenge.
right. I was a judge there. Which was your game?
Better World.
Oh, nice. Good job.
Yeah. I want to
That's
take
fun.
two. Is that okay?
Take as many as you want.
I have a question.
Yep.
Can we use it for a bigger project in the company scope?
Yeah, I think, yeah, of course. Of course. So they have some pricing plans for enterprise, I think. I think these ones you can try it out with.
But still, we have like over 20 developers in
Yeah,
our team.
yeah.
And basically, the question would be if we would like to try out, how would we proceed?
The easiest way is to just send him an email. He's super easygoing. Like he would just give you some codes and that you can use for your whole enterprise. It's called Incendial on Twitter, but you will also find his email on this site. Yeah.
So basically, to contact the guys and then ask basically to tell that we would like to
Try it out and
try it
just
out.
evaluate it.
Okay.
And he's super supportive at the same time, so he can probably do like an introduction for your company too if you want.
We had a problem with some smaller projects. We wanted also to adopt in our bigger project that the guys are not
Every time after the first time. First time we... Very good. How are you feeling?
Awesome.
Tired?
I'm tired, but
Yeah.
I took a nap.
Yeah. Did you manage to fall asleep?
I didn't.
Yeah.
Took a nap.
Yeah. Nice.
All right.
Thank you. So fancy. Like old year's T-shirt, and then you just put on suit jacket and everything. Yes. Joachim managed to convince you to take the shirt. Yeah.
Yeah, he basically said, you're gonna do something for me. Yeah.
Yes. Easy going. Yes. Ask Darja. She knows how to solve it. Oh, with the to have the side thing, yeah. Yeah.
I was trying to do some fancy things, but I was just gonna do the mirror.
Never do a fancy thing. That's the key.
Key hack.
Tell me what you want to do.
But we had the same problem as the first one, so this will be good, right?
Yeah, this is what I normally do. I was just curious.
Otherwise, we got the little bar there.
So you can have a local screen here, and then you have another screen here.
Yeah, I did that, but then that one can't go full screen, which was the problem.
Then you have to pull the Google Chrome to that tab, and then full screen there.
But it doesn't go full screen.
It shows the bar still. It doesn't matter. Doesn't matter. It'll be fine. All right, time to get seated, everybody. It's just rounding up. Are you ready for some cool stuff? Are you ready? I think everyone is about seated now. So this is Luan. He is the founder of Flame, which I'm also a part of. We're actually a team of 5, 6 now.
6.
Yeah. So if you haven't tried out Flame, you should do that. But today will be both about Flame and about real 3D.
Yes.
We had a talk previously about fake 3D at FlutterCon, right? But now we're moving up in the world to
Yeah,
real 3D.
exactly.
Next talk next year will be 4D. After that, 5D, etc. So
Yeah, basically
looking forward
every
to
year
that.
gonna add a dimension. Yeah.
Yeah, give it up for Luan.
Hello, everyone. Welcome. Thank you so much for having me in Stockholm. So yes, as Spidon said, last year we had the pseudo 3D talk. And you might be asking, are we talking about 3D again? Well, this one is very different, I promise. There's some similarities, but you can think of it as a continuation, because basically on the previous one, we talked about how we can leverage the tools that we had at the time, which are mostly 2D tools within Flame, to make games that maybe look and feel a little bit more 3D. But by the end of that talk, I was talking that there is this thing called the real 3D, right, that we quite didn't support yet. But that was last year, and now, well, things changed. So let's get started. So this is me, Luan. As I said, I work with the Blue Fire organization with a few other people. We make the packages you love, like Flame and all the ecosystem, audio players, all the bridge libraries that we use for making games. And as he also said, we had this talk last time about Flame, and basically the whole point of that previous talk is I said I was going to answer this question, because I get asked this a lot. People ask a lot, so does Flame support 3D? And I said back then, this is a very complicated question, and basically it took the whole talk to kind of explain this. So I'm going to have to do a summary this time, because I want to get further into some of the answers. But basically, why is this question complicated? Because you say, oh, it's a simple question, right? Does it support 3D, yes or no? Well, no, it's not that simple. Because what do you mean by Flame? What do you mean by support? What do you mean by 3D? And we explore all these topics on the other one, but mostly what do you mean by 3D? And basically, my point last time is that there is this whole spectrum of games, of how they look, or how they can feel like 3D. But by the end, I said, well, there's this real 3D, and I showed this FAQ. So I went to the FAQ of Flutter on their website, and I scrolled down, and well, Flame is built on Flutter, right? So if Flutter doesn't support it, Flame won't support it. And I looked it up on the Flutter FAQ, and it said, can I build a 3D OpenGL game? And it said no. I added it natively there, kind of, because you could do some hacks, but you wouldn't be able to natively support. So a few days ahead of this talk, I went back to the FAQ, and I looked it up again, and it's still there, exactly the same, didn't change. So yeah, nothing changed, that's all that we have. So no 3D. No, that's not true. Everything changed, because we got this article, Getting Started with Flutter GPU. So this Brandon, or Bidero, has been working on this for a long time, and basically he implemented support for accessing the real GPU within Flutter. That's using the new rendering system called Impeller, and it basically allows us to do a lot of different cool things, even within 2D. But one of the things that it unlocks is that it unlocks this new kind of 3D that we didn't see last time. But I think we're getting a little bit ahead of ourselves. Oh, another important thing, I added this note caveat that I'll talk more about some caveats later. This is very bare bones, but this right now only works on Mac, so that's why I got the Mac here. I tried to hide my shame a little bit. I put a sticker there, but yeah. So we're trying to get ahead of the curve and basically implement what we need in Flame to get this rolling. So when they support the other platforms that Flutter supports that we all love, we'll just kind of get that for free, which is the whole point of Flutter. But let's go back a little bit. So when we talk about 3D, what is 3D? So I make this slide just to get this out of the way. There are things I'm not going to mention at all that are out of scope completely for this talk. So the first thing is when I say 3D here, what I mean is 3 dimensions of space, and that's it. I'm not talking about time as a dimension. I'm not talking about, I'm a physicist, so when you talk dimensions, you might ask how many dimensions the universe has, and there might be 4 dimensions, or maybe some people say it's 11. No, let's think normally like the world as we know has 3 spatial dimensions, right? And not only the world we live in, but when we make games, we're simulating fake worlds. We're creating, imagining new worlds, right? But normally they're going to be 3D as well. Of course, you might have like a book like Discworld, where the world is actually 2D, but in 99% of the normal games that we play, regardless of how it shows on the screen, in your imagination, that world is supposed to be 3D, right? So that's one part. And then right at the other end of the spectrum, you have this game being rendered on a screen, on a monitor, that is actually 2D, right? Well, it is a 3D object that exists in a world, but the surface of the screen where we have this grid of pixels is 2D, right? So somewhere in between, there is some disconnect. It was 3D at some point and then become 2D. So we're going to talk about this transformation, where exactly it happens, because that's where the magic is. I will also mention only this time that if you're not rendering your game in a typical screen, so maybe you have like a VR game, that could be real 3D, like actual 3D, or if you have those 3D goggles, you can watch the movies. I guess you could make a game as well. I never seen one, but I don't see why not. Or maybe you have some hologram. Of course, you can render things in actual 3D, but for all intents and purposes, for 99% of the games, we're talking about games that are rendered in a 2D surface. So even when we say a 3D game, we're talking about a game that has that is being shown as 2D, but feels like 3D, basically. And it's supposed to be 3D in our minds. So this is so the whole question is like, we have this 3D thing being rendered in a 2D surface. So what is this transformation? So I divide into two types to begin with. This is the transformation that we're going to learn, this yellow arrow here. I divide in two types. So as I said, in both types, I think in our imagination, the world is 3D. But there are two very clear, distinct types of games in where in the code, the world is 2D, or in the code, the world is 3D, right? So what do I mean by that? If you have like some top-down game, you're saving, like you have the player character, and it has its position as an X and Y. That's 2D in the code. And then it's shown as 2D on the screen. Or you have your player character has a position X, Y, Z. It has a vector 3 as a position. That's what we're going to show they're going to be calling the real 3D. So last talk we'll focus more on number 1 here, but this time we're going to focus on number 2, and more specifically we're going to focus on this arrow here, which is the transformation between the 3D coordinates in your code to 2D coordinates on the screen. Okay, so let's do a quick recap from last time. We talked about 2D worlds. I think there are 2 key takeaways from 2D worlds that are going to be important this time. The first thing we learn about the 2D version is that even though we're going from 2D to 2D, there is still a transformation involved because we have a camera. Because normally in most games, you're not seeing the whole world at the same time. You're seeing a section of it. So you're already transforming from world to screen coordinates. It just happens to be 2D to 2D. But the way you do that, that's the second takeaway, is we use matrices. And these matrices are coordinate transformations that we're making to transform one thing into the other. And this talk, I'm not going to go deep into the matrices, because that was more the point of the previous talk. And for this one, we're kind of going to abstract that away a little bit. But it's important to know that all these transformations are basically a 4x4 matrix. And here's an example of one for 2D, but we're going to see that the 3D is not that much different. It's actually, we're doing very similar things. And then in the last talk, we also saw some 2.5D techniques, or ways to make the 2D worlds kind of look and feel more 3D. Again, we're not going to talk about this, but if you want to know more about any of one of these topics, you can check out the other talk. We're going to talk about the real 3D, right? So we are going to keep pressing this, like, what is real here? What do we mean exactly? Well, we're talking about 3D rendering, right? But more specifically, we're talking about a 3D in your code, right? So as I said, you could think of a simple game where you have this like player class, right, or enemy or character or whatever you have on your screen, and it has a vector too, has an X and Y. That's what I'm calling a 2D world. So, and in this one, you also have a transformation. You have like a camera, but it's a much simpler transformation. So this is not what we're talking about. We're talking about 3D worlds where you have 3D objects. So you have vector 3 to represent their positions. But still, you need to render that into the flat 2D screen. So what's the transformation here? So let's refine our understanding here, and we're saying we're 3D world rendering. But that's not only that, because last time, we need to find this transformation function. That's going to be a piece of code that's going to transform coordinates from the 3D space into the 2D space. And I'm already giving a spoiler here that it has to do with triangles. But in essence, in abstract, we're thinking like anything, any coordinates could be transformed from one to the other, right? And it has, everything is unlocked by this question. This question gives us a hint of how we're going to do that, because it says, can I build 3D worlds, parenthesis, OpenGL. So we're going to see a little bit more about what is OpenGL and how it fits into this. So basically, there are 2 ways we can do this transformation. So we have our 3D code, and we want to transform that into 2D, right? We can basically do that into the CPU or in the GPU. And last time I showed how to do it in the CPU because we didn't have this GPU access available. So you can definitely do that in the CPU. In fact, that's how games used to be made, before these fancy GPUs existed. And I showed this video that's from last time. It's 3D rendering in Flame. So this is similar to what we're going to accomplish, but this is all done in the CPU. Now, this is not very optimal. Of course, for this very, very simple example, and even something a little bit more complicated, it should be totally fine, but it won't scale forever. It will not, well, nothing scales forever, I guess. But it'll not be as fast as using the GPU. And the reason is because they work fundamentally different. So the CPU processes does one operation after the other. It's very sequential. Some asterisks there, but it's basically sequential. And this operation we can think of, basically it's multiplications that we're doing. We're doing lots of multiplications. And the CPU, if we're doing only one, it's actually faster than the GPU, but it only does one at a time. When you have a problem where you're actually making multiple multiplications involving the same numbers multiple times, and you happen to be able to put that into the GPU way where you do them in parallel, you can see that it can be orders of magnitude faster because you can do thousands of a time. Even if your CPU has multiple cores, it won't be a match for a GPU that can parallelize in a much larger fashion. So we're very interested in going the GPU route. And so how do we access the GPU? The code you write, you have your dark codes, you're writing your Flame game or anything else you're writing basically, is mostly run on the CPU. So in order to unlock the power of the GPU, that's where OpenGL comes in. So OpenGL is one of many protocols or interfaces or ways or programming tools that you can use to access the power of the GPU and do things in parallel the way we want to handle these graphics with. And there are others. So OpenGL is the good one because it's free and open source. So that's what you're going to find in Linux and Android and that kind of stuff. But if you are on macOS, you have Metal. That's, again, same deal, different API to do the same thing. And if you are on Microsoft, you've probably heard of DirectX. That's, again, the same thing. It's using GPU 3D, not only 3D, could also be 2D, but GPU rendering in general. And we're not going to have to deal with these specifically because, as we're going to see, we're going to have a wrapper on top, which is the Flutter GPU package. And the way these things are normally used is to make 3D games. In fact, most, big, I would say pretty much all 3D games these days, big or small, are made using these libraries and using the GPU as a way to render 3D graphics. So you're definitely familiar with this from just playing other games. But the GPU, I wanted to mention, can also be used for other things. In fact, it was originally envisioned for graphics because they realized that graphics is basically just multiplying a lot of matrices. And I'll say that a lot of times because basically that's all that is, multiplying a lot of matrices. And they designed this different type of processor that's better to do that than the CPU. But then later they realized that there are other other problems that they want to solve that also involve multiplying a lot of matrices but are not rendering graphics. So they created other languages, other protocols to access. We're not going to talk about that. A very famous one is CUDA from NVIDIA. So you might have heard of that in the context. There's recently been this new thing that everyone has been using GPUs to do. Oh, no, sorry. The actual new thing that everyone has been using GPUs to do instead of graphics. They use these languages. But we don't care about that. We're actually using GPU for its original purpose, which is graphics. So we're amending to our definition here. We not only want the 3D world rendering, which we did last time with CPU, we want a GPU accelerated 3D world rendering. And not only that, I'm also going to add that we want our first class. So we want to use this new Flutter GPU package that was provided by us, by the gods of Flutter, and gives us direct access to this instead of some, plugging like indirect access approach that you could potentially try to do before. So this is our complete problem statement. So the real 3D that we're seeking is using Flutter GPU, first class Flutter package, kind of built into Flutter, basically, built into Impeller, to render 3D worlds using GPU acceleration. So the question is, can we do it? And yes, we can now do it. Kind of. A little bit. But so this is very, very, very bare bones. As you saw, that article was very recent. This has been working on for a while, and as the Flutter team has been working on Flutter GPU, we have been working on Flame 3D in the background at the same time, but it's still extremely bare bones. But I think that's kind of how Flame is. It's like you could use any other game engine, right? Like there are much more mature and established engines out there for you to pick. And I feel like a lot of the Flame is like this exploration and kind of being the pioneer and figuring out how to do things yourself. You know, it's a lot of pick and choose things that Flame will help, and then combining with some things and doing your own thing. And also ties to this like code first approach of Flame, where you're basically, you know, everything is code, and you might need to extend some Flame class to add something that's missing, or you might send us a PR. So if you're willing to partake in this very initial stages, yes, we can get something done. And well, as I said, it's gonna be bare bones. So I'm already gonna start telling you that just to set it up is gonna be a little bit complicated. So we have the Flame 3D package that's published, but you probably, if you're gonna do this, I recommend you clone all the repos and do a pubspec override, so you have always the latest versions of everything. And in fact, you're gonna have to use the Flame 3D branch in the Flame repo, because this is not merged. So the Flutter code is still in main, and Flame depends on stable. So this is not actually merged into Flame yet. So you're gonna have to do some branching, and in fact, there's some other branches you might need. For example, I've been working on animations with joints. So if you want that, you're gonna have to grab this branch. And I also published this Flame 3D Extras package that has a lot of code that hasn't been ported into Flame yet, but they work together really well. They're all connected. So you're gonna have to do some scrapping, putting together some packages to get this working. But basically, as an overview, what we're thinking to do is here you have your code. This is your game, right? Your code, and you're gonna be calling just plain. So the idea is you're not gonna have to interact with Flutter GPU directly, because Flutter GPU is very, very low level, and we wanted to make it easier for you to provide a more high level API that you're more familiar with from 3D in other game engines. You're also gonna interact with Flutter directly, of course, because you still might want to render, the old 2D stuff, or you might want to have interface on top of your game. But basically, your code will interface only with Flame and Flutter. And Flame, I use Flutter as well to do the old CPU 2D rendering. But it will use Flutter GPU. So Flutter GPU, as I said, is basically a wrapper on top of an arbitrary middle layer, depending on the platform, how you access the GPU. This is a little bit of a stretch, because as I said, right now it's actually only Metal, but I'm gonna be saying OpenGL because that's what everyone uses as a standing. But ideally in the future it would be Flutter GPU is a single interface to access any of these. And then that connects to the low level library, which connects to the bare metal, which is basically the bits, and that renders on the screen. So this is kind of the plan. So what I'm going to show you is how Flame 3D works and how you can use it to render things today. So let's see what we have. Before that, I'll make a preamble that a lot of this code was made not only by me, but especially by Johan, or Wolfenring, as is known. So I'd like to give a huge applause for him, please, because this wouldn't be possible without his help. And let's start with triangles. As I said before, I gave a spoiler. I said everything's triangles. I also say everything's matrix multiplication. That's also true. Actually, they're both the same. And basically, this is what everything is. So let's start with triangles. So basically, we're talking about a transformation between 3D and 2D, right? Because in the end, we want to render things on the screen, which is 2D. But in the beginning, we have 3D points. Well, not exactly. We're going to arrange those points as a triangle, because triangle is the simplest surface that you can have in 3D. And with triangles, you can build any other polygon, and you can approximate any shape as well, even if it's round. We're just going to be using triangles because as you might suspect, computers don't do well with round things, so we just approximate everything into triangles. And then basically what we want is this arrow here, which is how do we transform a triangle in 3D space into a triangle in 2D space. Now, I talked a lot about this on the previous talk because we did this basically by hand in the CPU. And we learned that it was all about matrices. And everything we're doing is always multiplying matrices. And this is the second time and final time I'm showing matrices to you, because this time the Flame 3D package is going to do a lot of this for you. So you're hopefully, I don't think you're going to have to know what goes into any matrix, so the numbers inside. You might need to know that they exist, and you might need to know how to create them for certain scenarios. So basically what they are, a matrix is an affine transformation. It's transforming something into a different place. And that includes 3 operations: translation, scale, and rotation, right? So if you have something here and you want to move it, you apply translation. That translation by itself can be represented by a vector tree, right? You're displacing this by a certain amount. But you can put that into a matrix, and the matrix is kind of the standard form, because if you do a scale, you could also represent that for a vector, but that's different than a translation, right? So you put that somewhere else in the matrix. And if you have a rotation, in 3D, rotation is a little bit more complicated because you can rotate around any one of the 3 axes, right? So basically you have 3 angles. So you could use a vector that has some problems. So instead you use a quaternion, which is a more advanced way of describing a 3D rotation. And if you put all these 3 together, you get a single matrix. And the key thing to know about matrix is if you have 2 matrices representing 2 transformations and you want to apply both to the same object, you just multiply both matrices. And you get a new 4x4 matrix that represents the combined transformation. So that makes it very, very easy to keep adding transformations because you keep getting more and more matrices. And as you eventually come to realize, everything you're doing is multiply matrices all the way to the end. But these matrices will hopefully be created for you, so I'm not going to focus on the details on them. The other thing you need to know about 3D is that, as with 2D, you have the camera. That's very important because we need to know from where we're rendering things. But the camera in 3D is much more advanced. Not only it has the position, so that's where it is in space, and then it has a direction, that's where it's pointing at. So you can think of it like this laser beam, right? So it's looking at that. And also, this is a little bit confusing, but it has an up. That's because you can think, even though it has a fixed position and direction, you could rotate the camera, right? And if you rotate it like this, the picture is going to be upside down from how it was before. So you also need to specify the up, which is basically the rotation of the camera. The other terms that you might see as you start to play around with Flame 3D, depending on how deep you go into the cameras, are these. So basically, the camera is representing a perspective projection. There are other forms of projection, but basically 99% of the time, this is the one we're going to use. And the perspective projection, in it, you basically have 2 planes on the z-axis, that's where you're looking at, that define what you can see. The z-near is basically close to the lens, and before this plane, you can't see anything. And the z-far is very, very, very far away, after which we just assume everything is infinitely small and cannot be seen. So everything that you can be seeing, that you can see in the camera, is between z-near and z-far. And then the camera also has the field of view, which is this angle of how much you can see. And if you put these 2 together, you can imagine this shape, which is kind of like a trapezoid. That's called a frustum. That's basically the space that can be seen in the camera. But, as I said, we really don't need to care too much about these details this time because we're going to delegate all this to the GPU. It's going to do all for us. We just need to understand if we see a matrix, that's what it means. But it's going to be done for us by the GPU. Good guy, GPU. Now let's go a little bit more specific into Flame 3D code because I feel it's still a little bit too abstract. And in Flame, we're going to get to the concept of a mesh. And that's basically the most basic thing you're going to render on the screen. But before we get to mesh, we start with a vertex. So a vertex is a point in space. Very, very basic in 3D space, right? A 3D point. And that's the key ingredient that's going to make the meshes that we're going to render. Now, this is a version of the actual vertex class from Flame 3D. And you can see it has a lot of things. It not only has the position, because what this class is basically a byte buffer. It's the storage of all elements that we're going to send to the GPU to tell it what to render. So this is kind of data structure that we're propagating to the GPU. And as you can see, it has the vector 3 position. That's where it is. But then not only that, it has a texture coordinates and color. So these two things are going to tell the GPU basically what color to render that triangle, either based on a texture or based on a flat color. Now, one thing to demystify here is that these vertices are not like pixels. We're not going to say the color of each pixel like you might do in 2D. These vertices are just the edges, the vertexes, the border of a triangle. So what the GPU is going to do is going to linearly interpolate your colors to paint that triangle. So if all your 3 vertices of the triangle are the same color, you're going to get a flat triangle of that color. That's probably what you're going to do, or you're going to use a texture. If you want to put different colors on the vertices, you get some pretty like stuff like the ones Renan does with the shaders. But probably you either have a flat color or you have a texture. And you can see the texture is not specified here because it's specified at the surface level, which you're going to get there. But what you do specify here is the coordinates of the texture. And that's basically, so a texture is just a 2D picture that we're going to stamp on 3D surfaces. And the way we stamp it is by using this 2D coordinates of the picture mapping to this vertex. So basically, if we had a triangle, and we could say one edge of the triangle maps to here, one maps to here, one maps to here, the picture on the triangle would be this triangle here. If you do something different, it's going to distort this image to conform to the shape that you want to draw. Next, we have the normal. So another vector tree. This is the normal to the surface of the vertex you're drawing. So if you have a surface and you have this vertex, right, on the edge, it's going to be an edge. So the normal would be the perpendicular vector coming out of it. Now, why the hell do you need to specify this, right? It doesn't matter to render a triangle where the norm of the triangle is. We specify this for lighting. So I'm going to show that another very important thing in 3D is that we have basically a lighting engine that we want to specify how things should be lit and how they should react to light. In order to do that, all the physics formulas that define this require us to know the normal. So that's why this information is encoded there. And then finally, we have 2 vector force that are intimately related that are called joints and weights. These 2 are to do skin animations. So it has to do with animations that have a skeleton. And I'll explain that later, but it doesn't matter. If you're drawing static things, it doesn't matter. And then all these guys, all their bytes are packed together into this storage, which is about 16 bytes, or 12, I think, with all these things. But we don't send each vertex to the GPU. That will be too many trips, right? We want to pack them together. Oh, yeah, let's actually talk about this first. We're going to pack them together into a surface. The surface, before I said it was triangles, but it basically can be a triangle strip because you can have multiple triangles from a single surface. So for example, if you're rendering a cube, each face of the cube is a square, right? Or a rectangle if it's a different size cube. But we can't draw a rectangle, so what we do is we draw 2 triangles instead, right? And you can have any number of triangles. So instead of sending all the vertices 3 by 3, we send the whole array of vertices that represents the entire surface at once as a single byte buffer. So that's the list of vertices. There's some other stuff here, for example, indices. That's just so we don't repeat the vertex. So if you have repeated vertex, you can use indices to kind of identify them like a variable. And then we have the material. This is where the texture is. So if we're using an image, the byte of the image will go in here and will apply to the whole surface. We, of course, don't want to replicate that for each vertex because the whole surface uses a single texture. And then we have this joint map, which again has to do with the skeletal animations that we don't care about right now. And that's creating the surface. And then we send all that to the shaders. So the shaders is the language within OpenGL that allows you to do operations on the GPU. The same way that you have your Dart code doing stuff on the CPU, and you can write, equations and stuff, and that's going to run on the CPU. The shaders is the way you run code on the GPU, basically. And what they're doing here is multiplying all those matrices for you. Now, when you render something with Flame 3D, it already has these 2 shaders for you. So theoretically, you don't need to write any shaders to do your game. If you want to write a shader, you can get some custom behavior, but it's really not necessary. So that's why I'm being very, I'm just showing that this exists, but I'm not going to explain how shaders work. If you want to do something custom, you're going to have to look elsewhere. So I have a resource here. It explains very well how shaders work and how you can build your own. Just as an example, this is one of the shaders, and it is the most simple one possible. It doesn't have the joints for the animations, and the other one is even more complicated. So I don't want to get into that. But basically, what you need to know is that all these bytes that we're sending to the GPU are input to this procedure, this code language, that is transforming that into the pixels you see the screen. So this is what's doing all those transformations. This is the yellow line that we didn't know about. Okay, so we have the surface, but I promised you mesh. I said the most basic thing that we render is a mesh. So a mesh is basically just a 3D object, right? So what it has is a list of surfaces. So for example, if you have a cube, you know, it has all the 6 sides. Basically, that's it. It also has an AABB. That's a very common term within 3D programming, and it stands for axis-aligned bounding box. So it's basically the rectangular box, the smallest rectangular box that your shape completely fits inside. And this is just used for either collision detection, but in our case, for culling, for a simple pass to determine things that are like behind the camera or outside the camera that we can't see. We just want to quickly skip those things. So we don't want to do checks with the complex geometry. We just want this box as like a first pass. So we're sending this list of meshes to the GPU to render. So what does that look like? I said a lot of complicated things, right? But it's actually pretty simple to render. If you just want to render a cube, that's all you need. Because in order to render the cube, you need to define all those triangles, right? So if you look at this photo from before, you can see that each face has 2 triangles. So basically, we're talking about defining 12 triangles, each one with 3 vertexes. So if you wanted to render a cube from scratch, you need to define that. Now, of course, I already did that on Flame. So we have the cuboid mesh, and this has all the list of vertexes. You can see it's huge, but it's pretty simple, right? Like it's just, you can very easily geometrically figure out all these positions because it's a square. So in your user code on game land, you just create a cuboid mesh, you tell us the size, and it will create all the vertexes for you. It's gone. And then you create a mesh component that's just the Flame, tying into the Flame component system, basically saying, render this mesh. So you can see all that boils down to very simple code if you want to render a cube shape specifically. Now, of course, you're going to want to render other shapes, right? And then basically you're going to have to define all those vertexes yourself, which, as you saw, it's quite a pain just for a cube, right? So you're probably not going to do that. So at this point, I would have 2 questions. First one is like, how define this vertex in a better way, because I don't want to do that manually. And the second question is, what about this lighting? I guess you can't see. But you can remember that the cube had some lighting on it, right? So we're also going to talk about that. Is there any questions in the meanwhile? What do you mean by observability? So, you have a 3D scene and you want to view the scene basically as you would in Unreal Engine. So for me, one of the core concepts of Flame is that it's code first. Yeah. I feel like a lot of game engines are like editor first, right, where you just drag and drop things. So I want things to be code first, meaning there has to be a code way to do things. So you have to be able to add a cube like this. Now, that doesn't mean you cannot have an editor, right? It's definitely not on my roadmap because, as I'm going to show, this is very bare bones, meaning there's a lot else to do first. But eventually, I could see there being like a 3D viewer or a 3D editor. What I do, honestly, I just throw things and then I run the game. And Flutter has graced us, the gods of Flutter graced us with hot reload, right? So it's actually way easier than in other engines to where you can just the Shift R and you get your new stuff. So I use the game itself to view where the objects are. But I definitely think an editor could be a potential thing. I know other people have been working on sort of editors for Flame 2D. So I wonder once we have this, if that can be expanded for 3D as well. Again, we're talking about very future deadlines here. More questions? Yeah. Like the currency? Is that a file format? I see. Yes, I have. So I'm going to talk about loading models on different formats in a bit. I assessed all the available. I kind of remember that one. I kind of went for the open source route, so I picked OBJ files and GLTF files, which I believe are quite similar. I didn't want to go into the other ones because there's just so many and they were not open source. But of course, like anyone can make a loader into this structure. So I would envision that eventually Flame would, have loaders for all different kinds of formats. But that's why we need the community to help. But we'll get there. I'm going to talk about models. So the two questions were, where does lighting come from, and the models. But let's talk about the lighting first, because that's the order I put in the slide. So in order to render anything, you need light, because without light, you can't see, right? We all know that. That's physics. So currently, we have two types of light. The first is ambient light. That basically applies a static light to everything. So that's kind of what you would expect if you didn't know you could do lights. If you don't add this one, everything will be black. I just need to say this. Otherwise, you might be questioning why things are not showing up. But you don't really need to have that one. If you want to do like a darker style game where everything is lit by point lights, you can. The point lights are the realistic lights where it emits light all directions from a point and then attenuates. In real life, everything is a point light, but it just so happens that we have, for example, the sun that's so far away and so bright that it kind of becomes an ambient light. So that's a simplification that we have. In most games, you're going to have some sort of ambient lights, and then you might have some different point lights if you want to have like a specific light source that's a little bit brighter. And as you would expect with a light source, you can specify the color and the intensity. For the point light, you can specify the position. The ambient, obviously, by its own nature, doesn't have a position. It's everywhere. Let's look at what it looks like into the component tree, because it gets a little bit complex. So we all know from Flame, which is in blue here, like the normal Flame, we have components. And then we have position components, which probably, most components you have in Flame 2D are position components. They come in with that vector 2 position, which is their 2D position. That's all for 2D worlds, right? So luckily, we have this base class component on Flame that doesn't have anything, and that's what we extend into component 3D, which is the equivalent of the position component, but for 3D. It has the 3D position and also the 3D orientation of the model. Similarly, in normal Flame, you have world. We're going to have world 3D. And you have the camera, you have a camera 3D. And these things just extend their 2D counterparts. So very simple so far. Now, where it gets complicated, I kind of created this distinction. I'm not sure I still like it, so we might change it. But I thought that it made sense that the lights are not the same thing as the objects, because the objects are rendered themselves, and the lights are actually not rendered at all. They just change how other things are rendered. So I kind of separated them. We might bring them back together. But what really matters is you have this abstract component 3D class that can really be used, and then you have to choose either, if it's an object, it has its like render things, and if it's a light component, it has a special treatment within the engine. So probably in other engines, the light wouldn't be a component in the same sense that the objects are a component, but within Flame, we're trying to adapt this to our like philosophy, and where everything is a component, so that's kind of how it's designed. So the lights can be ambient or point, which already explained the difference. There exist other types of lights. Again, actually, everything is point, but there are other simplifications of lights. So for example, if you want to have sunlight, that would be a possibility that we haven't implemented. And then the object 3D, where this is how the mesh component. That's how we render that cube. But we also have a model component, which I'm going to show in a bit. That's how you load the files, like potentially the USD file. Now, how the lighting actually works, again, I'm not going to explain this because it's based on a little bit complicated physics formula, so you might have to dust off your physics books if you want to remember this. But basically, it's all done by the shader. It's all done by the GPU. You don't need to worry about it, right? We just specify where the lights are, and we have these transformations on the shader that calculate how things should be lit based on where the lights are. It's kind of like the light is not active. It doesn't do anything. It's actually the objects being rendered that kind of look up where the lights are. So it's a different system. Some things we don't support is we cannot have an arbitrary number of lights because I'm still trying to figure out how to do dynamic arrays in the shader language. So right now I think I added 3. If you want to add more, it's extremely trivial, but you have to kind of copy and paste some code for now, which I hate doing. So I'm trying to get the arrays to work. We also don't support some more advanced parameters, and we definitely don't support shadows. So there's no occlusion yet. That's an even more advanced formula than this one. Another thing here is that PBR stands for physics-based lighting. That's like the underlying model behind what we used. And one interesting thing about this model is that every material not only has its color and texture like we saw, but it has a few parameters that define how light applies to this object. So for example, how metallic it is, how reflective it is, that kind of thing. So we're gonna see some different renderings using different types of PBR parameters. Another thing that affects lighting is the normals that I talked before. There are 2 different ways of doing normal. The key problem here, let's say, is that the normals are per vertex, right? But if you think of a 3D shape, you always think of normals for a surface, right? You have a surface and you have a normal. How can you put a normal into a single point? Well, you can't. You have to tie that back to the surface. So there are 2 ways of doing that. The simplest to understand way is face normals. If you're using face normals, on each vertex of each face, you draw the normal relative to that face. That means that this corner here would actually be 3 vertexes, right, that are different. Because each vertex on each face has a different normal. So the front face would have a normal this way. The top face would have a normal that way. This face would have a normal this way. That means we cannot use that optimization of the indexes, right? Because even though this vertex is shared across multiple faces multiple times, each time it has a different normal. So another way to do the normals is to do the vertex normal. In that way, we kind of do the average of the normals on that point. None of them are more or less physically correct. They could both be argued for. They just have different results. So this gets a more smooth, and this one gets a more like diffuse looking thing. Now this doesn't matter that much. I have here an example of a model that I loaded. You can see it looks totally different because of those PBR parameters. So this cube was defined as being very metallic, so it has a completely different appearance than these ones that I created using the cuboid mesh. So basically defining the vertexes by hand. Again, just something that you should have in the back of your mind. If you're having different lighting than you expect, it might be because you have the different normals pointing differently. I actually forgot what this video is, but let's watch. Oh yeah, this is a demo of the lighting that I perfectly cropped with no errors. Oh yeah, actually I failed to see the moving. Oh, thank you. But the light is actually, the green light is moving. Yeah, I don't know if you got to see that. Maybe it's impossible. Yeah, there's a green light. So there's a static light, and then there's a green light moving here. I should have made that more intense. I didn't realize. There's also like a reddish light. You can kind of see they're all blending. So this is how you do lighting. This is what lighting looks like. Thank you. Now, let's talk about models, because we don't want to define those coordinates of all the vertices by hand for every single element, right? So we want to grab some from the internet, like the teapot that we did last time, and we want to just render it. So how do we do that? Well, we have to parse some file formats. And basically, as I explained, I picked two of them, the object and the GLTF, also called GLB. I'll explain the difference. These two is what we have right now. But there are others, like FBX. I guess I forgot to pick another one to put here. There's one called Colada, and there's USD. So eventually, we could have all of them, but right now, we have these two. I'll talk about the object first, because it's literally the simplest possible file you can imagine to describe a 3D object. It's literally just a text file where you have each line is the coordinates of one vertex, right? These are comments that are just ignored. Then you have V, that's the vertex. VN is the normal. VT is the texture coordinates. And then the material. And then you define the surfaces, which are the triangles. This is in the format V, VT. So this is kind of defining, like, predefining the coordinates and assigning, let's call an ID, that's an index to it. So this one will be index 0, the next one will be index 1, and then this is basically saying, make me a triangle, use the vertex ID 1, ID 2, and ID 3, use the texels ID 1, 1, 1, use the normals ID 1, 1, 1. So this is basically the simplest possible format that you can think of to describe these vertexes and their coordinates. So I first implemented this one. Now, I actually did this a while ago when I started working on this, and I had already shared I think it was on a FlameCon, this video where this is the first 3D proper game that we make. It is very, very simple, but I wanted to make a game like beginning to end with like menus and sound, kind of have it all working. So this is called Defend the Donuts. It's a very stupid idea. It's basically you have this space donuts that you have to protect, and you protect it from some ships that are going to show up and start attacking it. I did this because I found these models as object files, and because it needed no animation. Everything here is done by hand, so the rotating donut is not an animation. I'm just rotating it myself using the matrices for rotation. And then eventually, should have made it quicker, I guess. I promise a ship will show up. Yeah. Well, it's give you a briefing room, right? To get used to it. Yeah, there you go. Ships are approaching, and then you can shoot. With very simple collision detection just for the bullet, so you can pass through things because we don't have physics. But I wanted more. And if you look up models online, you're probably not going to see object files because they're too simple, and they don't support a lot of things, like animations and skeletons that I was talking about. So there are other formats. So the one I picked was GLTF. It is defined by the same open source committee that defined OpenGL, but it's not specific to OpenGL. It's a completely independent thing. But it stands for GL, graphics language, transfer file, or transfer format. There are two versions of it. The GLTF is a text file version, which is a JSON that describes the things. But it's kind of half and half, because the JSON part just describes the basic properties, but the actual vertex data is in a binary format inside the JSON. And then the GLB is a complete binary version of the same structure. So it uses this concept of byte buffers within the file, because it would be too big if you were to, within the JSON, have like a JSON array with all the vertexes. That would be extremely big for the types of models that we're talking here. So it defines the metadata as a JSON, but the actual vertex data, it just puts the bytes there. So it's a little bit harder to parse, as you might imagine, because I just have to look up those bytes and figure out what they mean and convert that into the Flame structure. But it supports a lot more things. It supports scenes and nodes, it supports animation. So in order to kind of support that, I created a new component called model component that uses this model data structure. This is a little bit more involved than a single mesh. So the idea of a model is a mesh would be, as we saw, like a 3D solid, right, like a cube. And a model would be a combination of multiple meshes that form what would be in Flame 2D a component. So one character or one gun or like one thing that exists by itself in your game. So all these meshes like move together, basically.
It also supports animations. So it has a list of animations that come from the file, and then from the model component, you can do play and play any of these animations, similar to Rive components, if you use Rive with Flame. It has a list of nodes. So instead of being a plain list of mesh, it actually has a tree structure, because some nodes depend on the position of the previous parent nodes. So it's just a hierarchical organization structure for the meshes. But basically, every mode, it might be just a grouping, or it might have a mesh. So you can think of a node as maybe a mesh, but it's organized in this tree structure. So it has the transform. That's, again, how it's rotated, translated, and positioned. Remember, whenever you see matrix 4, you don't need to go inside, look at the numbers, but know that that means translation, rotation, and scale, right? It also has a joints data that's used for a specific type of animation, which is skeletal animation. And then it has the animation here, which is used for both types of animation. The animation is basically, again, a set of matrices that describe how the vertex move through time. And it's basically a loop. It's always a loop that you're going to be playing. So let's look at a video of some models being loaded with lighting. And one of them has some animation there. So this is a real animation here. It's not me doing the transform. This animation is part of the model file being played. We have a very metallic cube and some characters. And also you can move the lights. I don't think I mentioned that, but yeah, obviously you can move the lights. Yeah, that's what we got. Thank you. But there's a lot we don't have, especially polish. So again, this is very, very bare bones. For example, I couldn't figure out how to do arrays. I think it doesn't work with Flutter GPU right now. So I had to do this disgusting nonsense, because I'm very creative and I can do arrays without arrays. Yeah. There's SSBOs are like dynamic arrays. I cannot even do static arrays to begin with. We don't have shadows, we don't have physics. It's probably not optimized. Some stuff I just got it working. It runs really fine with that example, but as we scale, we might need to do some optimization. Anyway, this is a call for help. This is like, if you're interested in this kind of stuff and you want to be a pioneer and you want to not only build your game, but also probably send us a lot of PRs and fix some bugs and contribute, I invite you to join our cause and build some 3D stuff. I guess I'm out of time because Spider is standing right next to me. I'm going to skip all the learnings and just say questions. We don't have time for questions either, so I just skip to the end. Thank you very much.
Yes, we do indeed not have time for questions, but,
yes, but you can ask
like
me.
with others, yeah, you can ask him out there. He's very friendly, won't bite that much. Yeah, we'll have a few minutes now, and then Pavel will come up on stage here. We're just gonna set up, and I think downstairs they have already started another talk, since this went over time a little bit. And after this, there will be some fika outside. It's a little break. I haven't tried this. I just got it handed to me like that.
I look at like
All right, it looks like everyone has gotten seated, so let's get started. And for this session, we, like all of us, have probably built a lot of small apps, but it becomes quite different when you scale up, when you have a large team, and yeah, things change. And Pavel will tell you a little bit more about that, so give it up for Pavel. Woo!
Hello everyone. Good afternoon. The topic of code quality is on the table today, and I hope you're excited about that. Well, at least I am. And I'm also curious, how many of you guys are happy and satisfied with code quality on your current project? Please raise your hand to let me know. Just, yeah, very few people, very few. No, only your current project, like where you work most of the time. All right, and who has more than 10 Flutter developers working on the same code base? Okay, that's more people. I have some good news for you, because my goal for today is to empower all of you guys with guidelines and tools so that you can use them to set a higher code quality bar and keep it there with less manual effort. Before diving into the topic itself, I would love to give you a bit more context about me. My name is Pavel. I'm a lead software engineer at EPAM. The first time I encountered Flutter, it was 2018. Loved it. And since 2020, I've been doing the Flutter development full-time. I also maintain a technical blog that you are very welcome to check out. And here today, I'm representing our awesome Flutter Netherlands community. Enough about me. Let's get the ball rolling. And first things first, continuous integration and continuous delivery is a must. So if you don't have it on your project for whatever reason, make sure you do. And if you hopefully do have it, let's see how you can enhance your CI pipeline to make it even more robust. The code quality gates I'm about to walk you through are divided into 3 categories, and I divided them so based on the amount of effort it takes to set them up. So consider starting with the basic ones first. And the first one on the list is code formatting. Dart tooling offers an option out of the box to help us with that. That's really cool, but do not limit yourself to Dart files only. Consider for more options. For instance, if you use the tool which is called Prettier plus Node Package Manager, then you can easily achieve consistency and good formatting in your JSON, Markdown, RB, and different types of files. Similar advice applies to spelling. Everyone makes mistakes, including spelling ones. Check out the popular tool called cspell. I've seen it used on a number of open source projects. And in addition to that, make sure that you install a plugin to your IDE, and then you should be good to go. When it comes to static code analysis in Flutter, you should know the following. That's good that Flutter Lins package, which comes out of the box, helps us with that. But from my point of view, that is not enough. Look for these tips. First of all, consider failing your CI pipeline not only on the presence of errors, but also on the presence of warnings and infors. Then consider enabling strict type checks. And in addition to that, make sure you enable more lins. As you might already guessed, Flutter Lins package covers only a subset of lins available out of Dart SDK. If you take a closer look at this table, you'll notice that it's less than a half. It's only 46%. And if you, for instance, use a very good analysis, then your code base should be in twice as good shape. Taking a step further would involve the integration of additional lins provided by the community. Dart Code Metrics has been the most used and well-known package. It was introduced in 2020, and our teams have been using it for years. And even though it was discontinued last year in favor of DCM, it is still possible to use the old and free version. The next level of linting involves the integration of custom lint. With this library, you can develop lints tailored to the specific needs and requirements of your team and your project. And another promising tool, which I discovered about half a year ago, is called Pyramid Lint. pyramid lint uses custom lint under the hood, and it provides more than 40 lints out of the box. Some of them are presented on the current slide. For instance, you can easily detect whether you have your resources properly disposed, or if you have any global variables, mutable global variables, which I would not recommend for sure. So really, really cool stuff. When you're confident with your linter setup, the next step for you may be devoting more attention to your architecture. Every serious application uses some sort of architecture, having various layers and following certain rules. So I highly recommend using physical separation over logical. And what I mean by physical separation is that you'd better create physical Dart and Flutter packages instead of having just mere folders or directories. For the sake of conveying the idea, in one of my articles, I took the default Flutter count application and got it refactored in a modularized solution with the following 5 modules. If you're familiar with clean architecture or domain-driven design, then those names should be already known to you. Nothing fancy here. What are the advantages, you may ask? Well, first of all, you have strict visibility control, meaning that you have package-level encapsulation. Compiler is playing on your side with this setup. Second of all, you have potential for reusing your modules in another application or multiple applications. And in addition to that, you also may benefit from additional build and CI time optimizations. When you have multiple Dart and Flutter packages living in the same Git repository, this is usually something which is called a mono repository. And when it comes to mono repositories, there is one tool that you should be definitely aware of. The name is Melas. Yeah, it helps a lot in managing a mono wrapper, and you can easily execute all your scripts for all your packages or across only a subset of them based on some filters. You can also update your external dependencies in one YAML file instead of doing it kind of in all the files. So I can recommend this tool without any doubt. One interesting thing or nuance about mono wrappers in Dart, which surprised me back in the time when I found it out, is the possibility to have cyclic or circular references. Surprisingly, Dart can compile such a mono wrapper. It does not have any issues with that, but I do. I don't think this is the best way to move forward, so luckily, Melas has a remedy for this as well. With such a simple command, you can detect those violations, and if you're doing good, you will see the following positive message. It means that this validation can easily be integrated in your CI pipeline, and what I especially like about this command is that it is super, super fast. It gives you the result in less than a second, even if you have hundreds of packages in your mono wrapper. Also be careful with how you deal with your external dependencies. Every Flutter application relies on some external packages or plugins from PubDev, and Dependency Validator can easily spotlight those missing, underpromoted or unused dependencies. So consider integrating this in your CI pipeline as well. Let's move on. And the next one is called duplicates. I bet we all sometimes just copy and paste some pieces of code instead of doing the proper refactoring right away. This may be fine when you are doing a POC, but in the long run, this is not a maintainable approach. And this tool can easily spot these issues, so you don't accumulate technical debt. You can adjust its strictness as well as exclude certain files like generated files or tests, for example. And who here writes any tests on their Flutter projects? All right, at least half of the people. Well, if you want to get any serious about automated testing for your software, there is one key concept you should be aware of, and this is the testing pyramid. A few things to remember here. First of all, write tests of different type or of different granularity. And second of all, the higher you get to the top of the pyramid, the fewer tests you should have. Why? Because they're more expensive. they're more expensive from both maintenance side and from their execution resources side. Let's briefly touch each of these types. When it comes to unit testing, I recommend testing the behavior and not the implementation details of your units or your classes. Read about black box testing versus white box testing. Read about the difference between fakes and mocks. One of the implicit advantages of unit testing is that you inevitably have a better architecture of your code. Also, consider using first and arrange act assert principles, and these are the packages that prove to be quite useful for our teams. Clock, fake async, mocktail, parameterized test. Okay, now I would love to move on to widget testing. Be aware that you can test not only the behavior of your widgets, like tapping a button and changing the state of checking the change of a change state, but you can also test accessibility. More and more companies nowadays try to make their applications accessible to everyone, including impaired people. So this topic is gaining more attention. A special subset of widget testing is called golden testing. We love them and we use them a lot. Basically, an image of how a widget looks like is taken and saved into a file. And when you run the test the next time, a new image of a widget is taken and compared pixel by pixel to the image in the file. And if there is a pixel difference or any small difference which you can set up, then such test fails. Really cool type of testing. One of the ways to encourage, or let's say force developers to write tests is to use a code coverage check in your CI pipeline. My advice here is to be reasonable. Striving for 100% code coverage is not always the best idea. So think twice before setting this rule. What you can also do, you can also set different thresholds for different modules. What do we have the next? End-to-end integration testing is usually a less used option, especially on the projects of smaller or startup-like size. However, this can give you a good return of investment if you do it the right way. And choosing the right testing tool, environment, and approach is something of vital importance. So sync up with your QAs, sync up with your automation QAs if you happen to have those guys on your project or in your company, and then you should be good to start. This comparison table provides you an overview of the popular tools suitable for Flutter applications. On one hand, the tools like Appium and WebDriver.io are quite mature and have been there for more than a decade. On the other hand, the more recent players like Maestro and Patrol are quite young but quite promising and may even surprise you. Just to give you the notion of how easy it can be to write an end-to-end integration test, I decided to wipe the dust from one of my pet applications, which I released almost 5 years ago. It took me literally less than 20 minutes to install Maestro on my machine, on my laptop, to play a bit with Maestro Studio, where I could inspect the UI elements of my application, and then write this test in the YAML format. The source code of the test you can see right in this video. I didn't have to install any dependencies or do any configuration inside my application, which means that with the right testing tool, the approach can be, or the process can be really easy and really enjoyable. A really outstanding type of testing that you may have never heard of is called architecture testing. I really love it, I really do, and your goal here is to automate the validation of the architecture rules that you have on your project. I bet all the projects of a big size have some architecture rules that usually are verified by people during the code reviews. And my big advice for you is to try to automate those rules as much as possible, and then you can rest assured that everything is working or is architectured up to your expectations. Get some inspiration from the tool called ArcUnit. This is the tool which exists in Java and .NET worlds, not in Flutter, unfortunately, but I think you may get quite some inspiration from it, and I think you will be amazed in the end. To give you the notion of how an architecture test may look like even without this tool, with some simple, more naive approach, this is one of the examples of from my previous project. We had a feature-oriented architecture, and one of our rules was that our features should not depend on other features for the sake of low coupling and high cohesion. And with the help of such a simple test, we were able to achieve the automation, the automated check, and it proved to be quite powerful and completely covered our needs. Having gone through all of these code quality gates or CI checks, you may be wondering, how much time could it take to run all of them on a project of a huge size? Well, obviously it depends. It depends on the project, and it depends on your setup. But what I can recommend doing is to look for some optimizations. You can obviously run things in parallel, but what you can also do is to scope your checks or to be selective. Let's say you have made a change only on the presentation layer of your application, only inside this package. For instance, by changing a button or adding a new screen or changing the existing screen. In this case, it doesn't make that much sense to run all of your CI checks on the domain package, for instance, or on the data package, because those packages have no dependencies on presentation, so it will be a waste of resources. What does make sense is to run all the checks on presentation one, obviously, and on the one which depends on it, the application package. It's awesome that Melos can also cover us here. You can use one of its commands. This command uses git diff under the hood, and it can find out the packages which have changes in the current Git branch compared to the other Git branch. And you can use this list of packages as a global filter for all your Melos CI commands or CI checks. So save your time, save your money by checking and validating what is really needed. Overall, the more validations you can automate and put in your CI pipeline, the easier it is for you, as you can focus on other things during your code reviews. So set stricter policies for your pull requests, be consistent, try to automate as much as possible. And I think using this advice, your code base should be in way better shape. Hopefully, it gives you some food for thought, and I would love to wrap it up with the following idea. Some people say that knowledge is power. That's true, isn't it? That is true, but that is true to only some extent, I would say. The real power comes when you apply the knowledge, when you put it in practice. So don't postpone until tomorrow what you can do today. Try to make your CI pipeline as robust as possible so that the next time I see all of you guys and ask a simple question, how satisfied are you with the code quality on your current project? The next time I ask it, I hope to see way more raised hands, not just 4 or 5 hands that I saw at the beginning. Well, you can use this QR code to navigate to my technical blog where all of these topics are covered in way greater detail with code samples and links to GitHub. Check it out. I think you may find something useful. That's it for today. Cheers. I'll see you the next time.
Thank you.
Do we have time for questions? I think we don't, do we?
You can take 2 questions. I'll allow it.
All right. I see the question in the second row, in the third row.
If you say the question, Shatai, I can repeat it for the stream.
So when you have this diff checking before testing, 11 is cost effective, right?
Yeah.
As cost effective.
Yeah.
Have you considered making it even like folder specific changes?
No.
So the question was, Oh my God, I got this right.
I can
If there was, oh yeah, you can say it. Repeat.
Yeah, the question was about the scoped CI or selective CI. If we consider doing it not on the package level, but on the folder level. Now we have not considered that, so we have quite some packages. We have a modularized solution, and the package level is more than enough. In our mono wrapper, which has about 80 packages, I think, nowadays all of our CI checks run on average under 4 minutes. So it takes about 3 minutes to run all of the CI checks, because usually it is for a few packages, and it works really, really, really good for us. So it saves quite some time and resources. Yeah, you're welcome.
Well, so the question is, they're also using Maestro in their pipeline, but and to test different native features, right? And they only do it for Android currently, and they're asking about iOS support, I guess.
Well, I have not used Maestro on production. On production, we are using WebDriver IO because of the legacy reasons, and because we have also native applications, and our automation QAs are experienced with that tool. So I just used it for my pet projects to play with. And the question is if it's possible to use with iOS. I think I saw an issue to run it on iOS devices. I'm not sure if this is still an issue or if it was resolved. But if you at least run in some end-to-end integration testing on one platform, I think you're in way better shape than if you're not doing it.
All right, super. Thanks a lot, Pavel. Give it up for him again.
Oh, thanks.
And now it is fika time, which is a very mandatory Swedish thing. So you go out there and have some fika, get some renewed energy, and we'll be back here in around half an hour or so. Nude energy. Nude energy. That's very Swedish too.
Professional photographer.
Yeah. It was a very good. All right, I hope you all have gotten some nice energy from the fika. Next up is Akanksha with a very important topic about accessibility and also how to more easily adapt your app to accessibility, right? So give a round of applause for Akanksha.
So hi everyone, thank you so much for coming to this talk. I'm sure like today's schedule, like there are a lot of amazing talks and it's really hard to choose which one to go for. So I'm really thankful for all of you for joining me in this talk on automating accessibility adoption in Flutter using Gemini AI. So let me quickly introduce myself. My name is Akanksha Singh. I'm a software engineer at JP Morgan Chase and I came all the way from Glasgow, Scotland. And I'm a Women Tech Makers Ambassador and also a Flutterista, and there are other Flutteristas present here. So if you are a woman or a non-binary person and you want to join this inclusive community with more folks interested in Flutter, so please feel free to just bump into any of us and let us know. And I also love doing hackathons a lot, and I'm part of a lot of good tech communities, and Flutter is one of them. And apart from that, like, yeah, I like mentoring and speaking and sharing my experiences. So yeah, that's a little bit about me. You can connect with me on Twitter. So my handle is coder_Jedi. And yeah, let's jump on to question first. So I want you all to like guess which country has the, I think it's a very easy question. So anyone, which country has the second largest population in the world? Yeah, it's the right answer. So everyone knows that. That's good. So I'm originally from India as well, and I know the population is huge. It's a huge country, very diverse culture. And the current population of India is 1.4 billion, which is huge, right? And it's also like 16% of the world's population, which is pretty much the same amount of like same number of people who have some form of disability. So you can imagine like a big country like India, if you just ignore their needs or their you don't consider their user experience and you just make your apps. So I mean, everyone wants their app to reach to as many people as possible, and they want to have a huge audience. Obviously, revenue is one thing, and you also want your apps to reach to everyone. So you can imagine how big the number is, and that's why it's really important to consider accessibility in our apps. So the agenda is going to be very simple. I'm sure everyone attended the keynote today, and Craig also talked about a lot of things related to accessibility, and there was an amazing talk by Simon as well just before this. So yeah, so just a little bit on why accessibility, and then some common challenges that we as developers and as teams face, and why we are not able to focus that much on accessibility. Then we're going to talk about shift left, which is an approach to optimize this process. And then we'll jump on to Gen AI and accessibility, and then tools, pros and cons, and then I'll conclude my talk. So that's the quick agenda. I'm sure everyone saw this in the keynote. So basically, these are called curb cuts, and they originated in the United States after the World War II, when the disabled veterans like came back to the country, and like they were not able to use the sidewalks like properly. So this is how it was originated. And then if you see, it was originally like made for them, but it is now being used by like people with strollers, cyclists, and everyone who wants like a smoother transition between the sidewalk and the street. So this is this actually then gave this like curb cut effect came into being like after this. So whenever you try to make something accessible, it not only makes it accessible for them, but it also makes it accessible to a wider audience. So that's why it's really important to consider accessibility. And in digital world, there were a lot of examples in Craig's talk as well. So one of them is like alt tags. They were originally like for screen readers. So if the person is using screen reader, and then it will just pronounce like, or it will just alt tags help the screen readers in like saying that picture aloud and what it is actually. But apart from that, they're also useful for search engine optimization and also a fallback content for when the internet is slow and you're going through a website and you can see what the picture is going to be about. So that's like a curve cut effect example, and there were a couple more earlier today. So now that we know there's like a huge number of people who will benefit from accessibility, and also even more people because of the curve cut effect. So now what are the challenges that we as teams or like developers face in the current landscape? So one of the example, or like I have another question here. So how many of you are confident that you know like 5 to 6 WCAG guidelines? Just some hands, please. I can see very few of them. So yeah, so a lot of us aren't aware about accessibility, and that's one reason why we don't focus on it much. So that's one challenge, the lack of knowledge. It makes it difficult to implement accessibility features. Another thing is if you go to the WCAG documentation, I mean, there are a lot of guideline documentations. This is the official one, obviously, the WCAG one. And if you go through this, I mean, there's no example, proper example, visual example. So it's not the best like readable form. And for designers or like for people, like a good documentation is the one that has some examples, some visual that can help you understand why it is important. So the WCAG guidelines are not the most accessible content, I would say. So that's another challenge, I feel, that they are a little bit complex for us to understand and like go through them. Another challenge is testing and validation. So I have previously spoken to a lot of people in conferences, and one of the main challenge they feel is testing and finding the right users when they are developing the apps and like trying to implement the accessibility features. And doing it themselves is fine, but like having a real user or like some users to test the apps and their accessibility feature is also like, it's one of the challenge. Another thing is like we have some of the folks like, because most of the startups or like even like when you have very tight deadlines, you just build the app and try to focus more on like building all the features, and you don't focus on the accessibility part that much. And then when you have the whole app ready, the whole code base is done. And now if somebody would come and say that you have to work on accessibility and those features and like make it more accessible, it's gonna be a little bit difficult for sure. So that's another challenge. And I mean, this can be minimized. Some of the challenges can be minimized if we adopt to shift left approach. So even though these challenges, like there are a lot of them, but some of them can be minimized by adopting the shift left approach. And basically, it's thinking about accessibility at the start of every step that we take in the software development lifecycle. So as you know, there are multiple steps in software development lifecycle, and we start with like gathering the requirements, then designing the system and everything, and then implementing and testing and deploying. So if we start thinking about accessibility from the very beginning, when we get the requirements, I think it will make the process a lot easier. So that's what the shift left approach is about. So when you get the requirements at that phase, you try to think about accessibility and try to think about the like requirements if you will be having any accessibility issues and stuff like that. So yeah, it's the shift left approach. It can definitely help you minimize. And how can Gen AI help you in like making this process even more optimal? So some of the phases, like the initial ones, you will have to do some of the work. But when you are in the coding phase, when you're developing your app, from the initial point when you start coding your app, I think Gen AI can definitely help you in speeding up the process of adding accessibility to your app. And that's what I'm going to talk about today. So by using Gen AI, we can make the process more optimal. And generative AI is everywhere. It's like AI, generative AI, and this time even Sundar Pichai mentioned the number of times AI was used in the Google I/O. Last time it was like too many times, and I'm sure everyone must have seen that meme with AI, and AI. So yeah, basically it's the buzzing thing, and we should definitely make the most of it. And it looks something like this for normal people. You just give a prompt and abracadabra and you get the result, right? But there goes a lot of things behind the generative AI models. And that's what I did. Like I asked ChatGPT and Gemini AI like about their data. I mean, you can definitely search and get to know like where their data comes from. But if you ask Gemini AI, so it gets its data from publicly available web content and the license data and everything that the Google provides it. So that's where the Gemini AI gets its data from. Where does the ChatGPT get its data from? So most of the training data and everything that ChatGPT, the OpenAI hasn't revealed, but yeah. So basically, there's huge amount of data, like terabytes of data and billions of parameters that these models are trained on. So they can definitely help you in like your coding process, like optimizing and speeding that up. So in terms of like accessibility, if we talk about how generative AI can help you in accessibility, so there are a couple of like the things that we need to ask before we try to use generative AI for accessibility is if they know the latest accessibility standards. And if yes, like how much and how accurate that is. So I asked that question to ChatGPT and Gemini AI again. And if you see, like they do have access to the latest accessibility standards because they can access the publicly available web content and the WCAG guidelines as well. So this was ChatGPT's response. And if you see, this is Gemini AI's response, like they do have access like November 2023, the WCAG guidelines. So now that we know they have the access to these guidelines, and if we give them a prompt that like specifies that we are looking for this WCAG level or this guideline for this particular use case, so I think they will be able to for sure give you good results. And that's what I did next, to ask about some of the widgets, if they are accessible or not. So this is what ChatGPT's response was. So it explains you like different things, like if the color contrast, like because it knows a lot of things already, accessibility guidelines, so it will check your code and tell you about it. And then I asked Gemini AI as well. So it gives you suggestions, but when you are coding, I mean, it's not very optimal like for you to like every code part, like you go to AI and ChatGPT and ask about it. So the question now is, can Gen AI help you in writing accessible code? The answer is yes, but if you are smart enough not to trust every answer you receive from it, so humans are obviously smarter than AI, and they will always be. I mean, AI can be trained on like tons of data, but there still will be a lot of things to consider. So the answer is obviously yes, it can help. But now how? So there are multiple tools, I mean, you must have used for your, there are a lot of coding assistance tools already, GitHub Copilot and ChatGPT and Gemini AI in itself, like you can go to their chat interface and like ask questions and stuff. But if you want to do something like this in Flutter, so I built a very simple VS Code extension to demonstrate like how you can use Gen AI. I'm sure there can be a lot of things done with it, but yeah, that's what I'm calling it. It's called Flutter li.ai. It's a VS Code extension, a very simple one. It is powered by Gemini AI. So let me give you a very quick demo. And I'm not doing a live demo because live demos always go wrong for some reason, especially when, so it's a recorded demo. And let's see what it's doing actually. So there are a couple of examples here. So mostly I wanted to make it very simple for the presentation. So I've taken like some examples like this icon is there, and on VS Code, if you want to use this extension, and then you can, for each thing, I have created a command. Like for adding semantic labels, you select that snippet, and then go to that command, and it will add it. And you can see for the image, because asset images it cannot access, but it can access the image from internet. So it will now label it according to the image. Like if it's image is like if it even numbered like 6 or 7 or something, because it has access to that image. So it will be able to replace it with the semantic label, which is after seeing that image itself. So it's a very simple thing right now, but yeah, there can be a lot of things done to it. It does not have the context of the whole project, but just the widgets itself right now. And for every accessibility like feature or guideline, it works that way. But for sure with the prompt, and I'll be talking about the prompts and stuff, because that's the most important part. So how does it work? So basically, it uses a Google AI SDK and the generative AI. The code I will be sharing that later. But I think the most important part of this process, like when I was trying to build it, was the prompt, because prompt is very important. And my initial prompt looked something like this. So I just asked it to check the Flutter widget if it has appropriate labels for accessibility or not, and I gave it an example. And then I was wondering why it's not working that well. And I was thinking maybe the model is not that good. But the thing was that my prompt was not good at all. And then I went to Google's documentation. They have some really nice documentation on how to create good prompts. So this was my final prompt that gave me better results than the first one. And if you see, I can go through one by one. So the first thing is the persona and objective. So I let them know that they are a Flutter developer and they need to enhance the accessibility of the app. And this is for the semantic labels. So they need to have the context. And then I provide the instructions. They have to review the widget code, and then they need to check if it has a semantic label or not. So those are the instructions. And then what are the do's and don'ts for them to have better context, and also a little bit about WCAG guideline. And then the output format. So I asked them to replace the widget with the accessible version of it. You can do a lot of things with it. For one of the things like color contrast, I didn't want to replace it because color contrast is something that it depends on the design, right? The UI part. So it won't replace, but it will suggest that the color contrast is not good. So it will just add a comment just under the widget. So prompt is very important. So this is a good format of the prompt. And there are some really nice AI prompt samples that you can access on Google's documentation. So yeah, now if I just go through a little bit about how the VS Code extension works. So for every user, they can put their own Gemini API in the settings, and it will be basically their own API, and no one has access to, they will be using their own API. They will be paying for it if they are using the pro models and versions. So yeah, so it's using Gemini Pro model, and you can change the models here. And basically, it selects the text, and then it adds it to the prompt. And this is how the prompt is generated with the whole text. And then it is passed through Gemini API. So that's basically how it works. In the whole experiment, I felt it can do a lot better with if it has more context and a better prompt. So if you want to, you want the API to analyze whole piece of your code. Maybe you can give it a better prompt in terms of like it has to go through all the widgets and it needs to replace each widget with the accessible version of it. And you can obviously fine tune the model with more examples. That way it will definitely give better results. So yeah, that was just a quick example how we can use the power of AI and Gemini API to write more accessible and more accessible code and make our apps more accessible. The pros and cons of using Gemini for accessibility, I would say it definitely speeds up the code writing process. And it will make your apps more accessible if you use it in the correct way, and the consistency, because it's AI. I mean, everybody writes code differently, but for AI, I feel there will be more consistency and standardizations, because everybody writes code differently. Like my teammate would write something in a different way, but I think with AI, if you train it that way, or like the model is trained in a way, then the code, like everything will be more standard and more consistent. So those are a couple of the pros. And if I talk about cons, then obviously it will need a human eye to verify everything if it's accurate or not. Ethical and legal issues can be there as well. So I showed example of like image labeling, the semantic labels. So if model is like, there can be bias in that. So for sure, it might not give the best results. But yeah, it totally depends on the prompt and the training data and how, if you have fine-tuned it in a way. So yeah, that can be one of the cons. And also the complexity, because it doesn't have the context of your whole application. So that can be an issue as well. So yeah, those are a couple of pros and cons. For sure, you can use Gen AI to make your apps more accessible, and it will speed up the process. And yeah, that's what I wanted to cover today. The code extension is not available for everyone right now because I still want to work more on it and add more features to it. But I'm planning to make a open source like GitHub repo soon. And I would love everyone to, like, if you are interested in something like this, and to reach out to me, and you can follow me on Twitter, and we can connect and see how it can go. So yeah, now I want to conclude my talk by saying, for people without disabilities, technology makes things easier, but for people with disabilities, it makes things possible. And that's the message that I wanted to give. And that concludes my talk, and I want to thank everyone for joining me today. And I also want to just thank my friend I met last year at Flutter and Friends. That's the whole concept of Flutter and Friends. You make new friends, and she's here with a Flutterista in her tummy, and I'm really thankful to her for joining me this year. And yeah, that was my talk, and thank you very much. So, any questions? Yeah. Yeah.
Can you
Yeah.
repeat the question for the stream?
Yeah, so the question is about the pricing, because we are using the API, and also about using the semantic widgets directly instead of just adding the semantic label. So the first question about the pricing, I would say, because everyone will have to use their own API, like API key. So they are going to pay for it. I would say it's the API pricing, the pro version, or I think I'm not quite sure because I didn't take the advanced, Gemini advanced, but it's usually around, I think, $10 pounds or 10 pounds or something, 10, 20 pounds. So that's what you're gonna pay, and you will obviously have access to Gemini API for other works as well, not just for the extension. But yeah, the second question about the semantic widgets, if you want to use the semantic widgets directly. So I would say because the examples that I showed were based on like my prompts. So if you want to have something like that, it will depend on the prompt. You can create a prompt and add a command for it. So basically, I made few commands for a few of the things, like replacing the, checking the accessibility labels, or checking the contrast, or like the text scaling. So I created those commands, and I can add more commands to it. So that's the plan. So yeah, you can obviously do that.
Any more questions? All right, then let's. Oh, there was. Sorry, there's such a bright light here. Yes, what was your question? Okay, no, maybe there wasn't a hand there.
There.
Oh, over there. So the question is whether the AIs are good enough now for you to be able to just upload an image of your app, and for the AIs to tell you if you have contrast issues, etc.
Yeah, I think so, because you know, like with ChatGPT and Gemini AI, you can upload an image and even ask what's in the image or what are the colors being used. So if you want to do that, like I showed an example of the image that was coming from internet, like the image, the asset, it wasn't the asset coming from the assets, or like the, so I was able to like give it a prompt that if the image is from internet, then it needs to check what the image is about and then label it accordingly. So yeah, of course, like it totally depends on the prompt. Like if you give it the prompt to do something in that way, like it has to check an image for the contrast, like with the background and the foreground, then it will be able to process that. Yeah.
All right, any more questions? I will look closer over here now too. No, doesn't seem like it. All right, thank you, Akanksha.
Thank you. Thank you, everyone.
And now we'll have a 20-minute break, and down on the other stage it is, let's see, is there something going on there now? It's in the middle of a talk there now. So in 20 minutes there will be Code Meets Art from Roaa up here, and a closer look at the blur effects in Flutter at the studio stage. So see you in a bit. All right. I hope you enjoyed the little pre-presentation art going here with the camera. You will be able to see it again in the end, I think. Yes. And you will get some explanations of how these things work. Yep. So give it up for Roaa, the code art magician.
Thanks. Welcome, everybody. I think, therefore I am. Famous words spoken by a philosopher called René Descartes, who was in a time where philosophers were pondering the question of existence. In 1644, he had a theory that the universe looked like this, entirely filled with elements of different sizes circling around each other in vortices, with the sun in the center. And those vortices were also used to explain forces like magnetism. That notion of vortices and his ideas played a very important role in future development of cosmology. In 1854, there was a severe outbreak of cholera near Broad Street, or now Broadwick Street, in Soho, London, England. This outbreak happened during a worldwide pandemic, and it was in the mid-19th century. It was known for an investigation led by a physician named John Snow. No, I will not make jokes about that name. And this physician was the first to hypothesize that the origin of the disease was not actually particles in the air, but was in fact drinking water contaminated with human waste, due to how sanitary facilities, or lack thereof, were functioning at that time. In his investigation, he laid out a map that you see here, and identified, this is a map of the street where the outbreak happened. He identified the number of death cases in different residences, which are the black lines you see on the map, and he located the individual water pumps that people were drinking from. What he did in his investigation, he actually did a lot of walking, a lot of investigation, and please, a disclaimer here, I'm not a historian, so take my explanation with a grain of salt, but basically he did a lot of walking to measure the walking distances between residences and specific water pumps, and was able to identify the exact problematic water pump that was causing the disease and got the city to shut it down. It did not make a major effect at the time, and most people did not believe him, but his work greatly influenced how public health and sanitary facilities were improved later on. Both René and John Snow, although for very different purposes, their work involved coming up with what is now known as the Voronoi diagram. And today, we're not going to investigate the origin of a viral disease or figure out how the universe looks like. Today, we're going to use the Voronoi diagram to create art and use algorithms to work with in the application of the arts. And our canvas of choice is Flutter. And what I want to explore with you today, using art, is a traditional art technique called stippling, or stipple engraving. This technique involved artists. It dates back as far back as the 15th century, and it involves artists meticulously handcrafting dots of various thicknesses and colors and patterns to create images. And it had many applications in many fields, including printmaking and scientific illustrations. And today, we're going to replicate it with algorithms and code. So how do we approach this coding task? We're going to break it down to three main goals. The first goal would be to be able to process an image and read each pixel's color in a format readable by Flutter. The second goal is to lay out random points, which will be our seed points or coordinates, in a random distribution across a canvas. And the third and final goal would be to move those points in some way based on some parameters to stipple the underlying image. So, to tackle our first goal, we're going to learn about image bitmaps. Take a 3x3 image, for example. In memory, it would be stored as an array of pixels, or array of bytes, where each item represents the red, green, blue, and alpha colors. And the whole image is stored in a list where those values are consecutively displayed. The way we access that in Flutter is you simply use the root asset bundle to access an image and use the byte data to read it and use some helper methods to access the image's buffer, which you can later use to get the exact color of each pixel using the get unsigned integer 32 list with, for example, here we're looping over an entire canvas and the index here is where the pixel should be, but to access it you need to multiply it by 4 because each item stores 4 values. This gives us the RGBA color, however Flutter uses ARGB colors, so you need to do some byte manipulation and then you can use it in your canvas. Okay, we achieved the first goal. That was quick. Second, we have to lay out the list of randomly distributed points. For this purpose, I want to talk to you at this point about using the Dart typed data library. The typed data library provides you with memory efficient types that have minimal overhead and allow you to deal with very long lists of large amounts of data efficiently. And the way we're going to initialize our seed points is using a float32 list, which is a 32-bit list storing floating point numbers, and it will be storing the values as xy, xy, xy consecutively, so its length will be the number of the total points multiplied by 2. And the way we're going to store those values is looping over that length, incrementing by 2, and storing values randomly distributed on the width and height of the canvas. And now I can use the Canvas's Draw Circle API to actually draw a circle for each point. At this point, we have this randomly distributed number points. We achieved the first 2 goals. The third goal, to tackle it, we're going to be learning about algorithmic art. And to be able to understand the algorithm that we will use to create that effect, we have to take a step back and dive deeper into the Voronoi diagram and other concepts. When dealing with points distributed on a plane or the canvas, the Voronoi diagram is a very handy tool. As you saw earlier, it divides, this does not have a laser, okay. It divides the plane or the canvas to regions based on seed points, such that each seed point's region has the points on the canvas closest to it than any other point. So if you very inefficiently want to implement this, you would loop over every pixel in the canvas, compare its distance to that seed point, compare that distance with the distance for every other seed point, and then create that. Kind of like how Jon Snow walked for every pump to measure the distance. Of course, we're not going to do that. There are multiple algorithms that already achieve that, and there's actually, this is not working now. Okay. There's actually a Voronoi diagram package on PubDev that uses FFI with Rust to implement an algorithm. However, I want to have more control over the code, and I want to stay on the Dart side. Thankfully, there's another approach to implement this diagram, which is another concept called the Delaunay triangulation. The Delaunay triangulation works like this. Given a set of seed points, it creates triangles that in such a way that the angles are maximized and every circles passing through every triangle does not contain any other seed point. So you can see that when I increase the number of points, those circles pass through a certain triangle and they do not include any other point. This maximizes the angle of each triangle and avoids very thin ones. The Delaunay triangulation has many applications in many fields, including generating meshes and modeling in 3D modeling and for terrains, facial recognition, this stuff. Thankfully, there's a package that does that, and it is a Dart package created, I think, by a member of the Flutter team that implements this, the Delaunay triangulation with an implementation adapted from the Delaunter JavaScript library. The way you can use it, you can look at the class initialization, and lucky for us, it takes a float32 list, how convenient, of coordinates that you can use. So we can generate our seed points by a handy little function that generates randomly distributed points, and we can initialize the Delaunay and call update, which is where the algorithm runs. Now, I don't want to get into the painting of the Delaunay. What I want to get to is that the Voronoi diagram is actually the dual graph of the Delaunay triangulation, which means that every edge, every line perpendicular to every edge in the Delaunay triangulation is an edge in a Voronoi polygon. So the package does not include a Voronoi implementation. I did my own, which is definitely not production ready, but it is based on the D3 JavaScript library, and it works for now. Basically, I extended the Delaunay class and did the calculations that the Voronoi is based on. What matters here is that the Voronoi takes bounds. It needs to know the canvas size and gives us a list of cells that has offsets that we can loop over after we initialize the Voronoi and use the canvas's path APIs to draw these polygons. Now, at this point, wrong order. At this point, the Voronoi diagram is already great material for creative coding. So you can, for example, manipulate the initialization of the seed points in a grid way, and you get this. The points look like this. The Voronoi diagram creates some patterns. You can experiment with colors. You can experiment with stuff like that breaks, yes. And yeah. You can also experiment with spiral patterns of seed points. I'm going over this because it's just some boring math. And this would create such patterns that can look interesting. And you can animate. So this would create some cool effects. Okay, we achieved the first 2 points. And we went over the algorithm that will help us understand how we will achieve the third. And now it is time to explore it. The algorithm we're going to use is called Lloyd's algorithm, or also Voronoi iteration relaxation. Don't worry about those naming, it's okay. And the way it works is, given a set of seed points, you calculate the Voronoi diagram, and then for each polygon, you calculate the center of the polygon and linearly interpolate those points by a factor to the center, and then calculate again until the dots reached a certain amount that is close or at the centers. The code, very bare bones of the code look like this. You initialize the Delaunay and Voronoi in the calculate function. You calculate the centroids with some boring math, and you update the points by calling a handy function called lerp points, and you calculate again. In the lerp points, we basically just call lerp double, which is a built-in method that provides a value between two values by a factor. And you can, for example, run the update method inside a ticker, which will allow you to run this simulation constantly. This is how it would look like. Now here, the red dots are the centers of the polygons, and the black dots are the origin, and the algorithm runs like this. The goal here is to evenly space out seed points, and you can see it more clearly with a lot of dots, that it just finds an even distribution of large amounts of points. And it has also a lot of applications in many fields, including optimizing and improving the mesh generation that was mentioned before. Now, this algorithm can be adjusted to be a weighted Voronoi stippling to achieve that. And the way it basically works is, instead of finding the center of each polygon, you would actually loop over the pixels inside each polygon and calculate their color and average that and choose that as the center instead of the center of the polygon. So our algorithm will look something like this. We will loop over all the pixels, and for each pixel, get the color and accumulate and calculate its brightness to get the value from it, and accumulate those values for every polygon and then calculate the average. And that is the new centroid. And this is how it would look like. You might recognize this guy. This girl, sorry. You can also calculate the color and show it. And you can make the thickness of the points also depend on the weight of the centroid, so it would also look different. And you can experiment with different patterns and dot shapes, so you can make it circular. And yeah, that's image stippling achieved. Now, for me personally, there's a special place in my heart for art installations that make the viewer a part of it. So today, I wanted to make you, lovely audience, the content of the canvas. And my first step, or the simplest approach to do this in Flutter, is to use the camera. So I'm simply here using the macOS camera package and replacing the image, the static image that we went over, with an image coming from the camera image stream. And this is how you get this. So can we dim the lights here, please? Yeah, thanks. So we can also experiment with some stuff. I can increase the dots, number of dots, see how hard the CPU can go. And this increases the maximum and minimum sizes of the dots to make it, yeah, more condensed. Okay, let's see if we can handle more. Oof. Can you turn on your badges? Let's see if that makes a difference. Yeah, we can also try it this way. Oh, yeah, that's more obvious. Okay, I just hope my laptop doesn't turn off suddenly. We can also see the Voronoi shapes. So this is like the polygons themselves. We're just using their dots. And we can do this. Or black and white. But yeah, that doesn't work in this scale. Oh. I'm so sorry. Yep. So this is it for the demo. And now I want to address some points, which is some questions. And first, why creative coding? So in this conference, today and tomorrow in the workshops, you will probably be learning about useful stuff that you will use in your day-to-day careers to build better apps and software. This was not the case for this talk, at least not directly. However, I strongly believe that combining creativity with algorithmic and analytical thinking can produce fascinating results. Because when you do that, you get the side effect of becoming a better developer thanks to creative learning material and topics you're exposed to for a particular project. So the topics we covered today included image bitmaps, which is a topic that would be useful that might be useful for any application. We learned about memory-efficient data structures, using algorithms to create art, the Flutter Canvas API, very briefly, and the Voronoi diagram, which is something you might think you will never ever need in your entire life, but it actually has an application in the user experience field. For example, in this scatter plot, you can implement a Voronoi. So if you want to hover over the dots to find more information, it would be kind of difficult for smaller dots, and the user experience can be drastically improved with a Voronoi diagram, where you would determine the hover area of each point and allow better user experience to dealing with this. And lastly, it's fun. When you do creative coding, you have fun with, like, in the creation process. So in software development, bugs are most of the time catastrophic. But in creative coding, bugs look like this. And this. Or this. That was completely by mistake. That happens while you're working, and you can't recreate it like this ever again. It's just a bug. Yeah. And yeah, I want to give a shout out to the Flutter deck package, to Mangerdas. I don't know where he is. The slides are created with it, so every interaction you saw was possible using it. So great shout out, and yeah, that's it. Thanks. Any questions? Leave this here. No.
Nice. I saw videos from in there from the audience. Very cool.
Questions? No? Oh. Yes.
So the question is whether your code is open source, right?
It is, but I need to clean up. Yeah, but I will share it. I don't know how, but.
More questions?
Yep. Yes, so there's a repository that includes the slides and the demos, and I will share it on my Twitter account, which I should have conveniently added a link to, but I didn't. But
you can put it on your badge, and everyone can come and scan it.
Yeah, exactly. I don't have it now. Yep. Yep.
I mean, you have so many awesome things.
Which things?
Like this or like the other graphs. Did you really plan on making them exactly like this?
So basically, I was just exploring creative coding content, and I saw this algorithm. There's a channel called the Coding Train. It has content for P5GS. It uses the same algorithm, which was like inspired of, but that was not the initial goal of the talk. It also led to this by accident. So this and that. Okay.
No more questions? All right. Give a big round of applause for Roaa.
Thank you.
And I think we have a few minutes until the next talk. Or wait, now it is maybe the panel. I forgot my phone in there. Yeah, it's the panel in 5 minutes, I think. Yeah. Yeah, it'll be in about 5-10 minutes when the other stage is done down there and when we have rigged up stuff here. Okay, it's 20 minutes. Okay, then let's go with 20 minutes. Sounds good to me. I forgot my phone in there. It's charging. See you in a bit.
Adding even more to room. Why should a person change when he writes a book about it? Of course, it's fine.
That's why he stopped having.
We just took them off.
All right, everyone. So, are you still hanging in there? How's the energy? Hey, that's what I wanted to hear. Awesome. Thanks for being such an amazing crowd today. So we're gonna close things off with a panel discussion, just as we did last year. So we'd like to welcome up the panelists on stage. So we have Anna Lushenko, engineer at Tide. We have Ezra, organizer of Flutter Berlin. Simon Lightfoot, CTO at Dev Angels. Greg Labenz, whom you all know. And last but not least, Majid, AI engineer at Microsoft. Welcome, Majid. New job title since last time.
Yes.
So I first wanted to talk about growth, and in particular, Flutter's growth. So we can now pretty confidently say that Flutter has overtaken React Native in terms of new projects. Yay. And as also, and as you can see on the crowd here, the Flutter community is growing. And it's now starting to really mature to the point where big companies are daring to take the leap towards Flutter. But now we're kind of also entering a new era, an AI developer era. So most of you probably know about VS Code Pilot, which Majid is working on as well at Microsoft. And there's also new types of IDEs like Cursor. So who have heard of Cursor before? Okay, a good amount of shown of hands. So Cursor is an IDE which is like generative AI first, where you can basically tell it what to build and it's going to build it for you. And in those kind of circumstances, do you think that all of a sudden now React Native is going to have an edge again because these large language models have so much more code, past code to train on? What do you guys think?
Who wants to take this? I mean, you're also saying that, are we going to be put out of jobs? Is that it? I mean, I've tried GitHub Copilot, and I find it gets in my way when I'm coding. Like, it will suggest stuff that's great, but equally it will suggest things that are wrong, right? Like, it will just invent functions and methods and all sorts that just don't exist. So, for me, it's great to have the tooling, but you have to know what you're coding as well, right? So it's great as a co-pilot, as something to assist you, but I don't think, you know, we're not there yet for sure, that you just say, build me this, and it'll be flawless, right? So you're still going to have to understand what you're building to actually finesse it.
So, but do you think that React Native will have an advantage? Will we see that, like, will you get correcter results trying to create a React Native app with Flutter or with AI compared to doing an app with Flutter using generative AI?
It's hard to predict there, but it does seem, it stands to reason that it might, if they're able to train it on 10x, 100x. I don't know what the multiplier is of code in the wild between React Native and Flutter. I think that certainly stands to reason. I don't know if, to Simon's point, if any of them, any LLM on any language currently rises to the level of being able to give you a complete enough answer where the human can just check out. And if you're getting 80% accuracy on React Native and 60% accuracy on Flutter, which are of course numbers that I just made up, then in some sense, those are pretty similar because they're both requiring a proofreading pass from someone who can bat near 1,000, which is sorry, terrible sports reference. Someone who's near 100% on their own as a human programmer. So I think the big question there, which is really the billion-dollar question in tech right now, is whether or not LLMs will get to the point where they're spitting out code that really doesn't need a person to audit. And I don't know if you want to talk about generative UI stuff at any point, but that's a paradigm that is the center of a lot of research and really only works if the LLM is actually writing nearly flawless code every single time.
So that's a great point. Let's circle back to generative UI later. And I wanted to ask Majid as well, like looking at the horizon, how do you think that this will evolve, and where do we see these tools being used in regular development teams?
I've been thinking about this question. First thing, let me have a disclaimer here. Whatever I say, it's my own opinion. I have to say this. So I feel like so far, if you look back in 2 years ago when these LLM came and then afterwards different models and what right now we can do, in the beginning, so exciting, and then it gets a bit less exciting because we know what they do. And then if you look at it right now, I think that the path that we are going in this area is that we're getting away from more of this is a model that is trained and is ready for you. Just go and type and get whatever you want, in a path that, okay, so we have some kind of model pre-trained, get this and build a custom model on top of this and have a RAG application or whatever else, and then train the way that you want that LLM to generate code for you, to be more customized. And if you look at like recent, all of these AI tools and models that are coming, like I don't know if anyone knows GitHub models, for example, which technically you have access to many different LLMs and SLMs and so on. And then you can take them and then maybe build a RAG application and just train your data as well. And, and then you have a lot of these AI enterprise tooling that can really, you can feed your own data and train the model in a way that you want the model to generate the code. So I always want to bring this example when we talk about Copilot or these kind of generative AIs. It's like, the Copilot name, I really like it. It's just because it's actually a Copilot. So if you are right now, if you have a Tesla, if anyone has a Tesla, and if you put on the autopilot, after like 30 seconds, it says, put your hand on the wheels. You are the pilot of the Copilot. So that means it can go somewhere, but if you don't put your hand on that, after 2 minutes, you don't know where you are. So that's the way I think we're going right now, and I hope the tech industry goes. Like we kind of looking at these AI tools as a tool, really, that we train them, we educate them. Like we're talking about bad code that is generated, but you know that you can actually educate Copilot to write the code that you want in the same project that you are. Like you can literally say, Copilot, hey, give me exactly this error handling, which I did in the same file in this project or another file,
That's a great point, Majid. So have anyone of you been experimenting with using Copilot to do more things in your companies? Araujo?
So personally, I'm using Copilot, GPT, Cursor. I'm just like giving a shot to everything what's going on. But Cursor, maybe my ideas can be a little bit not so objective because I'm currently using the free version, so it is limited also. But what I also see is like multiple points we do have there. One of them is, I think, losing the relevancy while they are suggesting the code. Because, like, for example, I am, again, these are all my own opinions. I am specifying what I want to do to, like, Copilot with, like, marking the files, like, everything, relevance, and so on. Then I'm getting a suggestion of code. Then I want to chat about it like I'm used to in ChatGPT, but then it's gone. It is just like, it started chatting me back like I never told the things before. It really starts like a new conversation, and I am having trouble going through them. And then when I also tried Cursor, yes, it gave me better relevance because it was kind of give me the option of, okay, chat with your code base. I noticed that it kind of recognizes my code base and pattern more. But when I also switch it to like a little bit upgraded version like ChatGPT 4.0, then okay, again, lost the relevancy while suggesting the code after a couple steps and iterations. And what I noticed is, I think as junior people, mid-level people, I think it's great to understand the code and how it's working and so on, because personally it is helping me a lot, and it is probably reducing a lot of things that I'm going to go and ask my senior about, okay, how this is actually working? It is helping me a lot to grasp what's going on. But also some of the code recommendations we are getting, like, mostly needs to be polished, like your version. Like we just want to say, like, there is a better version of this. Like, can you just cover this edge case? This could be more optimized. Can you do it better? But I just know it because I had to do it in another language before. And it is not giving me like best suggestions in the beginning. It is just solving my problem in a normal way. That's what I think.
Thanks, Asra.
So, speaking of just a step back about comparing React Native and Flutter, I think we should really not focus on comparing, but ask ourselves, is it good enough? It doesn't matter if it is better in React Native, if it is good enough in Flutter. And with this, when I use this kind of tools, I constantly find myself reviewing the code. So with these tools, as opposed to usually think forward what I want to do and then how I will do it. Here, I quite often find myself being led by the ideas of the tools instead of having my idea first and then implement it. And I think it is, this experience is different for different level of developers. As a senior, I kind of can do it fine, I hope. For juniors, it might be even misleading sometimes, depending on the code base it was trained on. And once again, going back to the Flutter versus React Native, even though React Native may have a bigger code base to be trained on, Flutter is also quite open source, has a lot of projects, so it may already be good enough. Depends on what tasks we say it is good enough. As a copilot, it may already be good enough. As a standalone tool, I don't think it will ever be, sorry.
No. Great points. I guess we just have to wait and see. So, Craig, you mentioned generative UIs, and when we talked backstage, you also mentioned that Flutter is in a really good position to be used for generative UIs. So, can you expand on that?
Yeah, so for anyone who's not familiar with the term generative UI, I don't know how broadly it's talked about, but obviously right now LLMs for the most part communicate in plain text with us all. But another thing that you can do with plain text is write code instead of paragraphs and then just render that code. And there's a pretty big push across Google to figure out how to enhance the experience of talking to Gemini. I'm sure all the players are doing this, you know, Anthropic with Claude and OpenAI with ChatGPT, to have the system basically just return an interface. So if you ask it, what are the best things to do in Stockholm, it might not just give you a plain text list, but it might give you an HTML page or a Flutter page or whatever. And that's going to have some images and links that you can click through, and you're just kind of off and running with this richer experience. And the angle that the Flutter team is taking within Google to try to position it as the ideal runtime for that is that Flutter uniquely would allow Gemini to master just one UI toolkit. It's obviously the exact same value proposition that has brought us all here. But yeah, so one of the things I said about that earlier is that that whole system is not very, parse error or bug tolerant, because then you just immediately see nonsense or it doesn't run or whatever. And so I think that is really pushing the envelope. I believe Gemini doesn't really write code with parse errors. It might have a build method that invents a widget. It'll definitely do that, and that is a kind of compile error, right? But it doesn't miss curlies. It doesn't. It's getting there, and I think it's just hard to predict whether it will actually get to that goal line. But yeah, generative UI is a huge goal of Google's, and again, probably all of the big players. And Flutter's trying to be the way that Google does that.
And I think that would be really, really interesting to see when we can see how it turns out. So let's switch topics a bit. So last year at this conference, in this panel, we also talked about the job situations for Flutter engineers. So Anna, you were here, and Majid, you were here as well. So what are your current outlooks on the Flutter job market right now from what you see around here in Europe?
Maybe I can start. So, because I was looking for a job actually in January, so it's quite new to me finding for a job. I think one thing that's happening right now is, in general, job market is tough right now. It's not about Flutter. Let's clear that out first, because since January until March, when I was applying different companies, I couldn't find even a good title to apply. Not Flutter, just anything, This is very tough, economy and everything that we know right now. But then, when I looked at the Flutter jobs, in Europe, actually, I found quite a lot of jobs. What the problem was, all of them needed senior, very senior level, And a funny thing, many of them rejected me, so it's funny as well. I don't know what senior means, but what is interesting is that there's a lot of jobs. It probably doesn't pop up in many list of jobs for folks because it's in a level that people are not looking for. So I found these jobs definitely in Europe. It's definitely growing compared to last year. I think last year was worse, to my opinion.
Yeah. And I can also share that sentiment. I think anecdotally, from what I've seen here in Sweden, there are multiple big companies now looking to kickstart their Flutter projects. And because of that, they're looking for senior people because they have no internal knowledge of Flutter. Yeah. They just know that, this is a tech that we want to get involved with. So Anna and Esra, we talked a bit about this as well behind the scenes. How does the situation look like for juniors, and what can be done about it?
Yeah, it's quite a challenging situation for juniors still, the same as it was last year. For instance, myself, I have a friend, a junior Flutter developer, and she is going in circles through the interviews for a couple of months already. In Ukraine, but I think the situation is the same in Europe, and clearly companies who only start to adopt Flutter require senior expertise. But I think they also need more hands actually doing stuff, which they can be advised how to do. So companies definitely could look into hiring juniors and interns to help out those seniors to actually produce more features faster.
I can give a bit of a side of this as well. I think there's a value proposition here. So from a perspective of a large company, they'll want to employ juniors because they can be trained and become an asset to the company. Whereas if you've got a lot of small tech startups, they need someone to come in with a certain skill level. So for example, with Flutter, because it's cross-platform, you want someone that's got experience on Android, on iOS, as well as Flutter. So they can then go into the depths, maybe create plugins, create very specific things that make their product work across the broader scope of what you can deliver with Flutter. And I think the problem is that that is a skill set that's quite high, and there's a limited amount of people that actually have that skill set right now. So it's just in the best interest of the community as a whole to learn the specifics of the platforms you're trying to deliver Flutter on, as well as Flutter itself.
Yeah, I think that's a great comment as well. Do you guys see in a foreseeable future, like where we're going to see job ads for senior Flutter engineers without like a native background, where the plugin ecosystem and everything you need has reached a certain amount of maturity so that you can basically stay in Dartland without hardly ever going down to native land?
I don't see that happening per se. I think you might find team sizes getting larger where you've got an Android-specific person, you've got an iOS-specific person, and you've got your Flutter people. Does that kind of make sense? I think there's a joining there that can actually take place. So a company that's saying that we're building a Flutter app, what they actually are asking for is someone that's Flutter and having those skill sets in those other platforms as well. So there'll be a larger team size, not just like one person working for a tech startup that's expected to know everything.
Yeah, I share this sentiment as someone who works in the fintech industry, where our banking app uses a lot of native dependencies for various features. We constantly find ourselves in the situation where this or that library doesn't work on this or that platform, and those are developed by third-party vendors, which we have limited influence on, and they may not always provide Flutter SDKs, but rather natives. So we constantly have to keep this skill set of native developer.
So personally, I also have some multiple points to expand on this one. And first one actually starts with the job market. And as a person who doesn't have a native development background and switching area and using Flutter in the first place, I had different, let's say, milestones in my life while looking for a Flutter job since 2020. Like, first one was looking for first mobile development app, and then it was for the relocation, and it was for relocation again. So I also had a chance to go through a job market multiple times in different positions, in different variations, while market is evolving. And how can I actually say is, in the beginning, like around 2000, for me, 2020, 2021, we had startups like, yeah, you would get paid a little bit lower, but they will also give you some time to learn about it, and you will actually, like, startups were also like a door to learn and step up as a junior in the beginning in the Flutter. But right now, what I also see in the market, I see a lot of job openings, a lot of like new developers, a lot of Flutter developers, but there is a gap about like finding a match, like fitting what is going for. And I actually have 3 points. I actually noted 3 of them here so that we can actually talk about it and not miss it. And one of them is, even we had one of the talks, it was related to background processing. And like, I think people are looking for directly senior Flutter devs while hiring directly. And then we don't see like junior, mid to like people to raise and like learn, train on the way. I think it's amazing asset. But I think the expectations of the market is also evolved on the way. I started to see like lots of agencies showed up and started to put some MVP products with Flutter, and then it kind of started getting marketed like that. So it also gave people expectations of like super quicker deadlines, faster deliveries. Like sometimes we are even having like unrealistic deadlines for like, okay, we want to release this app in 3 months. Because we have an event, it will not be an app we're going to use later. We need this app in 3 months. Even as senior mobile devs, we are like, can we make it in 3 months, like bug-free, like it still is good in this front? And their budget is too low, even for us to like have hands-on seniors like do this. I cannot see we are also getting a junior on board and training it on the way, then it will be cost from our pocket even. We don't even know what we're going to do. So it is actually getting a junior harder to step up.
And maybe that's a reflection of like the bigger macroeconomic, like we talked about. It's hard finding jobs in any category right now, and that's why companies are really pushing the budgets down a lot.
There is another point to this. So Flutter's grown. So the people that I don't know. Imagine the first year Flutter came out. Maybe there was just 100 developers that were working with Flutter. The next year 1,000. The next year 10,000. The year after that, 100,000, million. And so because it's grown so much, there's a lot of Flutter developers that are maybe 1-2 years of experience, and that they're asking for the senior level, and this is going to take time for everyone to move up, if that kind of makes sense, for it to grow.
So, circling back to the, did you have another?
I will add something on this one. I think this is pretty great point, because once the Flutter is launched, then people are started to go for it, try it. We had early adopter developers onboarded in Flutter, and then Flutter also becomes something like, you know what, you can even start mobile development even if you don't know native iOS and Android. Let's give it a start mobile app development with Flutter. Then we had some newbies with no background information or native background information like me. I wasn't an Android developer nor iOS developer. I immediately started with Flutter. We started learning it all. It's good. So first couple years, it's good. You're 3 years developing Flutter, you can still find a job. 3 years developer experience is good. I'm talking about 2021, 2022. And then meantime, we had a lot of iOS developers and Android developers resisting to change and adapt to Flutter, and they were holding back to see whether Flutter gonna go better, what the Kotlin multi-platform will be, what the storyboards, iOS, what we're gonna do, and so they were holding it back. Then they see that, okay, Flutter is keeping going, let's adjust a little bit, let's see it more. And then when they switched to Flutter, then immediately we had, I think it's also good parameters that we had a huge gap between juniors and seniors, because then we started to have 10 years mobile development experience in Android, started Flutter now. Then as a 3 years experienced mobile dev, now in 1 year, there is a person bringing 10 years of experience to the table from Android and then adjusting Flutter now. Okay, we have lots of seniors also can do Flutter now from iOS and Android. So I think that's also one of the good parameters, how we end up with so many seniors and getting those people and requirements.
And when web launched, Flutter Web, there's a huge influx of web developers that came to Flutter as well.
Yeah.
It's augmented, but yeah.
Yeah, those are really good points. So I wanted to circle back as well to getting more Flutter native developers, people who start out building with Flutter as their first framework, Dart as their first programming languages, and getting them to a point where they can be senior and taking care of projects on their own. I think from a technical perspective, there's things we can do to ease that as well. So I know there are, tell me if I'm wrong, but there are projects where native APIs are currently being auto-translated to Dart. I think it's used in some of core plugin is starting to do it as an alternative to the federated plugin approach.
It's probably bindings for.
Yeah, exactly. I mean, so that could be a way to so you don't need to code Swift, you don't need to code Kotlin, you have access to all the native platform interfaces, but you do it in Dart. So you only need to know Dart, and then you can learn frameworks.
We're all waiting on macros.
Yep.
There's the stuff that you're talking about is exciting, and so for anyone who's not familiar with this, if you've heard of FFI, right, foreign function interface, it's a way to call code in a different language in your same thread. And there's also JNI, which is JavaScript native interface. And the Flutter team and the Dart team really is working on ways to, with very little effort, have probably via macro, but I'm not sure. Slava could maybe clarify for us what the actual pipeline and build mechanics will be, but to very easily generate some bindings for, let's say you want to use the camera and the camera plugin doesn't exist. Actually, it doesn't exist on macOS, so this is a real problem. But you want to use some API that you know exists on all the platforms you want to target. And So, okay, great news. You can just import camera.swift, import camera.android, which are of course made up paths. And then what the build system is going to do is generate FFI and JNI bindings so that you can call into those APIs directly from Dart. But the hidden complication is that none of those steps actually make those APIs align. They're still different. They require different parameters. They have different concepts. They have maybe different life cycles. They're still fundamentally different camera APIs that Apple and Google designed without talking to each other. And staying in pure Dart is great. You know, it's better than having to think about method channels and whatnot. But whenever in the past you've had to do one of those things, you've had to talk to native in either a federated plugin way or whatnot. The real trick is figuring out how to capture the full surface area of each of those native APIs in a consistent and single Dart API. And that challenge will still remain. Yeah. And I think that's more fun, right? I like the idea of figuring out a clean, idiomatic Dart API that wraps these different, you know, mutually exclusive, don't agree on anything camera APIs, just to run with this example more. But it's still a serious engineering challenge.
I mean, we have a problem, right, in terms of a lot of these plugins choose least common denominator, right? So the simplest functionality that can spread the platforms. And yeah, that's not where we need to go.
No. So we have to end on that final note, and let's give it up for all of our panelists. Thank you very much.
I wanted to flash back to Greg's keynote today, when a few first slides were talking about 20 years being in the market and then talk about mature and like being recognized, or you've been talking about that, about Python. And to just look at Flutter right now, folks, it's how many years? I mean, it's 10 years maybe at Google, but like in this community, maybe 5 years, right? Or more or less.
Yep.
And 5 years ago, me and Simon, look at like what? We had like 0 plugin. Yeah. There's nothing. Today, you just come and install a plugin and build an app and go, because it's coming. And then look at what Greg says, 10 years from now, probably a lot more. And 20 years, I don't know where I am, but I hope I'm retired.
Thank you, Majid. All right, so thanks to all of you for being with us throughout this day. And now we would like to invite all of the speakers up on stage for a speaker's gift.
Yes, and also one person from each sponsor should come up.
And all the workshop hosts.
Yes, and all the workshops too. We forgot them last year. Or we forgot you last year. Well, yeah, but I think last year you didn't get your speaker's gift here, right? Yeah? Okay. Så jag tänker vi tar inte ut kartongen för den är så jävla ful. Inspired by one of your gifts, actually. So you can start your badges, and I recommend to keep them off while you're eating dinner because they only have like 4 or 5 hours battery, and you really want them at the party later. But put them on now for the. You can charge them. You have a little charging cable in your swag bag. Yeah, yes, some speaker photos, and then we're going to have photos of all of us with the audience too.
So give it up for speakers.
Woo! And sponsors. Woo, woo, woo. And this is the lighting platform. All right, let's do the other way around. So now it's a picture of the whole conference with you two too. So stand up, everybody, and we all are coming over here too, and put on your badges. So that's I don't know, put them up in the air maybe, so we get some color in here. Ah, no. And then we say Flutter and Friends on 3. 1, 2, 3. Flutter and Friends! One more time. 1, 2, 3. Flutter and Friends! On 3. Thank you. And now some practicalities for the party. So please, if you can, try to leave your bags at the hotel rooms, because we have this strange law in Sweden now that you can't bring in big bags to big parties.
Oh, wow.
So as long as you can, please try to leave them there. Otherwise, we will sort it out for you. And for the party, it starts at 19:30, and we will be leaving. There will be multiple groups leaving from which hotel is it?
We're gonna leave from here.
Okay, we're gonna leave from here, from right outside here, and there will be multiple groups guiding you.
So the first group will leave at 19:00, and then every 15 minutes until 8 p.m. So 19:00, 19:15, 19:30, and 19:45. If you want to tag along to a group, otherwise, just go to Slaktkyrkan, take the green subway line down south. See you there.
And make sure to eat dinner before you get there. And if you feel that it's a little bit tight on time, like just come a little bit later. It's very easy to get there.